E D capital C O N T I.
Testing. Test. Okay, this works.
A module item list.
I don't know. The last stream hit 12 hours, I guess. I need to like set alarm on my phone.
Export name. String literal. It is a
I think like it might have been an hour over the 12-hour mark.
1. 2 static semantic
Oh well.
names. Import entries. The abstract operation imported local names takes argument import entries, a list of import entry records, and returns a list of strings
I'm waiting for YouTube to update.
by import entries. It performs the following.
There it goes.
Let local names be a new empty list. For each import entry record I of import entries, do a append I to local names 3. Return local names 6, 2, 1. 3 static semantics. Module requests. The syntax directed operation module requests takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Module empty. Return a new empty list. The duplicate exported names rule implies that multiple export
And I'll fix the description later.
syntax error. Additional error conditions relating to conflicting or duplicate declarations are checked during module linking prior to
So
any such errors are detected. The module is not evaluated. 68. ECMA International 2024. Module item list. Module item. Return module requests.
I think I said like at 4 o'clock-ish I want to be done with this in an hour. I think it took an hour and 20 minutes.
Module item. For each string name of additional names.
So I took a break for like 30 minutes.
A new empty list. Import declaration.
I don't know how much the last stream got cut off though. I think a lot got cut off.
Module specifier. String literal. Return
So I don't know.
SV of string literal. Export deck.
It prints a stupid list and it expands it.
So from clause. Export.
And now I need to like make another copy just because, so I have a copy. You never have too many backups
Assignment expression.
until you run out of space. Then you have too many backups.
2. 1. 4 abstract module records. A module record
And now I have to like tag the name.
is used to link the imports and exports of sets of connected modules.
The list name or whatever.
Only used when evaluating a module. The specification per
So this is a log position of highest bit list or whatever. And then benchmark wall time list. Benchmark CPU cycles list. So inside the macro, whatever, I needed to glue this, and then it's going to do these. It'll glue whatever I pass in.
specifications and implementations may define
And then I can simply just print the fucking numbers.
module record defines the fields listed in table 41.
And all of
At least those fields.
the field offsets will be pre-computed. Not pre-computed. Systematically computed. Exactly the same because of the macros. I could just make 2 more lists underneath this list. And I could finally speed test and benchmark assembly.
Environment. A module environment record or empty. The environment record containing the top level bindings for this module.
So it's like 6 o'clock. If I can get done
An object or empty.
in 30 minutes.
3. If one has been created.
If the mouse would just work, that'd be great too.
Associate additional information with a module. Table 42. Abstract.
If I can get done in 30 minutes, I'll be able to. Dang it, wrong screen. If I can get done in 30 minutes, I'll be able to finally speed test some assembly
exported from this module. Load requested module.
Printing the time is going to be annoying. I'm going to have to make like a loop. Get the average time. So I'll wait on that. Because I just want to like run some stuff. Get some kind of like idea of which is faster. So I'll do like the cycle count first.
Return null if the name cannot be resolved, or ambiguous if a
And then I'll deal with averaging the real time, because I have to subtract the time it takes to like get the time from the stopwatch, whatever, from the system timer.
Sensitively resolving all module dependent.
So I'll print like the CPU cycles in 30 minutes if I can get done 30 minutes. And I'll have some idea how fast assembly is. But that's not real time, so I want to print the real time after that. But that's going to take more time to like format and figure it out. And of course, computer's like dying on me. I should restart the computer.
Third, 370. ECMA International 2024 16.
And the bitrate is dying too. That's great. It seems like whenever the bitrate is dying, people are watching. It's really convenient because it's like whenever people are watching, it's exactly when the bitrate drops. It's really frustrating because it says buffering and like it doesn't play the video. So I'm gonna ignore that. If the video doesn't play, if it's buffering, I don't know. It is what it is. So I'm gonna try to get to work in 30 minutes. If I can get this stuff, this tag name passed in, glue it, tokens and labels, I will finally be able to benchmark things. So I'm gonna try to focus. I'm gonna ignore the bitrate.
To execute on completion of its asynchronous.
I'll pull up the screen to show that bitrate's lagging.
Executed and is pending top level completion. Evaluation error. A throw completion nor empty. A throw completion representing the exception that occurred during evaluation, undefined if no exception occurred or if is not evaluated. DFS index. An integer or empty. Auxiliary field used during link and evaluate only. If is either linking or evaluating. This non-negative number
Where's the stupid thing?
during the depth first traversal of the dependency graph. DFS ancestor index. An integer or empty. Auxiliary field used during link and evaluate only. If is either linking or evaluating. This is either the module's own or that of an earlier module in the same strongly connected component. Requested modules. A list of strings. A list of all.
So the bitrate, I don't know. It was perfectly fine for however long the last stream was. And then now it's doing that.
A map from the specifier strings used by the module represented by this record to request the importation of a.
So I don't know if it's lagging. I guess it's lagging.
Cycle root. A cyclic module record or empty. The first visited module of the cycle. The root DFS ancestor of the strongly connected component.
I'm gonna get to like finishing this up. Try to get done. And like, it's probably gonna take 40 minutes. It's 40 minutes. Everything takes so freaking long to do. So I'm gonna get started, whatever. I have to benchmark something today because this is so boring. It's taking so long.
Containing a top level await. Having an asynchronous dependency does not mean this field is true. This field must not change after the module is parsed. A sync evaluation, a boolean, whether this module is either itself asynchronous or has an asynchronous dependency. Note: the order in which this field is set is used to order queued executions. C16, 2, 1, 5, 3, 4. Top-level capability. A. Promise capability record or empty. If this module is the of some cycle, and evaluate was called on some module in that cycle, this field contains the promise capability record for that entire evaluation. It is used to settle the promise object that is returned from the evaluate abstract method. This field will be empty for any dependencies of that module, unless a top-level evaluate has been initiated for some of those dependencies. Async parent modules, a list of cyclic module records. If this module or a dependency has true, and execution is in progress, this tracks the parent importers of this module for the top-level execution job. These parent modules will not start executing before this module has successfully completed execution, pending async dependencies. An integer or empty. If this module has any asynchronous dependencies, this tracks the number of asynchronous dependency modules remaining to execute for this module. A module with asynchronous dependencies will be executed when this field reaches 0 and there are no execution errors. In addition to the methods defined in Table 42, cyclic module records have the additional methods listed in Table 44. Table 44, additional abstract methods of cyclic module records.
I don't know. I kind of have a naming convention. It is a very long naming convention for very long names. But this way, nothing overlaps. So I'm gonna try to rename the new shit to like list maybe. And then that way, all the defines that are like defined with the tag name for the list will all start with this token keyword leading word. I don't know, whatever you want to call it. Words are stupid. There should be a way to like define things by color so it will like look totally insane, or to program with like emojis. That would also be great. Like if I could like make like this. If I could make variables. Like a diagram. This is a diagram. It's not variables. If I could make stuff like this though. I need to get back on track. make like all these things. The color purple, like a purple square. And I could make all the other types. Like a red square. Yeah, I'm so bored. I'm gonna get back to work in any second now. And then like, I won't even need a type here. It's like this right here. It's the same base word, whatever. This is why names are stupid. I hate spelling things because I don't care about spelling. If I could just like tag things with symbols so I don't have to spell things, that'd be awesome. Do you know how cool it'd be to read a program like this? It'd be fucking awesome. Not having to type a name. And if I could have like, if these were like someplace, like if there's like a menu, I could like click plus or something to make a new one, and then like it alternated, it made a new color each time I use one. So you like click, 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 and then I make a new color. I use that color, and then like keep track. So like I could have blue, like a base of blue, whatever. And I could click like a down key to like expand. So if I have a base of blue, I click the down key here and make a new thing, whatever. I have to like click another key. Get to like add a property. So maybe the right arrow means property. So I gotta expand this category and add another property by clicking that. Then make these ones purple. Because it's not a name. That's my whole point. And then, okay, this is totally crazy. But if it had a name though, it doesn't look as crazy. It'd be really useful. You could have like name, type, prop, and maybe click the next here, or click the down to add like category, another category to like whatever the current category is. So you click down. And then you could give it like actual names. But then it would hold a symbolic reference. So like anywhere you change the one place, all the other places would update at the same time. Unless you like right click and like unbind it from whatever ones it's like tied to. That'd be great. That'd be awesome. And that'd be like, that'd be the best way types to manage type naming or variable naming or all kinds of things. But no, what we have is a text editor, and you just freaking type it in as plain text. You give everything a name and hope that nothing else is named the same thing because things overlap. So that's why I make really long names. But that's not how the world is. Oh, everything sucks. I'm gonna get back on track now. Or try to stay on track.
Ext is a module namespace exotic object that provides runtime property-based access to a module's exported bindings. There is no constructor function for module namespace objects. Instead, such an object is created for each module that is imported by an import declaration that contains a namespace import. In addition to the properties specified in 1.0.4.6, each module namespace object has the following own property: 8.3.1 add string tag. The initial value of the add string tag property is the string value module. This property has the attributes false, false, false. 9. Memory model. The memory consistency model, or memory model, specifies the possible orderings of shared data block events arising via accessing typed array instances backed by a shared array buffer and via methods on the atomics object. When the program has no data races, defined below, the ordering of events appears as sequentially consistent, that is, as an interleaving of actions from each agent. When the program has data races, shared memory operations may appear sequentially inconsistent. For example, programs may exhibit causality violating behavior and other astonishments. These astonishments arise from compiler transforms and the design of CPUs. For example, out-of-order execution and speculation. The memory model defines both the precise conditions under which a program exhibits sequentially consistent behavior as well as the possible values read from data races. To wit, there is no undefined behavior. The memory model is defined as relational constraints on events introduced by abstract operations on shared array buffer or by methods on the atomics object during an evaluation. Note this section provides an axiomatic model on events introduced by the abstract operations on shared array buffers. It bears stressing that the model is not expressible algorithmically, unlike the rest of this specification. The non-deterministic introduction of events by abstract operations is the interface between the operational semantics of ECMAScript evaluation and the axiomatic semantics of the memory model. The semantics of these events is defined by considering graphs of all events in an evaluation. These are neither static semantics nor runtime semantics. There is no demonstrated algorithmic implementation, but instead a set of constraints that determine if a particular event graph is allowed or disallowed. 9.1 Memory Model Fundamentals. Shared memory accesses, reads and writes, are divided into two groups: atomic accesses and data accesses, defined below. Atomic accesses are sequentially consistent, that is, there is a strict total ordering of events agreed upon by all agents in an agent cluster. Non-atomic accesses do not have a strict total ordering agreed upon by all agents. That is, unordered. A shared data block event is either a read shared memory, write shared memory, or read modify write shared memory record. Note 1. No orderings weaker than, sequentially consistent and stronger than unordered, such as release acquire, are supported. ECMA International 2024 729. Table 91. Read shared memory event fields. Field name, value, meaning, order, sexcst, or unordered. The weakest ordering guaranteed by the memory model for the event. Note a boolean, whether this event is allowed to read from multiple write events with equal ranges. This event block, a shared data block. The block the event operates on byte index, a non-negative integer, the byte address of the read-in element size, a non-negative integer, the size of the read. Table 92. Write shared memory event fields. Field name, value, meaning, order, sexcst, unordered, or init. The weakest ordering guaranteed by the memory model for the event. Note a boolean, whether this event is allowed to be read from multiple read events with equal ranges. This event block, a shared data block. The block the event operates on byte index, a non-negative integer, the byte address of the write-in element size, a non-negative integer, the size of the write payload, a list of byte values, the list of byte values to be read by other events. Table 93. Read modify write shared memory event fields. Field name, value, meaning, order, sexcst. Read modify write events are always sequentially consistent. Note true. Read modify write events cannot block, a shared data block. The block the event operates on byte index, a non-negative integer, the byte address of the read modify write in element size, a non-negative integer, the size of the read modify write payload, a list of byte values, the list of byte values to be passed to 2. Modify op, a read modify write modification function, an abstract closure that returns a modified list of byte values from a read list of byte values, and these events are introduced by abstract operations or by methods on the atomics object. Some operations may also introduce synchronize events. A synchronize event has no fields and exists purely to directly constrain the permitted orderings of other events. 30. Copyright sign. ECMA International 2024. In addition to shared data block and synchronize events, there are host-specific events. Let the range of a read shared memory, write shared memory, or read modify write shared memory event be the set of contiguous integers from its to +1. Two events ranges are equal when the events have the same, and the ranges are element-wise equal. Two events ranges are overlapping when the events have the same. The ranges are not equal and their intersection is non-empty. Two events ranges are disjoint when the events do not have the same or their ranges are neither equal nor overlapping. Events are ordered within candidate executions by the relations defined below. 29.2 Agent events records. An agent events record is a record with the following fields. Table 94. Agent events record fields. Note 2 examples of host-specific synchronizing events that should be accounted for are sending a shared array buffer from one agent to another, for example, by post message in a browser, starting and stopping agents, and communicating within the agent cluster via channels other than shared memory. It is assumed those events are appended to agent order during evaluation like the other shared array buffer events. Field name, value, meaning, agent signifier, an agent signifier, the agent whose evaluation resulted in this ordering. Event list, a list of events. Events are appended to the list during evaluation. Agent synchronizes with a list of pairs of synchronize events. Synchronize relationships introduced by the operational semantics. 29.3 Chosen value records. A chosen value record is a record with the following fields. Table 95. Chosen value record fields. Field name, value, meaning, event, a shared data block event, the read shared memory or read modify write shared memory event that was introduced for this chosen value. Chosen value, a list of byte values, the bytes that were non-deterministically chosen during evaluation. Copyright sign, ECMA International 2024. 31. 29.4 Candidate executions. A candidate execution of the evaluation of an agent cluster is a record with the following fields. Table 96. Candidate execution record fields. Field name, value, meaning, events records, a list of agent events records, maps an agent to lists of events appended during the evaluation. Chosen values, a list of chosen value records, maps read shared memory or read modify write shared memory events to the list of byte values chosen during the evaluation. Agent order, an agent order relation, defined below. Reads bytes from, a reads bytes from mathematical function, defined below. Reads from, a reads from relation, defined below. Host synchronizes with, a host synchronizes with relation, defined below. Synchronizes with, a synchronizes with relation, defined below. Happens before, a happens before relation, defined below. An empty candidate execution is a candidate execution record whose fields are empty lists and relations. 29.5 Abstract operations for the memory model. 9. 5. 1 event set. Execution. The abstract operation event set takes argument execution a candidate execution and returns a set of events. It performs the following steps when called. Let events be an empty set. For each agent events record error of execution. Do. A for each event of error. Do I add to events? Return events. 32. ECMA International 2024. 29. 5. 2 shared data block event set. Execution. The abstract operation shared data block event set takes argument execution a candidate execution and returns a set of events. It performs the following steps when called. Let events be an empty set. For each event of event set. Execution. Do. If E is a read shared memory, write shared memory, or read modify write shared memory event. Add E to events. Return events. 9. 5. 3 host event set. Execution. The abstract operation host event set takes argument execution a candidate execution and returns a set of events. It performs the following steps when called. Let events be an empty set. For each event of event set. Execution. Do. If E is not in shared data block event set. Execution. Add E to events 3. Return events. 9. 5. 4 compose write event bytes, execution, byte int x, w's. The abstract operation compose write event bytes takes arguments execution a candidate execution, byte int x, a non-negative integer, and w's, a list of either write shared memory or read modify write shared memory events, and returns a list of byte values. It performs the following steps when called. Let byte location be byte index. Let bytes read be a new empty list. For each element w of w's, do a assert w has byte location in its range. B let payload index be byte location. W, see if w is a write shared memory event. Then I let byte be w, payload index. T else I assert w is a read modify write shared memory event. 2. Let bytes be value of read event, execution, w. 3. Let bytes modified be w, bytes, w. 5. Let byte be bytes modified, payload index. E append byte to bytes read. F set byte location to byte location +1. Return bytes read. Note 1. The read modify write modification is given by the function properties on the atomics object that introduce read modify write shared memory events. Note 2. This abstract operation composes a list of write events into a list of byte values. It is used in the event semantics of read shared memory and read modify write shared memory events. ECMA International 2024 733 29 5 value of read event, execution, R. The abstract operation value of read event takes arguments execution a candidate execution and R, a read shared memory or read modify write shared memory event, and returns a list of byte values. It performs the following steps when called. Let w's be execution R, assert w's is a list of write shared memory or read modify write shared memory events with length equal to. Return compose write event bytes, execution, R, w's. 9.6 Relations of candidate executions. 9, 6, 1 Agent order. For a candidate execution is a relation on events that satisfies the following. For each pair, E, D, in event set, execution contains E, D. If there is some agent events record air in execution such that D and D are in air and D is before D in list order of air. 9, 6, 2 reads bytes from. For a candidate execution cushion, execution is a mathematical function mapping events in shared data block event set, execution, to lists of events in shared data block event set, execution, that satisfies the following conditions. For each read shared memory or read modify write shared memory event R in shared data block event set, execution R, is a list of length R whose elements are write shared memory or read modify write shared memory events W such that all of the following are true. Each event W with index I in W's has R plus I in its range. R is not in W's. 9, 6, 3 reads from. For a candidate execution is the least relation on events that satisfies the following. For each pair, R, W, in shared data block event set, execution contains R, W, if execution R contains W. 9, 6, 4 host synchronizes with. For a candidate execution is a host-provided strict partial order on host-specific events that satisfies at least the following. If execution contains E, D, E and D are in host event set, execution, there is no cycle in the union of execution and execution. Note 1 for 2 host-specific events E and D, E host synchronizes with D implies E happens before D. Note each agent introduces events in a per-agent strict total order during the evaluation. This is the union of those strict total orders. 734. Copyright sign, ECMA International 2024. Note to the host synchronizes with relation allows the host to provide additional synchronization mechanisms, such as post message between HTML workers. 9, 6, 5 synchronizes with. For a candidate execution is the least relation on events that satisfies the following. For each pair, R, W, in execution contains W, R. If R is sexcst, W is sexcst, and R and W have equal ranges. For each element events record of execution, The following is true for each pair S, SW. In events record, execution contains S, SW. For each pair E, D. In execution, execution contains E, D. Note 1 owing to convention, write events synchronizes with read events, instead of read events synchronizes with write events. Note 2 init events do not participate in synchronizes with, and are instead constrained directly by happens before. Note 3 not all sexcst events related by reads from are related by synchronizes with. Only events that also have equal ranges are related by synchronizes with. Note 4 for shared data block events R and W such that W synchronizes with R may reads from other writes than W. 9. 6. 6 happens before. For a candidate execution. F4 is the least relation on events that satisfies the following. For each pair E, D. In execution, execution contains E, D. For each pair E, D. In execution, execution contains E, D. For each pair E, D. In shared data block event set, execution, execution contains E, D. If E is init and D and D have overlapping ranges. For each pair E, D. In event set, execution, execution contains E, D. If there is an event F such that the pairs E, F, and F, D are in execution. 9.7 Properties of valid executions. 9. 7. 1 valid chosen reads. A candidate execution has valid chosen reads if the following algorithm returns true. For each read shared memory or read modify write shared memory event R of shared data block event set. Execution. Do a let chosen value record be the element of execution whose field is R. ECMA International 2024 735. Note because happens before is a superset of agent order. Candidate executions are consistent with the single-thread evaluation semantics of ECMAScript. B let chosen value be chosen value record. C let read value be value of read event. Execution. R. D let chosen len be the number of elements in chosen value. E let read len be the number of elements in read value. F if chosen len read len, then I return false. G if chosen value I read value I. For some integer I in the interval from 0 inclusive to chosen len exclusive, then I return false 2. Return true. 9. 7. 2 coherent reads. A candidate execution has coherent reads if the following algorithm returns true. For each read shared memory or read modify write shared memory event R of shared data block event set. Execution. Do a let W's be execution R be let byte location be R. C for each element W of W's. Do I if execution contains R, W, then 1. Return false. 2. If there exists a write shared memory or read modify write shared memory event V that has byte location in its range such that the pairs W, V, and V, are in execution, then return false. 3. Set byte location to byte location plus 1. Return true. 9. 7. 3 tear-free reads. A candidate execution has tear-free reads if the following algorithm returns true. For each read shared memory or read modify write shared memory event R of shared data block event set. Execution. Do if R is true, then I assert the remainder of dividing R by R is 0. 2. For each event W such that execution contains R, W, and W is true. Do 36. ECMA International 2024. Return true. If R and W have equal ranges and there exists an event V such that V and W have equal ranges, V is true, W is not V, and execution contains R, V, then a return false. Note an events field is true when that event was introduced via accessing an integer typed array, and false when introduced via accessing a floating point typed array or data view. Intuitively, this requirement says when a memory range is accessed in an aligned fashion via an integer typed array, a single write event on that range must win when in a data race with other write events with equal ranges. More precisely, this requirement says an aligned read event cannot read a value composed of bytes from multiple different write events all with equal ranges. It is possible, however, for an aligned read event to read from multiple write events with overlapping ranges to 9, 7, 4 sequentially consistent atomics. For a candidate execution, memory order is a strict total order of all events in event set execution that satisfies the following. For each pair, E, D, in execution, E, D, is in memory order. For each pair, R, W, in execution, there is no write shared memory or read modify write shared memory event V in shared data block event set execution, such that V is sexcst, the pairs W, V, and V, R, are in memory order, and any of the following conditions are true. Execution contains the pair W, R, and V and R have equal ranges. The pairs W, R, and V, R are in execution. W is sexcst, and W and V have equal ranges. The pairs W, R, and W, V are in execution. R is sexcst, and V and R have equal ranges. Note 1. This clause additionally constrains sexcst events on equal ranges. For each write shared memory or read modify write shared memory event W in shared data block event set execution, if W is sexcst, then it is not the case that there is an infinite number of read shared memory or read modify write shared memory events in shared data block event set execution with equal range that is memory order before W. A candidate execution has sequentially consistent atomics if a memory order exists. 9, 7, 5 valid executions. A candidate execution is a valid execution or simply an execution if all of the following are true. The host provides a host synchronizes with relation for execution. Execution is a strict partial order. Execution has valid chosen reads. Execution has coherent reads. Execution has tear-free reads. Execution has sequentially consistent atomics. All programs have at least one valid execution. 9.8 races. For an execution, to events in the shared data block event set execution are in a race if the following algorithm returns true. If E is not D, then if the pairs E, D, and D, E are not an execution, then note 2. This clause together with the forward progress guarantee on agents ensure the liveness condition that sexcst writes become visible to SE. QCST reads with equal range in finite time. Note 3. While memory order includes all events in event set execution, those that are not constrained by happens before or synchronizes with are allowed to occur anywhere in the order. ECMA International 2024 737. If E and D are both write shared memory or read modify write shared memory events and E and D do not have disjoint ranges, then return true. 2. If execution contains either E, D, or D, E, then return true. 2. Return false. 9.9 data races. For an execution, to events in the shared data block event set execution are in a data race if the following algorithm returns true. If E and D are in a race in execution, then if E is not sexcst or D is not sexcst, then I return true. B. If E and D have overlapping ranges, then I return true. 2. Return false. 9.10 Data race freedom. An execution is data race free if there are no two events in shared data block event set execution that are in a data race. A program is data race free if all its executions are data race free. The memory model guarantees sequential consistency of all events for data race free programs. 9.11 Shared memory guidelines. Note 1. The following are guidelines for ECMAScript programmers working with shared memory. We recommend programs be kept data race free. That is, make it so that it is impossible for there to be concurrent non-atomic operations on the same memory location. Data race-free programs have interleaving semantics where each step in the evaluation semantics of each agent are interleaved with each other. For data race-free programs, it is not necessary to understand the details of the memory model. The details are unlikely to build intuition that will help one to better write ECMAScript. More generally, even if a program is not data race-free, it may have predictable behavior, so long as atomic operations are not involved in any data races and the operations that race all have the same access size. The simplest way to arrange for atomics not to be involved in races is to ensure that different memory cells are used by atomic and non-atomic operations, and that atomic accesses of different sizes are not used to access the same cells at the same time. Effectively, the program should treat shared memory as strongly typed as much as possible. One still cannot depend on the ordering and timing of non-atomic accesses that race, but if memory is treated as strongly typed, the racing accesses will not tear, bits of their values will not be mixed. Note 2: the following are guidelines for ECMAScript implementers writing compiler transformations for programs using shared memory. 38. ECMA International 2024. It is desirable to allow most program transformations that are valid in a single agent setting in a multi-agent setting, to ensure that the performance of each agent in a multi-agent program is as good as it would be in a single agent setting. Frequently these transformations are hard to judge. We outline some rules about program transformations that are intended to be taken as normative, in that they are implied by the memory model, or stronger than what the memory model implies, but which are likely not exhaustive. These rules are intended to apply to program transformations that precede the introductions of the events that make up the agent order. Let an agent order slice be the subset of the agent order pertaining to a single agent. Let possible read values of a read event be the set of all values of value of read event for that event across all valid executions. Any transformation of an agent order slice that is valid in the absence of shared memory is valid in the presence of shared memory, with the following exceptions. Atomics are carved in stone. Program transformations must not cause the sexCST events in an agent order slice to be reordered with its unordered operations, nor its sexCST operations to be reordered with each other. Nor may a program transformation remove a sexCST operation from the agent order. In practice, the prohibition on reorderings forces a compiler to assume that every sexCST operation is a synchronization and included in the final memory order, which it would usually have to assume anyway in the absence of inter-agent program analysis. It also forces the compiler to assume that every call where the callee's effects on the memory order are unknown may contain sexCST operations. Reads must be stable. Any given shared memory read must only observe a single value in an execution. For example, if what is semantically a single read in the program is executed multiple times, then the program is subsequently allowed to observe only one of the values read. A transformation known as rematerialization can violate this rule. Writes must be stable. All observable writes to shared memory must follow from program semantics in an execution. For example, a transformation may not introduce certain observable writes, such as by using read-modify-write operations on a larger location to write a smaller datum, writing a value to memory that the program could not have written, or writing a just read value back to the location it was read from, if that location could have been overwritten by another agent after the read. Possible read values must be non-empty. Program transformations cannot cause the possible read values of a shared memory read to become empty. Counterintuitively, this rule in effect restricts transformations on writes, because writes have force in memory model insofar as to be read by read events. For example, writes may be moved and coalesced and sometimes reordered between two sexCST operations, but the transformation may not remove every write that updates a location. Some write must be preserved. Examples of transformations that remain valid are merging multiple non-atomic reads from the same location, reordering non-atomic reads, introducing speculative non-atomic reads, merging multiple non-atomic writes to the same location, reordering non-atomic writes to different locations, and hoisting non-atomic reads out of loops even if that affects termination. Note in general that alias-typed arrays make it hard to prove that locations are different. ECMA International 2024 739. Note 3. The following are guidelines for ECMAScript implementers generating machine code for shared memory accesses. For architectures with memory models no weaker than those of ARM or Power, non-atomic stores and loads may be compiled to bear stores and loads on the target architecture. Atomic stores and loads may be compiled down to instructions that guarantee sequential consistency. If no such instructions exist, memory barriers are to be employed, such as placing barriers on both sides of a bare store or load. Read modify write operations may be compiled to read modify write instructions on the target architecture, such as log prefixed instructions on x86, load exclusive store exclusive instructions on ARM, and load link store. Conditional instructions on power. Specifically, the memory model is intended to allow code generation as follows. Every atomic operation in the program is assumed to be necessary. Atomic operations are never rearranged with each other or with non-atomic operations. Functions are always assumed to perform atomic operations. Atomic operations are never implemented as read, modify, write operations on larger data, but as non-lock-free atomics if the platform does not have atomic operations of the appropriate size. We already assume that every platform has normal memory access operations of every interesting size. Naive code generation uses these patterns. Regular loads and stores compile to single load and store instructions. Lock-free atomic loads and stores compile to a full, sequentially consistent fence, a regular load or store, and a full fence. Lock-free atomic read modify write accesses compile to a full fence, an atomic read modify write instruction sequence, and a full fence. Non-lock-free atomics compile to a spin lock acquire, a full fence, a series of non-atomic load and store instructions, a full fence, and a spin lock release. That mapping is correct so long as an atomic operation on an address range does not race with a non-atomic write or with an atomic operation of different size. However, that is all we need. The memory model effectively demotes the atomic operations involved in a race to non-atomic status. On the other hand, the naive mapping is quite strong. It allows atomic operations to be used as sequentially consistent fences, which the memory model does not actually guarantee. Local improvements to those basic patterns are also allowed, subject to the constraints of the memory model. For example, there are obvious platform-dependent improvements that remove redundant fences. For example, on x86 the fences around lock-free atomic loads and stores can always be omitted except for the fence following a store, and no fence is needed for lock-free read modify write instructions, as these all use lock prefixed instructions. On many platforms there are fences of several strengths, and weaker fences can be used in certain contexts without destroying sequential consistency. Most modern platforms support lock-free atomics for all the data sizes required by ECMAScript atomics. Should non-lock-free atomics be needed, the fences surrounding the body of the atomic operation can usually be folded into the lock and unlock steps. The simplest solution for non-lock-free atomics is to have a single lock word per shared array buffer. There are also more complicated platform-dependent local improvements, requiring some code analysis. For example, two back-to-back fences often have the same effect as a single fence, so if code is generated for two atomic operations in sequence, only a single fence needs separate them. On x86, even a single fence separating atomic stores can be omitted, as the fence following a store is only needed to separate the store from a subsequent load. 40. Copyright sign. ECMA International 2024. A. 1 lexical grammar. Source character. Any Unicode code point. Input element div. White space. Line terminator comment token div punctuator right brace punctuator. Input element regexp. White space, line terminator comment token right brace punctuator regular expression literal, capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A, white space, line terminator comment token regular expression literal template substitution tail, input element template tail, white space, line terminator comment token div punctuator template substitution tail, input element hashbang or regexp, white space, line terminator comment token hashbang comment regular expression literal, white space, tab, VT, FF, ZWMBSP, OSP, ECMA International 2024. 41. Annex A. Informative. Grammar summary. Line terminator. LF. CRLS. PS. Line terminator sequence. LF, CR look ahead, LF, LS, PS, CR LF, comment, multi-line comment, single line comment, multi-line comment, chars op, multi-line comment chars, multi-line not asterisk char, multi-line comment chars opt, post asterisk comment chars opt, post asterisk comment chars, capital M, U, L, T, I, capital L, I, N, E, capital N, O, T, capital F, O, R, W, A, R, D, capital S, L, A, S, H, capital O, R, capital A, S, T, E, multi-line comment chars opt, post asterisk comment chars opt, multi-line not asterisk char, source character but not, capital M, U, L, T, I, capital L, I, N, E, capital N, O, T, capital F, O, R, W, A, R, D, capital S, L, A, S, H, capital O, R, capital A, S, T, E, source character but not one of or single line comment chars opt, single line comment chars, single line comment char, single line comment chars opt, single line comment char, source character but not line terminator hashbang comment, single line comment chars opt, common token, identifier name, private identifier, punctuator, numeric literal string literal template, private identifier, identifier name, identifier start, identifier name, identifier part, identifier start char, Unicode escape sequence, identifier part char, Unicode escape sequence, 42, ECMA International 2024, identifier start char, Unicode ID start, identifier part char, Unicode ID continue, ZWJ, assign letter, 1 of A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, capital A, capital B, capital C, capital D, Opergrustavoxes, Unicode ID start, any Unicode code point with the Unicode property ID start, Unicode ID continue, any Unicode code point with the Unicode property ID continue, reserved word, 1 of, await break case catch class const continue debugger default delete do else, enum export extends false finally for function of import and instantiaf new null return super switch this throw true try type off var void well with a yield, punctuator, optional chaining punctuator, other punctuator, optional chaining punctuator, look ahead decimal digit, other punctuator, 1 of, comma equals plus percent plus and equals plus equals percent equals and equals de punctuator equals sign right brace punctuator null literal null boolean literal true false numeric literal separator numeric literal decimal big integer literal non-decimal integer literal plus sep non-decimal integer literal plus sep begin literal suffix legacy octal integer literal decimal big integer literal 0 big int literal suffix non-zero digit decimal digits plus sep opt begin literal suffix non-zero digit numeric literal separator decimal digits plus sep begin literal suffix ECMA International 2024 743 non-decimal integer literal sep binary integer literal sep octal integer literal sep hex integer literal sep begin literal suffix n decimal integer literal decimal digits plus sep opt exponent part plus sep opt decimal digits plus sep exponent part plus sep opt decimal integer literal exponent part plus sep opt decimal integer literal 0 non-zero digit. Non-zero digit numeric literal separator octadecimal digits. Plus sep. Non-octal decimal integer literal decimal digits. Sep. Decimal digit. Decimal digits sep. Decimal digit. Plus sep. Decimal digits. Plus sep. Numeric literal separator decimal digit. Decimal digit. 1 of 123,456,789. Non-zero digit. 1 of 123,456,789. Exponent part. Sep. Exponent indicator signed integer sep. Exponent indicator. 1 of EE signed integer. Sep. Decimal digits sep. Decimal digits sep. Decimal digits sep. Binary integer literal. Sep 0b binary digits sep 0b binary digits sep binary digits sep binary digit sep binary digit plus sep binary digits plus sep numeric literal separator binary digit 1 of 0 1 octal integer literal sep 0 octal digits sep 0 octal digits sep octal digits sep octal digit sep octal digit plus sep octal digits plus sep numeric literal separator octal digit legacy octal integer literal octal digit legacy octal integer literal octal digit 44 ECMA intonation L 2024 non-octal decimal integer literal 0 non-octal digit capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L non-octal digit non-octal decimal integer literal decimal digit capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L octal digit capital L E G A C Y capital O C T A.
This is really annoying to rename. I need some more water. I rename it. I need to rename the labels first maybe, then the rest. I need some water. But most of all, I need some water. Because I can't rename them all, because I keep missing a spot. And then there's something needs to be wrapped in parentheses. But I can't wrap everything because it makes other issues. I could replace them one by freaking one.
Continuation single string character, source character but not one of or line terminator. LS, PS, escape sequence, line continuation, line terminator sequence, escape sequence, character escape sequence, look ahead decimal digit, legacy octal escape sequence, non-octal decimal escape sequence, hex escape sequence, Unicode escape sequence, character escape sequence, single escape character, non-escape character, single escape character, 1 of BFN RTV, ECMA International 2024 745, non-escape character, source character but not one of escape character or line terminator, escape character, single escape character, decimal digit, X, U, legacy octal escape sequence, 0, look ahead, 8, 9, non-zero octal digit, look ahead octal digit, 0 to 3 octal digit. Look ahead octal digit. 4 to 7 octal digit. 0 to 3 octal digit. Non-zero octal digit. Octal digit but not 0. 0 to 3. 1 of 0, 1, 2, 3. 4 to 7. 1 of 4567. Non-octal decimal escape sequence. 1 of 89. Hex escape sequence. X hex digit. Unicode escape sequence. U hex 4 digits. U. Code point. Hex 4 digits. Hex digit. Regular expression literal. Regular expression body. Regular expression flags. Regular expression body. Regular expression first char. Regular expression chars. Regular expression chars. Empty. Regular expression chars. Regular expression char. Regular expression first char. Regular expression non-terminator but not one of or. Capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U. Regular expression class. Regular expression char. Regular expression non-terminator but not one of or. Capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U. Regular expression class. Capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U. Regular expression non-terminator. Regular expression non-terminator. Source character but not line terminator. Regular expression class. Regular expression class chars. Regular expression class chars. Empty. Regular expression class chars. Regular expression class char. 46. ECMA International 2024. Regular expression class char. Regular expression non-terminator but not one of or regularly XP Russian \sequence. Regular expression flags. Empty. Regular expression flags identifier part char template. No substitution template. Template head no substitution template. Template character sop. Template head. Template character sop. $. Template substitution tail. Template middle. Template tail. Template middle. Template character sop. $. Template tail. Template character sop. Template characters. Template character. Template character sop. Template character. Look ahead. Template escape sequence. Not escape sequence. Line continuation. Line terminator sequence. Source character but not one of or $. Or line terminator. Template escape sequence. Character escape sequence. Look ahead decimal digit. Hex escape sequence. Unicode escape sequence. Not escape sequence. 0 decimal digit but not 0. X. Look ahead hex digit. X hex digit. Look ahead hex digit. U. Look ahead hex digit. Look ahead U hex digit. Look ahead hex digit. U hex digit. Look ahead hex digit. U hex digit. Look ahead hex digit. U. Look ahead hex digit. U. Not code point. Look ahead hex digit. U. Code point. Look ahead hex digit. Look ahead not code point. Hex digits. SEP code point. Hex digits. SEP but only if MV of hex digits. 0 times 10 FF but if MV of hex digits 0 times 10 FF. ECMA International 2024. 47. A. 2 expressions. Identifier reference. Yield. Await. Identifier. Yield. Yield. Await. Await binding identifier. Yield. Await. Identifier. Yield. Await. Label identifier. Yield. Await. Identifier. Yield. Yield. Await. await identifier, identifier name but not reserved word primary expression, yield, await. This identifier reference yield await. Literal, array literal yield await. Object literal yield await. Function expression, class expression yield await. Generator expression, async function expression, async generator expression, regular expression literal, template literal yield await. Tagged, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, yield await, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, yield, await, plus in yield await.
Okay, now I'm gonna try to like rename the defines first. Because those are made up of the other defines. But they're not defines. They're field offsets. I don't know. It's treating them differently or something. So we need to find like the outermost thing. Oh, this is so boring.
T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, yield await. The interpretation of capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, is refined using the following grammar. Parenthesized expression, yield, await, expression, plus in yield await. 48. ECMA International 2024. Literal, null literal, boolean literal, numeric literal, string literal, array literal, yield, await, elisionort, element list yield await, element list yield await, elisionort, element list, yield, await, elisionort assignment expression, plus in yield await, elisionort spread element yield await, element list yield await, elisionort assignment expression, plus in yield await, element list yield await, elisionort spread element yield await, elision, spread element, yield, await, dart, assignment expression, plus in yield await, object literal, yield, await, property definition list yield await, property definition list yield await, property definition list, yield, await, property definition yield await, property definition list yield await, property definition yield await, property definition, yield, await, identifier reference yield await, cover initialized name yield await, property name yield await, assignment expression, plus in yield await, method definition yield await, dart, assignment expression, plus in yield await, property name, yield, await, literal property name, computed property name yield await, literal property name, identifier name string literal numeric literal, computed property name, yield, await, assignment expression, plus in yield await, cover initialized name, yield, await, identifier reference yield await, initializer, plus in yield await, initializer, in, yield, await, assignment expression in yield await, template literal, yield, await, tagged, no substitution template, substitution template yield await tagged, substitution template, yield, await, tagged, template head expression, plus in yield await. Template spans yield await tagged. ECMA International 2024 749. Template spans yield await tagged. Template tail. Template middle list yield await tagged. Template tail. Template middle list yield await tagged. Template middle expression plus in yield await. Template middle list yield await tagged. Template middle expression plus in yield await. Member expression yield await. Primary expression yield await. Member expression yield await. Expression plus in yield await. Member expression yield await. Identifier name member expression yield await. Template literal yield await. Plus tagged super property yield await. Meter property new member expression yield await. Arguments yield await. Member expression yield await. Private identifier super property yield await. Super expression plus in yield await. Super identifier name meter property new target import meter new target import meter import meta new expression yield await. Member expression yield await. New expression yield await. Call expression yield await. Capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R yield await. Super call yield await. Import call yield await. Call expression yield await. Arguments yield await. Call expression yield await. Expression plus in yield await. Call expression yield await. Identifier name call expression yield await. Template illiteral yield await. Plus tagged call expression yield await. Private identifier when processing an instance of the production. Call expression yield await. Capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R yield await. The interpretation of capital C O V E
So fucking annoying.
L capital E X
I can't just glue the define that's defined to 1 right here.
Y N
For whatever reason,
the following grammar
that doesn't work. But when I use 1,
yield await. Arguments yield await.
the argument without gluing it to like the define. So this is the same exact thing as this, or it's supposed to be, but this doesn't work.
4 arguments yield await. Argument list yield await.
But there was an error. It says it's not defined.
Yield await. Assignment expression
If I replace that, the argument itself,
in yield await. Argument list yield await. Assignment expression plus in yield await. Argument list
then it builds.
expression plus in yield await. Optional expression yield await. Member expression yield await. Optional chain yield await.
It's not worth looking into. Instead, I'm just gonna fucking not define this argument. Because it's wasting fucking time.
Plus tagged. Private identifier.
So for these ones, I'll just fucking find and replace, and if I ever have to update it, it'll be a pain in the ass to fucking find fucking %1 for fuck's sake.
Await. Template.
Fuck. Shit. God, stupid.
private identifier, left-hand side expression, yield, await, new expression yield await, call expression yield await, optional expression yield await, update expression, yield, await, left-hand side expression yield await, left-hand side expression yield await, left-hand side expression yield await, plus unary expression yield await, unary expression yield await, unary.
It works for the other defines though. I don't know why it doesn't work for the defines of the defines.
Unary expression.
I don't care right now. I just want to get done. This is so annoying. I can't like stop, look up every single case. Chatbot's a piece of shit. Does not help at all. It keeps saying wrap things in tokens or backticks. That's not even in the fucking documentation. There is no backtick even in the documentation. The fuck is Chatbot even saying? It's just making up shit, wasting time.
Expression yield await, multiplicative expression yield await, multiplicative operator exponentiation expression yield await, multiplicative operator 1%, additive expression yield await, multiplicative expression yield await, additive
So now this isn't defined,
expression yield question mark
and instead
yield await, multiplicative expression
of using this define, I'm just gonna freaking use %1. This is so stupid.
shift expression yield await, additive expression yield await, shift expression yield await, additive expression yield await, relational expression in yield await, shift expression yield await, relational expression and yield, 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 plus in relational expression, plus in yield await, in shift expression yield await, plus in private identifier in shift expression yield await, equality expression in yield await, relational expression and yield await, equality 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 expression and yield await, bitwise and expression in yield await, equality expression and yield await, bitwise and expression and yield await, bitwise or expression in yield await, bitwise and expression and yield await, bitwise or expression and yield await, bitwise or expression in yield await, bitwise or expression and yield await, await, shift expression yield await, await, shift expression yield await, await, equals shift expression yield await, await, equals shift expression yield await, await, instantia of shift expression yield await, bitwise or expression and yield await, bitwise or expression and yield await, logical and expression in yield await, bitwise or expression and yield await, logical and expression and yield await, and bitwise or expression and yield await, logical or expression in yield await, logical and expression and yield await, logical or expression and yield await, logical and expression and yield await, coalesce expression in yield await, coalesce expression head and yield await, bitwise or expression and yield await, coalesce expression head in yield await, coalesce expression and yield await, bitwise or expression and yield await. 52. ECMA International 2024 equals relational expression and yield await equals relational expression and yield await equals relational expression and yield await equals relational expression and yield await, equality expression and yield await, bitwise and expression and yield await, short circuit expression in yield await, logical or expression and yield await, coalesce expression and yield await, conditional expression in yield await, short circuit expression in yield await, short circuit expression in yield await, assignment expression plus in yield await, assignment expression in yield await, assignment expression in yield await, conditional expression in yield await plus yield yield the expression in await, arrow function and yield await, async arrow function and yield await, left-hand side expression yield await, equals assignment expression and yield await, left-hand side expression yield await, assignment operator, assignment expression and yield await, left-hand side expression yield await, and equals assignment expression and yield await, left-hand side expression yield await, equals assignment expression and yield await, left-hand side expression yield await equals assignment expression and yield. Question mark await, assignment operator, 1 of, equals percent equals plus equals equals. In certain circumstances when processing an instance of the production, assignment expression, in, yield, await, left-hand side expression yield, assignment expression and yield await. The interpretation of left-hand side expression is refined using the following grammar. Assignment pattern, yield, await, object assignment pattern yield await, array assignment pattern yield await, object assignment pattern, yield, await, equals, assignment dress property yield await, assignment property list yield await, assignment property list yield await, assignment dress property yield await opt, array assignment pattern, yield, await, elegant assignment dressed element yield await opt, assignment element list yield await, assignment element list yield await, elegant assignment dressed element yield await opt, assignment dress property, yield, await dot. Destructuring assignment target yield await, assignment property list, yield, await, assignment property yield await, assignment property list yield await, assignment property yield await, assignment element list, yield, await, assignment elision element yield await, assignment element list yield await, assignment elision element yield await, assignment elision element, yield, await, elegant assignment element yield await, assignment property, yield, await, identifier reference yield await, initializer, plus in yield await opt property name yield await, assignment element yield await, ECMA International 2024 753, assignment element, yield, await, destructuring assignment target yield await, initializer, plus in yield await opt, assignment dressed element, yield, await dot. Destructuring assignment target yield await, destructuring assignment target, yield, await, left-hand side expression yield await, expression, in, yield, await, assignment expression and yield await, expression and yield await, assignment expression and yield await. A. 3 statements, statement, yield, await, return, block statement yield await return, variable statement yield await, empty statement expression statement yield await, if statement yield await return, breakable statement yield await return, continue statement yield await, break statement yield await, plus return, return statement yield await, with statum, end yield await return, labeled statement yield await re2.
Well, that's finally renamed. It was literally like a syntax issue. It was a waste of time. I'm not even gonna waste my time Googling why the parenthesis plus doesn't concat the tokens. I'm just gonna leave it like this and try to get a little bit further. This is so boring. I think now I can make the other list and do some freaking benchmarking. So to copy paste, and if it's all templated, then it should run. Now, I can finally copy paste, and it should print two more lists for the wall time and the cycle time. If it works, then I'll actually be able to speed test stuff. Please work. Swear to God. I don't know what I'll do. I'll just be really pissed. It's taking even longer to get done. The mic was on. Oops. So, everything's working. If everything's working. Oh, my stomach. I ate too much. I don't know, I'll just paste again. So, like, this would make 3 of the same list. But now, I want to make a benchmark wall time and a benchmark CPU cycles list. So I'm going to copy these. And if it's working, then it'll work. If it's not working, then it's not going to work. It's as simple as that. Easy as pie. Please just fucking work. For the love of shit. Please. Just build. I'm tired. I want to benchmark some shit. I'm really tired. I'm so fucking tired. I'm gonna build it. See what happens. So stupid. I hate this shit. It builds. Oh my God. But does it run? Does it run? Please work. Ta-da! Finally. Okay, so now I can fucking benchmark some shit. I'm not gonna fuck with getting real time and getting not static, whatever it's called. I have to like subtract to get the average because there's a huge delay when getting the time. So I'm gonna remove that from the total time. That's gonna take an hour or so to set up, so I'm just gonna do CPU cycle time. That's good enough for now. Just get something and I'll get the wall time set up. I gotta put another line feed or a new line, whatever, between the split list. I didn't build it. I forgot to build it. Finally. So now I still have to format it to print executable. So I'm gonna like simply use a lookup table and get this shit done. I want to see how many CPU cycles that the Windows instruction takes to execute compared to the GCC routine. This is like 26 instructions. This one's 24 or 12. So you multiply 12 by 2, 24. So this is like twice as large in instruction length plus 2. So I don't know. This one, the Microsoft Vision, whatever, the time it takes to like actually fetch your memory that's not part of cycle time or whatever. It's like the real time. I have to like, I'll deal with that later. I'll just get like cycle time for now. So now the whole thing's macroed or templated or whatever. So I should be able to change the type of the CPU cycles or any of them, whatever, to a different type. And then I get to add another option to print 64-bit value. Now I should be able to pass in what to select as an argument. And it should work. So finally, this define was a global. Drink some water. It's not helping. My throat is still really dry. But now, instead of using the global, I make this 2 to pass in 2 arguments. I'm not going to make a define because for the argument, I'll just use %2. It's too much effort to deal with defining things at the top and the bottom. So I need to pass in what type, the format to pick, whatever. Just annoying. Fucking type. Fuck this stupid syntax. Why can't I just define something without like some fucking special rule for every fucking case? I don't have time to look up. This is annoying. The problem is that I didn't pass in the name. There's nothing even wrong. Dang it. It's wasted that much time. I changed the length to 2 arguments. I forgot to pass in the second argument. I just wanna be done. Benchmark stuff. That's all I want. I forgot to type, pass in the type again. So now, pass and type, this should work. And it works. And it builds exactly the same. I'll now like change the CPU cycle list to hextest word. It should be the other format. It is not, so that's great. Now I'll have it print CVD vendors. Oh, I forgot to rename this. It should work. Fuck. Oh wait, no. That's fine. I made it throw an error to say entry. So it says okay, entry. So it's all okay. And it works. Ta-da! This is way more work than needs to be. This prints only two characters, whatever. So it's like a byte. So I need to rename this type to byte. It's not a word. It's not 16-bit. That's a nibble. And a nibble, it's 8-bit. Alright, so now I rename this to 8-bit. I rename this to 16-bit. So now the name at least matches what it is. And now I need to add a new option. 64-bit. Can I use an assign for this? Enum. If I can, then I can auto accumulate it. So I'm going to define this assign to length. This assign to length. Or I'll name it length, whatever. Great. I ended up with 3 underscores. That's cool. Now I have to like accumulate it between each one. So I don't know if this is any more useful than just defining it. Nope, can't use an assign. What if it's X define? Oh, it works. Now I gotta check to like make sure that the length is never less than or equal to 0. I think I can finally add another option. I need to get some pop. I'm so freaking tired. I already added the type. Let's write both this. So now all I have to do is find all the places where it's defined for this type option, then add another option the 64-bit type. Make a copy of the type above it. Paste. Paste. And then put in the new type. I need some water. So bad. Now, it should still build as it was. I'm going to pick the new type. So now, this should throw an error because I put an error on purpose to see if it enters. And it should. And it did. Good. Finally. So I need to like so now I can finally set up the freaking type parameters, whatever, parameters, or whatever. The mic is like extremely laggy. So I can almost benchmark stuff. This took way too long. I don't know, baby. I need to get some freaking pop, soda. I'm dying. Caffeine. So if I like try to focus, hurry up, maybe in 30 minutes, I can like benchmark at least clock cycles. It's not real time, but it's something. So that's what I'm trying to do. The soda, pop, whatever, caffeine, it's kind of working. Hopefully, it'll wake me up. there's a bunch of tiny little differences between C and the assembler. 63. I forgot to turn on Siri, whatever. $64 is 1 bit over 63. So that's outside of the range of the instruction for 64-bit. On x64, because they mask it. They just keep the bits below. So 63 is the maximum number of bits you can shift register. Because you can shift register 0 times, which means that there's always 1 bit left in the register. In C language, you can right shift 64, and I think it does as expected. Maybe it doesn't, I don't remember. But in the assembler, whatever, if you shift 64, it it fails the test. So I have like I have this test, whatever. Here's the value to set as the default value. I take the default value, if whatever, I shift it right by the size t whatever, or the sign bit, which is 63. Except I was adding 1. So it's shifting right. 15 plus 1. Or 7 plus 1. So this type, 64-bit. So I did 63, and I had plus 1 here. So it looked like the other ones. Plus 1. And I just wasted maybe 20 minutes. I'm like, how the hell is this bigger than 64 bits? What's happening? I just figured it out. It's plus 1. Because technically, you can't shift 64 bits, but you can. You can shift 63 bits, wrap it in parentheses, and then shift it one more time. And now, it shifted 64 bits. You just can't encode it in instruction physically. So you have to put like another shift to shift 1 afterwards. That's my super exciting story. I think I'm almost there. I just lost some time. I can almost speed test it. I'm so close. I can almost benchmark stuff. I'm so close. I can almost taste it. but I need to taste some water because my throat is so dry. So, I'll be right.
const binding list in yield await, lexical binding in yield await, binding list in yield await, lexical binding in yield await, lexical binding in yield await, binding identifier yield await, initializer in yield await opt, binding pattern yield await, initializer in yield await, variable statement yield await, our variable declaration list, plus in yield await, variable declaration list in yield await, variable declaration in yield await, variable declaration list in yield await, variable declaration in yield await, variable declaration in yield await, binding identifier yield await, initializer in yield await opt, binding pattern yield await, initializer in yield await, binding pattern yield await, object binding pattern yield await, array binding pattern yield await, object binding pattern yield await, binding rest property yield await, binding property list yield await, binding property list yield await, binding rest property yield await opt, array binding pattern yield await, elisionort binding rest element yield await opt, binding element list yield await, binding element list yield await, elisionort binding rest element yield await opt, binding rest property yield await dart, binding identifier yield await, binding property list yield await, binding property yield await, binding property list yield await, binding property yield await, binding element list yield await, binding elision element yield await, binding element list yield await, binding elision element yield await, binding elision element yield await, elisionort binding element yield await, binding property yield await, single name binding yield await, property name yield await, binding element yield await, binding element yield await, single name binding yield await, binding pattern yield await, initializer plus in yield await opt, single name binding yield await, binding identifier yield await, initializer plus in yield await opt, ECMA International 2024 755, binding rest element yield await dart, binding identifier yield await, binding pattern yield await, empty statement, expression statement yield await, look ahead, function async, no line terminator here, function class let expression plus in yield await, if statement yield await, return if expression plus in yield await, statement yield await return, else statement yield await return, if expression plus in yield await, statement yield await return, look ahead else, iteration statement yield await return, do while statement yield await return, while statement yield await return, for statement yield await return, for an of statement yield await return, do while statement yield await return, do statement yield await return, while expression plus in question mark yield await, while statement yield await return, while expression plus in yield await, statement yield await return, for statement yield await return, for look ahead let expression in yield await opt, expression plus in yield await opt, expression plus in yield await opt, statement yield await return, for var variable declaration list in yield await, expression plus in yield await opt, expression plus in yield await opt, statement yield await return, for lexical declaration in yield await, expression plus in yield await opt, expression plus in yield await opt, statement yield await return, for in of statement yield await return, for look ahead let left hand side expression yield await in expression plus in yield await, statement yield await return, for var for binding yield await in expression plus in yield await, statement yield await return, for declaration yield await in expression plus in yield await, statement yield await return, for look ahead let async of left hand side expression yield await of assignment expression plus in yield await, statement yield await return. 4. var for binding yield await, of assignment expression, plus in yield await, statement yield await return. 4. for declaration yield await, of assignment expression, plus in yield await, statement yield await return, plus await, for await, look ahead left-hand side expression yield await, of assignment expression, plus in yield await, statement yield await return, plus await, for await, var for binding yield await, of assignment expression, plus in yield await, statement yield await return, plus await, for await, for declaration yield await, of assignment expression, plus in yield await, statement yield await return, for declaration, yield, await. Let or const for binding yield await. 56. ECMA International 2024 for binding, yield, await, binding identifier yield await, binding pattern yield await, continue statement, yield, await, continue, no line terminator here, label identifier yield await, break statement, yield, await, break, no line terminator here, label identifier yield await, return statement, yield, await, return, no line terminator here, expression, plus in yield await, with statement, yield, await, return, with, expression, plus in yield await, statement yield await return, switch statement, yield, await, return, switch, expression, plus in yield await, case block yield await return, case block, yield, await, return, case clauses yield await return opt, case clauses yield await return opt, default clause yield await return, case clauses yield await return opt, case clauses, yield, await, return, case clause yield await return, case clauses yield await re2, rn, case clause yield await return, case clause, yield, await, return, case expression, plus in yield await, statement list yield await return opt, default clause, yield, await, return, default, statement list yield await return opt, labeled statement, yield, await, return, label identifier yield await, labeled item yield await return, labeled item, yield, await, return, statement yield await return, function declaration yield await, default, throw statement, yield, await, throw, no line terminator here, expression, plus in yield await, try statement, yield, await, return, try block yield await return, catch yield await return, try block yield await return, finally yield await return, try block yield await return, catch yield await return, finally yield await return, catch, yield, await, return, catch parameter yield await, block yield await return, catch block yield await return, finally, yield, await, return, finally block yield await return, catch parameter, yield, await, binding identifier yield await, binding pattern yield await, debugger statement, debugger, ECMA International 2024 757, A. 4 functions and classes, unique formal parameters, yield, await, formal parameters yield await, formal parameters, yield, await, empty, function rest parameter yield await, formal parameter list yield await, formal parameter list yield await, formal parameter list yield await, function rest parameter yield await, formal parameter list, yield, await, formal parameter yield await, formal parameter list yield await, formal parameter yield await, function rest parameter, yield, await, binding rest element yield await, formal parameter, yield, await, binding element yield await, function declaration, yield, await, default, function binding identifier yield await, formal parameters, yield, await, function body, yield, await, plus default, function, formal parameters, yield, await, function body, yield, await, function expression, function binding identifier, yield, await opt formal parameters, yield, await, function body, yield, await, function body, yield, await, function statement list yield await, function statement list, yield, await, statement list yield await, plus return opt arrow function, in, yield, await, arrow parameters yield await, no line terminator here, equals, concise body in, arrow parameters, yield, await, binding identifier yield await, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, yield await, concise body, in, look ahead, expression body in, await, function body, yield, await, expression body, in, await, assignment expression in, yield await, when processing an instance of the production, arrow parameters, yield, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, yield await, await. The interpretation of cover parenthesized expression and arrow parameter list is refined using the following grammar. Arrow formal parameters, yield, await. Unique formal parameters yield await. 58. ECMA International 2024. Async arrow function, in, yield, await. Async. No line terminator here. Async arrow binding identifier yield. No line terminator here. Equals async concise body in, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, yield await, async concise body in, async concise body, in, look ahead, expression body in, plus await, async function body, async arrow binding identifier, yield, binding identifier yield, plus await, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, yield, await. No line terminator here, equals. Member expression yield await. Arguments yield await. When processing an instance of the production, async arrow function, in, yield, await, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, yield await. No line terminator here, equals, async concise body in, the interpretation of, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, is refined using the following grammar. Async arrowhead, async. No line terminator here, arrow formal parameters, yield, plus await. Method definition, yield, await. Class element name yield await. Unique formal parameters, yield, await. Function body, yield, await. generator method yield await, async method yield await, async generator method yield await, get class element name yield await, function body, yield, await, set class element name yield await, property set parameter list, function body, yield, await, property set parameter list, formal parameter, yield, await, generator declaration, yield, await, default, function binding identifier yield await, formal parameters, plus yield, await, generator body, plus default, function, formal parameters, plus yield, await, generator body, generator expression, function binding identifier, plus yield, await opt formal parameters, plus yield, await, generator body, generator method, yield, await, class element name yield await, unique formal parameters, plus yield, await, generator body, function body, plus yield, await, yield expression, in, await, yield, no line terminator here, assignment expression in, plus yield await, yield, no line terminator here, assignment expression in, plus yield await. ECMA International 2024 759. Async generator declaration. Yield. Await. Default. Async. No line terminator here. Function binding identifier yield await. Formal parameters. Plus yield. Plus await. Async generator body. Plus default. Async. No line terminator here. Function. Formal parameters. Plus yield. Plus await, async generator body, async generator expression, async, no line terminator here, function binding identifier, plus yield, plus await opt formal parameters, plus yield, plus await, async generator body, async generator method, yield, await, async, no line terminator here, class element name yield await, unique formal parameters, plus yield, plus await, async generator body, function body, plus yield, plus await, async function declaration, yield, await, default, async, no line terminator here, function binding identifier yield await, formal parameters, yield, plus await, async function body, plus default, async, no line terminator here, function, formal parameters, yield, plus await, async function body, async function expression, async, no line terminator here, function binding identifier, yield, plus await opt, formal parameters, yield, plus await, async function body, async method, yield, await, async, no line terminator here, class element name yield await, unique formal parameters, yield, plus await, async function body, function body, yield, plus await expression, yield, await unary expression yield, plus await class declaration, yield, await, default, class binding identifier yield await, class tail yield await, plus default, class tail yield await, class expression, yield, await, class binding identifier yield await op, class tail yield await, class tail, yield, await, class heritage yield await opt, class body yield await opt, class heritage, yield, await, extends left-hand side expression yield await, class body, yield, await, class element list yield await, class element list, yield, await, class element yield await, class element list yield await, class element yield await, class element, yield, await, method definition yield await, static method definition yield await, field definition yield await, static field definition yield await, class static block, field definition, yield, await, class element name yield await, initializer, plus in yield await opt, left curly bracket, 60, ECMA International 2024, left curly bracket, class element name, yield, await, property name yield await, private identifier class static block, static, class static block body, class static block body, class static block statement list, class static block statement list, yield, plus await, return opt, a, 5 scripts and modules. Script, script body opt, script body, statement list, yield, await, return, module, module body opt, module body, module item list, module item list, module item list, module item, import declaration, export declaration, statement list item, yield.
So, I think
Import declaration.
I can almost print the result or whatever, or like to the list or whatever.
Default binding, namespace import imported default binding, named imports, imported default binding, imported binding, name
And
binding, named imports, imports list,
I rewrote this twice.
imports list, import specifier, imported
I'm going to rewrite this again.
2024 761, module specifier, string literal, imported binding, binding I
Because I want to put this in like the speed test loop or whatever to benchmark it.
imports, export variable statement, yield, plus await, export declaration, yield, plus await, export default hoistable declaration,
That way I don't have to write code to benchmark because I have some stuff, whatever I want to benchmark.
look ahead.
And it's also being used for whatever.
No line terminator here, function, class,
So I'm going to like modify this one to set the A high register.
module export name,
Because A high register, there's AL and A high and AX register. The high is the upper 8 bits, AL is the lower. And setting or using A high register is like a big no-no. In x86, it's frowned upon. And if you like set or use the high register, you're gonna be like made fun of. And you also, the program will suffer in performance because for whatever reason, however they designed later processors, accessing the high register funks with a whole bunch of like instruction decoding or whatever. So I rewrote this
sep, exponent,
to not use the AI register. And I originally wrote it to like save the value in DL and swap it back, whatever. But now I got it to like
be right sign,
move DL into AL. Then I shift right the DX register 8 because I want to get a nibble. Convert the text, get the next nibble, convert the text. So I don't need to sort back to RDX. So I shift right, RDX 8. I'm just going to destroy the value. It doesn't matter, I just got to print it. And I shift left, AX 8, which means that the 8 bits that were at the bottom of the AX register are shift left 4. So then when I do a shift right, AL 4, I split the register in half.
time separator, extended, plus
So A high register
digit, 2 decimal digit, 3 decimal digit, 4 decimal digit, 5 decimal digit, temporal decimal fraction, temporal decimal separated decimal digit, 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 decimal digit, temporal decimal separated decimal digit, decimal digit, decimal digit, temporal decimal separated decimal digit, decimal digit, decimal digit, decimal digit, temporal decimal separated decimal digit, decimal digit, decimal digit, decimal digit, decimal digit, decimal digit. ECMA International 2024. 63. Decimal digit, 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 temporal decimal separator, 1 of a 8 regular expressions, pattern, Unicode mode, Unicode sets mode, named capture groups, disjunction Unicode mode, Unicode sets mode, named capture groups, disjunction, Unicode mode, Unicode sets mode, named capture groups, alternative Unicode mode, Unicode sets mode, named capture groups, alternative Unicode mode, Unicode sets mode, named capture groups, disjunction Unicode mode, Unicode sets mode, named capture groups, alternative Unicode mode, Unicode sets mode, named capture groups, empty, alternative Unicode mode, Unicode sets mode, named capture groups, term Unicode mode, Unicode sets mode, named capture groups, term Unicode mode, Unicode sets mode, named capture groups, assertion Unicode mode, Unicode sets mode, named capture groups, atom Unicode mode, Unicode sets mode, named capture groups, atom Unicode mode, Unicode sets mode, named capture groups, quantifier, assertion, Unicode mode, Unicode sets mode, named capture groups, B, capital B, question mark, equals disjunction Unicode mode, Unicode sets mode, named capture groups, disjunction Unicode mode, Unicode sets mode, named capture groups, equals disjunction Unicode mode, Unicode sets mode, named capture groups, disjunction Unicode mode, Unicode sets mode, named capture groups, quantifier, quantifier prefix, quantifier prefix, plus decimal digits, sep decimal digits, sep decimal digits, sep decimal digits, sep atom, Unicode mode, Unicode sets mode, named capture groups, pattern character, atom escape Unicode mode, named capture groups, character class Unicode mode, Unicode sets mode, group specifier Unicode mode opt, disjunction Unicode mode, Unicode sets mode, named capture groups, colon disjunction Unicode mode, Unicode sets mode, named capture groups, syntax character, 1 of $sign plus pattern character, source character but not syntax character. 64. ECMA International 2024. Atom escape. Unicode mode. Named capture groups. Decimal escape. Character class escape Unicode mode. Character escape Unicode mode. Plus named capture groups. K group name Unicode mode. Character escape. Unicode mode. Control escape. CSI letter. Look ahead decimal digit. Hex escape sequence regexp Unicode escape sequence Unicode mode. Identity escape Unicode mode. Control escape. 1 of FNRTV. Group specifier. Unicode mode. Group name Unicode mode. Group name. Unicode mode. regexp identifier name Unicode mode. regexp identifier name. Unicode mode. regexp identifier start Unicode mode. regexp identifier name Unicode mode. regexp identifier part Unicode mode. regexp identifier start. Unicode mode. Identifier start char. regexp Unicode escape sequence. Plus Unicode mode. Unicode mode. Unicode lead surrogate Unicode trail surrogate regexp identifier part. Unicode mode. Identifier part char. regexp Unicode escape sequencer. Plus Unicode mode. Unicode mode. Unicode lead surrogate Unicode trail surrogate.
Okay. So
Unicode mode. UHEX lead surrogate. Plus Unicode mode. UHEX trail surrogate. Plus Unicode mode. UHEX non-surrogate. Unicode mode. UHEX 4 digits. Plus Unicode mode. U. Code point. Unicode lead surrogate. Any Unicode code point in the inclusive interval from U plus D800 to U plus DBFF. Unicode trail surrogate. Any Unicode code point in the inclusive interval from U plus DC00 to U plus DFFF. Each UHEX trail surrogate for which the choice of associated UHEX lead surrogate is ambiguous shall be associated with the nearest possible UHEX lead surrogate that would otherwise have no corresponding UHEX trail surrogate. Hex lead surrogate. Hex 4 digits, but only if the NV of hex 4 digits is in the inclusive interval from 0xd800 to 0xdbff. Hex trail surrogate. Hex 4 digits, but only if the NV of hex 4 digits is in the inclusive interval from 0xdc00 to 0xdfff. Hex non-surrogate. Hex 4 digits, but only if the NV of...
So, I rewrote this to not use the A high register. The A high register is 8 bits above the AL register. So I set RAX, that's a 64-bit, the full register, to RDX. That's faster than setting the lower registers.
Capital.
And then I set RDX, I shift right, RDX 8 bits. So it's ready. I drank some water, my throat is still killing me. So I shift right, RDX, which means I shift off these bits here. I shift in 8 bits at the top that are 0. So now RDX is ready for the next entry, and the 8 bits are at the bottom. So I don't know, that's all done. So now RAX holds whatever RDX was, and what I wanted was just AL, but doing move RAX, RDX, setting the whole 64 bits. I think that's actually faster because of how it's set up. So I don't know, I'm gonna speed test to find out if that's true or not. And then I shifted right, RDX, the next entry. I already said that. So I'm doing this because I have to get 4 bits and then 4 bits to print the value in hexadecimal, and I have to print the whole 64-bit value because the timer is a 64-bit value. 64-bit, 64-bit. Did I say 64-bit?
TERS Unicode.
So now RDX is set up, ready for the next entry to pass in the next byte. And then I shift left RAX 8. So let's say I care only about these bits that were set.
Mode Unicode.
So I made underline whatever. Make it like a hashtag.
Non-empty class ranges Unicode mode plus Unicode sets mode.
So those are the important bits I care about. They need to preserve.
Class ranges no dash Unicode.
Xlat is an old instruction. It uses RBX as the address or whatever. And then AL is what's passed in to get a value at a 256 byte table. So it's literally a byte lookup. That's all it is. I could just use a move, but I want to try this whatever, because it seems to, it's supported whatever, so I was going to try it. Just because.
Unicode mode. Source.
So, I shift left, AX. I don't know, I'll show the example after. It is the same thing, except I use A high. And then I try to rewrite it so I don't use A high. So I don't know. I'll speed test between this and this after I rewrite this to use the A high register to see if there's any difference. Because the A high register, using it should be slower. So I want to test it, whatever. So I need to drink some more water. But
class set operand class.
When I shift left, AX, 8 bits,
Nested class string disjunction class set character. Nested class. Look ahead. Class contents. Plus Unicode mode. Plus Unicode sets mode. Class contents. Plus Unicode mode. Plus Unicode sets mode. Character class.
Maybe I should mask. That would be faster. I don't know, I'll just keep the shift.
String disjunction
So if I shift left, 8 bits.
Class string disjunction contents class string.
Now, the bottom 8 bits in AL are inside of A high. And when it does a shift, it fills the bottom with 0 bits.
Capital S, E, T, capital.
Then I do a shift right 4, but in AL. So this way, I'm not using the A high register. Only like RAX, AX, and AL. I'm making sure not to like use A high. So that's the whole point, whatever. I shift right, AL4.
L, A, S, S, capital S, E, T.
That should be AX.
E, S, E, R, V, E, D, capital D, O, U, B, L, E, capital P, U, N, C, T, U, A, T, 1 of, and $% plus equals.
It might be faster to just use the A register. But anyways, I don't know, I gotta test it. So shift to left 8, and then shift to right 4.
Semantics defined in the syntax
So the shift right 4 is gonna be 1, 2, 3, 4.
of the syntax is normative but optional.
I'll set 0s to the top.
A browser. Note the syntax describes various legacy features and
Now all the spacing is messed up.
specified in the syntax have one or more undesirable characteristics and in the absence of legacy usage would be removed from this specification. However, the usage of these features by large numbers of existing web pages means that web browsers must continue to.
Okay, now you see how like
User is
I'm gonna need my throat is so dry. I'm gonna need like a third instruction.
the web browser or is required to run the same legacy ECMAScript code that web browsers encounter. B. 1 additional syntax. B. 1.1 HTML-like comments. The syntax and semantics of 12.4 is extended as follows except that this extensio n is not allowed when parsing source text using the goal symbol module. Syntax. Input element hashbang or regexp. White space, line terminator comment token hashbang comment regular expression literal HTML close comment multi-line comment, single line comments single line HTML open comments single line HTML close comments single line delimited comment multi-line comment first comment linear opt line terminator multi-line comment chars opt HTML close comment opt first comment line capital S I N G L E capital L I N E capital D E L I M I T E D capital C O M M E N T capital C H A R ECMA International 2024 769 single line HTML open comment.
This will probably be slower than setting the high register. So I don't know. I don't think I can simplify it anymore.
Capital D E L I M I
So
capital C
it's still gonna do the shift left 8, then shift right 4, and I'm gonna shift right AL4.
R HTML close
So this gets shift right 4.
I N
So these bottom 4 bits, shift it off.
I N E capital D E L I M I T E D capital C O M M E N T capital S E Q U single line comment JavaScript capital S I N G L E capital L I N E capital D E L I M I T E D capital C O M M E N
Could rotate. I could rotate. That'll be slower. So I don't know. This is as fast as I can get it. To like compare not using AI.
L I
So now AL holds holds the first nibble that was in DL, and it has the top 4 bits set to 0,
A capital
and then AI holds the next nibble with the 4 bits above it set to 0.
E capital P
So now these 4 bits are 0 to 15, so we can use it in xlat, and it'll look up the offset and grab the byte, which is hexadecimal character.
M E N
So that's what we'll do here. So now it's shifted right, AL4,
one of our line terminator capital S
xlat is going to call the instruction whatever and destroy whatever's in AL and set it to the value that's returned. And it's going to rotate right, AX, 8 bits.
E O M M E N T cap
So now this is AX, it's 16 bits.
N E capital S
It's going to rotate right. So it goes right, 8 bits. And these 8 bits,
capital S L A
like that's 1 bit rotated.
O R capital A
It's 2 bits rotated.
capital S I N G L E capital
3 bits rotated.
capital D E L I M I T E
Then 4 bits rotated.
O M
Do you see how it's like rotating whatever? I don't know. And then it rotates 4 more bits.
S I N G
This is probably going to be slower than using the AI register. Okay, so now after the rotate, AL holds what was in AI without moving to AI. Instead, use the rotate. Is it better to just use AI? I don't know. That's what I want to find out. So I wrote it up both ways, whatever. So I have to fix the way I wrote it, because I need a third move in here.
W A R
But anyways, this way I can test whatever speed test stuff.
R capital A S T source character but not one of oral line terminator one
So, I don't know. Super duper, a lot of fun.
I N G L E capital L
So I'm gonna like tweak this
E E
to count for the couple things I missed.
I T E D, capital C, O, M, M, E, N, T, capital S, E, Q, U, single line delimited comment white space sequenciart, capital S, I, N, G, L, E, capital L, I, N, E, capital D, E, L, I, M, I, T, E, D, capital C,
Alright, I'm gonna rewrite this.
N, T, capital S, E,
But this time I'll use the AI register.
point.
And I'm gonna like test this. And I have to paste this
Purposes of passing by the syntactic
for however many bytes there are. So it's 8 bytes.
syntax of two
So I gotta paste it 7 times.
T's that are broken by the ordering of grammar.
And I also want to test if a loop will be faster than inlining. So I don't know, I have a bunch of things I want to test.
And grammar and semantics.
And I should be able to, if this is working, because I use this to print to
With the Unicode mode.
this window, whatever.
However, none of these extensions
And also like copy paste and make a copy of it to speed test whatever.
code mode. Parameter present on the goal symbol 70. Copyright sign. ECMA International 2024. Syntax. Term. Unicode mode. Unicode sets mode. Named capture groups. Plus Unicode mode. Assertion.
So if I'm going for like minimal operations, I do
Unicode sets mode. Named cap.
AI
Mode Unicode sets mode. Named
set it to TL.
quantifiable assertion. Named
Shift right AX8.
mode. Assertion.
4.
Code sets mode. Named capture groups.
That splits it in half.
Named capture groups. Quantifier. Unicode mode. Extended atom num. Ed capture groups. Assertion. Unicode
I still gotta rotate RDX.
groups. B capital B plus Unicode mode equals disjunction plus Unicode mode Unicode
And then
disjunction.
shift right AL4.
Named capture groups. Unicode mode. Quantifiable assertion. Named capture groups, comma equals disjunction. Unicode mode Unicode sets mode. Named capture groups. Disjunction. Unicode mode Unicode sets mode. Named capture groups. Quantifiable assertion. Named capture groups. Question mark equals disjunction. Unicode mode. Unicode sets mode. Named capture groups. Disjunction. Unicode mode. Unicode sets mode. Named capture groups. Extended atom. Named capture groups. Atom escape. Unicode mode. Named capture groups. Look ahead equals C. Character class. Unicode mode. Unicode sets mode. Group specifier. Unicode mode opt. Disjunction. Unicode mode. Unicode sets mode. Named capture groups. Disjunction. Unicode mode. Unicode sets mode. Named capture groups. Invalid braced quantifier. Extended pattern character. Invalid braced quantifier. Decimal digits. SEP. Decimal digits. SEP. Decimal digits. SEP. Decimal digits. SEP. Extended pattern character. Source character but not one of $+ atom escape. Unicode mode. Named capture groups. Plus Unicode mode. Decimal escape. Unicode mode. Decimal escape but only if the capturing group number of decimal escape is count left. Capturing pair ends within the pattern containing decimal escape. Character class escape Unicode mode. Character escape Unicode mode. Named capture groups. Plus named capture groups. K group name Unicode mode. ECMA International 2024 771. Character escape. Unicode mode. Named capture groups. Control escape. CSI letter. Look ahead decimal digit. Hex escape sequence Regi XP Unicode escape sequence Unicode mode. Unicode mode. Legacy octal escape sequence identity escape Unicode mode. Named capture groups. Identity escape. Unicode mode. named capture groups, plus Unicode mode. Syntax character plus Unicode mode. Unicode mode. Source character identity escape named capture groups. Source character identity escape. Named capture groups. Named capture groups. Source character but not C, plus named capture groups. Source character but not one of C or K. Class atom note dash. Unicode mode. Named capture groups. Source character but not one of or class escape Unicode mode named capture groups. Look ahead equals C. Class escape. Unicode mode. Named capture groups. B plus Unicode mode. Unicode mode. C class control letter character class escape Unicode mode. Character escape Unicode mode named capture groups. Class control letter. Decimal digit. B. 1. 2. 1 static semantics. Early errors. The semantics of 2 2. 2. 1. 1 is extended as follows. Extended atom. Invalid braced quantifier. It is a syntax error if any source text is matched by this production. Additionally, the rules for the following productions are modified with the addition of the highlighted text. Non-empty class ranges. Class atom. Class atom class contents. Note when the same left-hand sides occurs with both plus Unicode mode and Unicode mode. Guards it is to control the disambiguation priority, comma, it is a syntax error if is character class of the first class atom is true or as character class of the second class atom is true in this production has a Unicode mode parameter. It is a syntax error if is character class of the first class atom is false, is character class of the second class atom is false, and the character value of the first class atom is strictly greater than the character value of the second class atom. 772. ECMA International 2024. Non-empty class ranges no dash. Class atom no dash. Class atom class contents. It is a syntax error if is character class of class atom no dash is true or as character class of class atom is true in this production has a Unicode mode parameter. It is a syntax error if is character class of class atom no dash is false. Is character class of class atom is false. And the character value of class atom no dash is strictly greater than the character value of class atom. B. 1. 2. 2 static semantics. Count left capturing parens within and count left capturing parens before. In the definitions of count left capturing parens within and count left capturing parens before, references to atom, group specific disjunction, are to be interpreted as meaning atom, group specific disjunction, or extended atom. Group specific disjunction. B. 1. 2. 3 static semantics. Is character class. The semantics of 2 2. 2. 1. 5 is extended as follows. Class atom no dash. Look ahead equals C. Return false. B. 1. 2. 4 static semantics. Character value. The semantics of 2 2. 2. 1. 6 is extended as follows. Class atom no dash. Look ahead equals C. Return the numeric value of U plus 005C. Reverse solidus. Class escape. C class control letter. Let CH be the code point matched by class control letter. Let I be the numeric value of CH. Return the remainder of dividing I by 32. Character escape. Legacy octal escape sequence. Return the MV of legacy octal escape sequence. C12, 9, 4. 3. B. 1. 2. 5 runtime semantics. Compile subpattern. The semantics of compile subpattern is extended as follows. The rule for term. Quantifiable assertion quantifier is the same as for term. Atom quantifier.
So, setting A high to DL. Shifting right, RDX 8. So let's prepare for the next iteration. Shift right. AX4 to split AL and A high. Shift right AL4 to split AL so that the top bits are 4 zeros and the bottom bits are 4 from DL. And then after that, A high is going to hold the top 4 bits. Of DL at the bottom 4 bits, with the top 4 bits of A high being 0, because zeros were shifted in from left. Then it calls xlat AL holds 4 bits. That's a lookup. It gets the byte, the char code. It rotates right. AX, 8 bytes. So now A high has already been set with 4 bits at the bottom, 0 bits at the top of the nibble, because there's 2 nibbles. It rotates right. So now AL holds those top 8 bits, and A high holds the bottom 8 bits. So now A high holds the 8 bits that were passed back from xlat in this instruction, so it's preserved. And AL is passed into xlat, and afterwards AL is going to hold whatever xlat fetched from the lookup table at the offset. That's like 4 bits.
Non-empty class ranges no dash, class atom no dash,
Super exciting.
set of class atom no dash with argument rare. Let
Now this is
atom with argument rare. Let C be compiled to char set of class contents with argument rare. Let D be character range or union. Rare A, B. Return the union of D and C. In addition, the following rules are added to compile to char set. Class escape.
this is 7 instructions. This one's 8. This will probably be slower.
CV. Return the char set.
If it's possible to get it to like
Char set contains
7 instructions too,
005
but it's not,
74. ECMA into
because I'm trying to not use AI. I could also mask whatever,
C within a character
but I might as well just shift or whatever.
code by an acceptable control character. B. 1, 2, 8. 1 character range or union. Rare A, B. The abstract operation character range or union takes arguments rare, a regexp record, A, a char set, and B, a char set, and returns a char set. It performs the following steps when called. If is either Unicode flag, rare, is false, then if A does not contain exactly 1 character or B does not contain exactly 1 character, then I let C be the char set containing the single character, U plus 002D, hyphen minus 2. Return the union of char sets A, B and C.
And then down here, I set RBX AL,
Next, U, V,
but
2.
I need to
Abstract operation parse pattern takes arguments pattern text, a sequence of Unicode code points, U, a boolean, and V, a boolean. It performs the following steps when called. If V is true and U is true, then a let parse result be a list containing 1 or more syntax error objects. Else if V is true, then a let parse result be parse text, pattern plus Unicode mode, plus Unicode sets mode, plus named capture groups 3. Else if U is true, then a let parse result be parse text, pattern, plus Unicode mode, Unicode sets mode, plus named capture groups. Else a let parse result be parse text, pattern, Unicode mode, Unicode sets mode, named capture groups. B if parse result is a parse node and parse result contains a group name, then I set parse result to parse text, pattern,
move this inside of the block.
groups. Return parse result. B. 2 additional built-in properties. When the ECMAScript host is a web browser, the following additional properties of the standard built-in objects are defined. B. 2.1 additional properties of the global object. The entries in Table 97 are added to Table 6. Table 97. Additional well-known intrinsic objects. Intrinsic name. Global name. ECMAScript language association. Escape %. Escape. The escape function. B. 2. 1. 1. Unescape percent. Unescape. The unescape function. B. 2. 1. 2. Copyright sign. ECMA International 2024. 75. B. 2. 1. 1 escape. String. This function is a property of the global object. It computes a new version of a string value in which certain code units have been replaced by a hexadecimal escape sequence. When replacing a code unit of numeric value less than or equal to 0 times 00FF, a 2-digit escape sequence of form %x hex is used. When replacing a code unit of numeric value strictly greater than 0 times 00FF, a 4-digit escape sequence of the form %UX hex is used. It is the %escape %intrinsic object. It performs the following steps when called. Set string to string. String. Let len be the length of string. Let r be the empty string. Let unescape set be the string concatenation of the ASCII word characters and at plus length 0. Repeat. While k. Len, let c be the code unit at index k within string. B if unescape set contains c. Then, I let s be e, c else. I let n be the numeric value of c. 2. If n, 256, then, let hex be the string representation of n, formatted as an uppercase hexadecimal number. Let s be the string concatenation of percent and string pad. Hex. 2. 0. Start. 3. Else, let hex be the string representation of n, formatted as an uppercase hexadecimal number. Let s be the string concatenation of %u in string pad. Hex. 4. 0. Start. D set r to the string concatenation of r and s. E set k to k plus 1. Return r. B. 2. 1. To unescape. String. This function is a property of the global object. It computes a new version of a string value in which each escape sequence of the sort that...
So this uses RD, RB, RA, so set RCX to RAX.
String. Let len be the length of string. Let r be the empty string. Length 0. Repeat. While k. Len. Note the encoding is partly based coding described in RFC 1738, but the entire encoding specified in this standard is described above without regard to the contents of RFC 1738.
Now, this should work. I'm gonna run it.
RFC 3986, 76.
It builds. It links. Let us run.
If C is the code unit 0 times 0025, %, then I2, 3. Let hex digits be the empty string. Let optional advance be 0. If k plus 5.
So, it looks like it almost ran.
075. Latin small letter u. Then 1. Set hex digits to the substring of string from k plus 2 to k plus 6. Set optional advance to 5. Else if k plus 3 len, then, set hex digits to the substring of string from k plus 1 to k plus 3. Set optional advance to 2. V let parse result be parse text. String to code points. Hex digits. Hex digits.
Turn this block off.
Node. Then, let n be the MV of parse result. Set C to the code unit whose numeric value is n. Set k to k plus optional advance. C set r to the string concatenation of r and c. D set k to k plus 1. 6. Return r. B. 2.2 additional properties of the string prototype object B. 2. 1 string prototype substar. Star.
This is 2.
Method returns a subs.
I think it's removed. I think it's removed below. Man, my throat is killing me.
Or through the end of the string if length is undefined. If start is negative, it is treated as source length plus start where source length is the length of the string. The result is a string value, not a string object. It performs the following steps when called. Let ob. Require object coercible. This value. Let size be the length of s. Let int start be to an integer or infinity. Start. If int start equals, set int start to 0. Else if int start 0, set int start to max. Size plus int start 0. Else set int start to min. Int start size. If length is undefined, let int length be size. Otherwise let int length be. To an integer or infinity, length, set int length to the result of clamping int length between 0 and size 0. Let int end be min. Int start plus int length, size 1. Return the substring of s from int start to int end. B. 2. String prototype anchor. Name. This method performs the following steps when called. Let s be the this value. Return. Create HTML. S. A. Name. B. 2. 1. Create HTML. String. Tag. Attribute. Value. The abstract operation create HTML takes argument string, an ECMAScript language value, tag, a string, attribute, a string, and value, an ECMAScript language value, and returns either a normal completion containing a string or a throw completion. It performs the following steps when called. Let str be. Require object coercible. String. Let s be. To string. str. Let page 1 be the string concatenation of and tag. If attribute is not the empty string, then note this method is intentionally generic.
Problem. It's with the formatting.
Therefore, it can be transferred to other kinds of objects for use as a method. ECMA International 2024 777. 1. 2. Let s be the this value. Return. Create HTML. S. Font. Size. 78. ECMA International 2024. Let VB. To string. Value. B. Let escaped be the string value that is the same as V except that each occurrence of the code unit 0 times 0022 quotation mark in V has been replaced with the 6 code unit sequence and quote. C. Set page 1 to the string concatenation of let page 2, let page 3, let page 4, return page 4. Black small square, black small square, black small square, black small square, black small square. Black small square. Page 1. The code unit 0 times 0020. Space. Attribute. The code unit 0 times 003D. Equals sign. The code unit 0 times 0022. Quotation mark escaped. The code unit 0 times 0022. Quotation mark. Be the string concatenation of page 1 and be the string concatenation of page 2 and s. Be the string concatenation of page 3, comma tag. And B. 2. 3 string prototype big. This method performs the following steps when called. Let s be the this value. Return. Create HTML. S. Big. B. 2. 4 string prototype blink. This method performs the following steps when called. Let s be the this value. Return. Create HTML. S. Blink. B. 2. 5 string prototype bold. This method performs the following steps when called. Let s be the this value. Return. Create HTML. S. B. 2. 6 string prototype fixed. This method performs the following steps when called. Let s be the this value. Return. Create HTML. S. B. 2. 7 string prototype font color. This method performs the following steps when called. Let s be the this value. Return. Create HTML. S. Font. Color. B. 2. 8 string prototype font size. This method performs the following steps when called. B. 2. 9 string prototype italics. This method performs the following steps when called. Let s be the this value. Return. Create HTML. S. B. The 2nd of February 2010 string prototype link. URL. This method performs the following steps when called. Let s be the this value. Return. Create HTML. S. A. Ref. URL. B. The 2nd of February 2011 string prototype small. This method performs the following steps when called. Let s be the this value. Return. Create HTML. S. Small. B. The 2nd of February 2012 string prototype strike. This method performs the following steps when called. Let s be the this value. Return. Create HTML. S. Strike. B. The 2nd of February 2013 string prototype sub. This method performs the following steps when called. Let s be the this value. Return. Create HTML s sub b. The 2nd of February 2014 string prototype sub. This method performs the following steps when called. Let s be the this value. Return. Create HTML s sub b. The 2nd of February 2015 string prototype trim left. The initial value of the trim left property is %string prototype trim start %, defined in 22.1, 3.34. Note the property trim start is preferred. The trim left property is provided principally for compatibility with old code. It is recommended that the trim start property be used in new ECMAScript code. ECMA International 2024 779. B. The 2nd of February 2016 string prototype trim right. The initial value of the trim right property is %string prototype trim end %, defined in 22.1.3.33. B. 2.3 additional properties of the date prototype object. B. 2.3. 1 date prototype get year. This method performs the following steps when called. Let date object be the this value. Perform. Require internal slot. Date object. Let t be date object. If t is none, return none. Return year from time. Local time. T. 1900. B. 2.3. 2 date prototype set year. Year. This method performs the following steps when called. Let date object be the this value. Perform. Require internal slot. Date object. Let t be date object. Let y be to number. Year. If t is none, set t to +0. Otherwise, set t to local time. T. Let y be make full year. Y. Let d be make day. Y. Month from time. T. Date from time. T. Let date be make date. D. Time within day. T. Let u be time clip. UTC. Date 0. Set date object u 1. Return u b 2. 3. 3 date prototype to GMT string. The initial value of the to GMT string property is %date prototype to UTC string %, defined in 2.1.4.4.4.3. Note the property trim end is preferred. The trim right property is provided principally for compatibility with old code. It is recommended that the trim end property be used in new ECMAScript code. The getFullYear method is preferred for nearly all purposes, because it avoids the year 2000. Note problem. The setFullYear method is preferred for nearly all purposes, because it avoids the year 2000. Note problem. The TUTC string method
I think I fixed it.
for compatibility with. Note old code 80. Copyright sign. ECMA International 2024. B. 2.4 additional properties of the regexp prototype object. B. 2.
So now, print it again. Try to print it.
Flags. This method performs the following steps when called. Let O be the this value. Perform. Require internal slot. O. If pattern is an object and pattern has the internal slot, then if flags is not undefined, throw a type error exception. B. Let P be pattern. C. Let F be pattern. Else A. Let P be pattern. B. Let F be flags. Return. regexp initialize. O. P. F. B. 3 other additional features. B. 3.1 labeled function declarations. Prior to ECMAScript 2015, the specification of labeled statement did not allow for the association of a statement label with a function declaration. However, a labeled function declaration was an allowable extension for non-strict code, and most browser-hosted ECMAScript implementations supported that extension. In ECMAScript 2015 and later, the grammar production for labeled statement permits use of function declaration as a labeled item, but 1.4.1.3.1 includes an early error rule that produces a syntax error if that occurs. That rule is modified with the addition of the highlighted text labeled item. Function declaration. It is a syntax error if any source text that is strict mode code is matched by this production. B. 3.2 block level function declarations. Web legacy compatibility semantics. Prior to ECMAScript 2015, the ECMAScript specification did not define the occurrence of a function declaration as an element of a block statement list. However, support for that form of function declaration was an allowable extension and most browser-hosted ECMAScript implementations permitted them. Unfortunately, the semantics of such declarations differ among those implementations. Because of these semantic differences, existing web ECMAScript source text that uses block-level function declarations is only portable among browser implementations if the usage only depends upon the semantic intersection of all of the browser implementations for such declarations. The following are the use cases that fall within that intersection semantics. A function is declared and only referenced within a single block. One or more function declarations whose binding identifier is the name f occur within the function code.
And
All occurrences of f as an
at the end, it's printing F1.
declaration of f.
So,
This method completely reinitializes this value regexp with a new pattern and flags. An implementation may interpret use of this method as an assertion that the resulting regexp object will be used multiple times and hence is a candidate for extra optimization. Note the early error rules for with statement, if statement, and iteration statement prevent these statements from containing a labeled function declaration in non-strict code. 2. A function is declared and possibly used within a single block but also referenced by an inner function definition that is not contained within that same block. One or more function declarations whose binding identifier is the name f occur within the function code of an enclosing function g and that declaration is nested within a block. No other declaration of f that is not of R declaration occurs within the function code of g. There may be occurrences of f as an identifier reference within the statement list of the block containing the declaration of f. There is at least one occurrence of f as an identifier reference within another function h that is nested within g and no other declaration of f shadows the references to f from within h. All invocations of h occur after the declaration of f has been evaluated. A function is declared and possibly used within a single block but also referenced within subsequent blocks. One or more function declaration whose binding identifier is the name f occur within the function code of an enclosing function g and that declaration is nested within a block. No other declaration of f that is not of R declaration occurs within the function code of g. There may be occurrences of f as an identifier reference within the statement list of the block containing the declaration of f. There is at least one occurrence of f as an identifier reference within the function code of g that lexically follows the block containing the declaration of f. The first use case is interoperable with the semantics of block-level function declarations provided by ECMAScript 2015. Any pre-existing ECMAScript source text that employs the use case will operate using the block-level function declarations semantics defined by clauses 10, 14, and 15. ECMAScript 2015 interoperability for the second and third use cases requires the following extensions to the clause 10, clause 15, clause 19, 2, 1 and clause 16, 1. 7 semantics. If an ECMAScript implementation has a mechanism for reporting diagnostic warning messages, a warning should be produced when code contains a function declaration for which these compatibility semantics are applied and introduce observable differences from non-compatibility semantics. For example, if a var binding is not introduced because its introduction would create an early error, a warning message should not be produced. B. 3, 2, 1 changes to capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, during capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I. The following steps are performed in place of step 29. 9. If strict is false, Then, 82, ECMA International 2024. A. For each function declaration F that is directly contained in the statement list of a block, case clause, or default clause, do I2 let F be string value of the binding identifier of F. If replacing the function declaration F with a variable statement that has F as a binding identifier would not produce any early errors for function parameter names does not contain F, then 2. Note: a var binding for F is only instantiated here if it is neither a var declared name, the name of a formal parameter, or another function declaration. If instantiated var names does not contain F and F is not arguments, then a perform var env create mutable binding F. False. B perform var env initialize binding F. Undefined. C append F to instantiated var names. When the function declaration F is evaluated, perform the following steps in place of the function declaration evaluation algorithm provided in 1.5.2.6 ABCDE. Let vend be the running execution context's variable environment. Let vend be the running execution context's lexical environment. Let fobj be benv get binding value F. False. Perform fenv set mutable binding F. Fobj. False. Return anu said B. 3. 2. 2 changes to global declaration instantiation. During global declaration instantiation, the following steps are performed in place of step 12. 12. Perform the following steps. B. 3. 2. 3. AB. Let strict be as strict of script. If strict is false, then I let declared function or var names be the list concatenation of declared function names and declared var names. 2. For each function declaration F that is directly contained in the statement list of a block, case clause, or default clause contained within script, do let F be string value of the binding identifier of F. If replacing the function declaration F with a variable statement that has F as a binding identifier would not produce any early errors for script, then if env has lexical declaration F is false, then I let F undefinable be env can declare global var F2. If F undefinable is true, then I note a var binding for F is only instantiated here if it is neither a var declared name nor the name of another function declaration. 2. If declared function or var names does not contain F, then I perform env create global var binding F. False. 2. Append F to declared function or var names. 3. When the function declaration F is evaluated, perform the following steps in place of the function declaration evaluation algorithm provided in 1.5.2.6. I let gen be the running execution context's variable environment. 2. Let ben
it prints 1, 2. Now it needs to call it 7 more times. And it should be working. So I need to use another register. So I'll set RDI to RBX. I need some more water. So our bx is going to hold the address to the byte array that has the hex points, circuit points, here, whatever, the destination array or address is computed here. I switched it to RDI. So now RDX set to R14, which is the loop count accumulate. So this picks which line each time, whatever. It's like 0, 1, 2, 3, 4, whatever. So that's fine as it is. RDX. Oh, this computer's so laggy. RDX is set to R14, which is the line number. RDI is set to the offset. RAX is set to the field offset. Multiply RDX by RAX to get the line, and then it adds to RDI RAX to get the offset in the line, and then it calls this macro that accounts for endian. So I'll flip the address or whatever if it's big endian, because it's assumed to be little endian. And then RBX is set to divide array. I just said that because RBX needs to be set for xlat. That's what it assumes, or not assumes. It's the register that it needs to be set because it uses RBX. And then here, I don't know, just set an RDX to random values. But that's set to this. So RDX is being set here. It's being used for the multiply here. Because multiply uses RDX, and RAX. Add here. So now I don't need to set the C register. and it should run the same. But it didn't. Oh, I forgot to pass in RDA for the increment. I think it works. So I gotta paste it. This macro 7 times. So now our BX holds the address that has the byte lookup table, and that stays the same. This whole thing, whatever RDI holds the address of the line, the offset inside line, and it calls this macro here. Well, this whole macro, whatever. And then it basically gets the bottom nibble of DL and then the top nibble of DL. It sets it to AL, to A high, to AL, rotates it. So AL is in A high. So the next get will set to AL and preserve the original value. And then does a move to RDI, A high, and it increments to memory, whatever. This might be an issue. When making it a little or big endian. I might need to make it move like the AX register and then add 2 to it, to the offset or whatever. Because I make the macro increment or decrement depending on if it's little or big endian. But that means the directions can be affected or no, but I don't know. It works for now. Ta-da! Now I can finally print the fucking timestamp. Fuck yeah. So, this is for timestamp. Let's check if it's entering here or whatever. Type in random stuff. Build. It enters because it printed the random stuff, which means that it is calling it to get the cycle count. It's calling it here and here, so I need to get these two values. I'll just print it all 16 times, whatever. So, right here, I guess, put this. Not really even, it's not really even computing anything right now. It doesn't matter. I just want to print it to see what it looks like. I'm gonna get some more pop and water, and I think I can finally speed test stuff. And then I can get back to parsing the program and converting it to 64-bit. This took up too much time setting up assembly stuff. My throat is so fucking dry. So move our AX, that's fine, because our AX is destroyed anyways in here. Move RDX, that's fine too, because RDX is being used. Pass in the value. Subtract RAX, RDX, so now RAX holds the end time. The last place that the cycle timestamp was called, the clock cycle timestamp. So subtracting from the end time, the start time, because the end time is the end point. So if it's at like 10, the start time is at 5. 10 minus 5 is the difference. Otherwise, they'll end up negated. This way it's positive. So move RDX, subtract, blah blah blah. This should work. But I should flip these around. So RDX ends up holding the value to pass in. Alright, now RDX holds the end time, AX holds the start time, subtracting RDX, RAX. So from the end time, the start time, we subtract it, which is the difference between the two. So let's see what that is. Da-da-da-da. It builds. And I'll click when I get back. I'm gonna set Siri to read the standard. I don't know why it keeps freaking crashing.
IASHN. During global declaration instantiation, the following steps are performed in place of step 12. 12. Perform the following steps. B. 3, 2, 3. AB. Let strict be as strict if script. If strict is false, then I let declared function or var names be the list concatenation of declared function names and declared var names. 2. For each function declaration f that is directly contained in the statement list of a block, case clause, or default clause contained within script, do let f be string value of the binding identifier of f. If replacing the function declaration f with a variable statement that has f as a binding identifier would not produce any early errors for script, then if env has lexical declaration f is false, then I let fn definable be env can declare global var f2. If fn definable is true, then I note a var binding for f is only instantiated here if it is neither a var declared name nor the name of another function declaration. 2. If declared function or var names does not contain f, then I perform env create global var binding f false. 2. Append f to declared function or var names. 3. When the function declaration f is evaluated, perform the following steps in place of the function declaration evaluation algorithm provided in 1.5.2.6. I let gent be the running execution context's variable environment. 2. Let ben be the running execution context's lexical environment. 3. Let fobj be benv get binding value f false. 5. Perform genv set mutable binding f fobj false. V return unused. Changes to eval declaration instantiation. During eval declaration instantiation, the following steps are performed in place of step 13. 3. If strict is false, then a let declared function or var names be the list concatenation of declared function names and declared var names be for each function declaration f that is directly contained in the statement list of a block, case clause, or default clause contained within body. Do I let f be string value of the binding identifier of f. 2. If replacing the function declaration f with a variable statement that has f as a binding identifier would not produce any early errors for body, then let binding exists be false. Let the CNV be lexCNV assert. The following loop will terminate. Repeat. While the CNV is not var-env, if the CNV is not an object environment record, then if the CNV has binding f is true, then I let binding exists be true be set the CNV to the CNV. If binding exists as false and var-env is a global environment record, then if var-env has lexical declaration f is false, then I let fn definable be var-env can declare global var fb else I let fn definable be false. 6. Else I let fn definable be true. If binding exists as false and fn definable is true, then if declared function or var names does not contain f, then ECMA International 2024 783. If var-env is a global environment record, then I perform var-env create global var binding f t ru 2. Else I let binding exists be var-env has binding f2. If binding exists as false, then I perform var-env create mutable binding f true. 2. Perform var-env initialize binding f undefined. 3. Append f to declared function or var names b when the function declaration f is evaluated. Perform the following steps in place of the function declaration evaluation algorithm provided in 1.5.2.6. I let gent be the running execution context's variable environment. 2. Let ben be the running execution context's lexical environment. 3. Let fobj be benv get binding value, f, false, iv. Perform genv set mutable binding, f, fobj, false, v return unused, b, 3, 2. 4 changes to block static semantics, early errors. The rules for the following production in 1.4, 2, 1 are modified with the addition of the highlighted text, block. Statement list. It is a syntax error if the lexically declared names of statement list contains any duplicate entries. It is a syntax error if any element of the lexically declared names of statement list also occurs in the are declared names of statement list. B. 3, 2. 5 changes to switch statement static semantics, early errors. The rules for the following production in 1.4, 1.2, 1 are modified with the addition of the highlighted text, switch statement, switch, expression, case block. It is a syntax error if the lexically declared names of case block contains any duplicate entries. It is a syntax error if any element of the lexically declared names of case block also occurs in the are declared names of case block. B. 3, 2. 6 changes to block declaration instantiation. During block declaration instantiation, the following steps are performed in place of step 3a2.1. 1. If env has binding, dn, is false, then perform env create mutable binding, dn, false. During block declaration instantiation, the following steps are performed in place of step 3b. 3. Perform the following steps. If the binding for fn in env is an uninitialized binding, then perform env initialize binding, fn, fo2. Else, 84. ECMA International 2024. AB. Assert. D is a function declaration. Perform env set mutable binding, fn, fo. False. Unless the source text match by this production is not strict mode code and the duplicate entries are only bound by function declarations. Unless the source text match by this production is not strict mode code and the duplicate entries are only bound by function declarations. B. 3.3 Function declarations in if statement clauses. The following augments the if statement production in 14.6. If statement, yield, await, return, if, expression, plus in yield await. Function declaration yield await, default, else statement yield await return. If, expression, plus in yield await, statement yield await return, else function declaration yield await, default. If, expression, plus in yield await, function declaration yield await, default, else funct on declaration yield await, default. If, expression, plus in yield await, function declaration yield await, default, look ahead else. This production only applies when parsing non-strict code. Source text match by this production is processed as if each matching occurrence of function declaration yield await, default, was the sole statement list item of a block statement occupying that position in the source text. The semantics of such a synthetic block statement includes the web legacy compatibility semantics specified in B. 3.2, B. 3.4 variable statements and catch blocks. The content of subclause 1.4, 1.5, 1 is replaced with the following: catch parameter, block. It is a syntax error if bound names of catch parameter contains any duplicate elements. It is a syntax error if any element of the bound names of catch parameter also occurs in the lexically declared names of block. It is a syntax error if any element of the bound names of catch parameter also occurs in the are declared names of block unless catch parameter is catch parameter binding identifier. This modified behavior also applies to var and function declarations introduced by direct eval calls contained within the block of a catch clause. This change is accomplished by modifying the algorithm of 1.9.2.1.3 as follows. Step 3di. 2ai is replaced by I if this env is not the environment record for a catch clause. Throw a syntax error exception. Step 13b. 2.4 AI is replaced by I if this env is not the environment record for a catch clause. Let binding exists be true. The block of a catch clause may contain var declarations that bind a name that is also bound by note the catch parameter. At runtime, such bindings are instantiated in the variable declaration environment. They do not shadow the same named bindings introduced by the catch parameter, and hence the initializer for such var declarations will assign to the corresponding catch parameter rather than the var binding. ECMA International 2024 785 B 3.5 initializers and foreign statement heads. The following augments the foreign of statement production in 1.4.7.5. Foreign of statement yield await return 4 var binding identifier yield await initializer in yield await in expression plus in yield await statement yield await return. This production only applies when parsing non-strict code. The static semantics of contains duplicate labels in 8.3.1 are augmented with the following. Foreign of statement 4 var binding identifier initializer in expression statement return contains duplicate labels of statement with argument label set. The static semantics of contains undefined break target in 8.3.2 are augmented with the following. Foreign of statement 4 var binding identifier initializer in expression statement return contains undefined break target of statement with argument label set. The static semantics of capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E in 8.3.3 are augmented with the following. Foreign of statement 4 var binding identifier initializer in expression statement return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of statement with arguments iteration set, and the static semantics of is destructuring in 1.4.7.5.2 are augmented with the following. Binding identifier yield await return false. The static semantics of var declared names in 8.2.6 are augmented with the following. Foreign of statement 4 var binding identifier initializer in expression statement let names 1 be the bound names of binding identifier, let names 2 be the var declared names of statement, return the list concatenation of names 1 and names 2. The static semantics of var scope declarations in 8.2.7 are augmented with the following. Foreign of statement 4 var binding identifier initializer in expression statement let declarations 1 be binding identifier, let declarations 2 be the var scope declarations of statement, return the list concatenation of declarations 1 and declarations 2. The runtime semantics of foreign of loop evaluation in 1.4.7.5.5 are augmented with the following. Foreign of statement 4 var binding identifier initializer in expression statement 2 let binding id be string value of binding identifier, let LHS be resolved binding id 86 ECMA International 2024 3. If is anonymous function definition initializer is true, then a let value be named evaluation of initializer with argument binding id, else a let RHS be evaluation of initializer be let value be get value RHS perform put value LHS value let key result be foreign of head evaluation expression enumerate return foreign of body evaluation binding identifier statement key result enumerate var binding label set b 3.6 The internal slot. An internal slot may exist on host-defined objects. Objects with an internal slot behave like undefined in the Boolean and is loosely equal abstract operations, and when used as an operand for the type of operator B3.6.1 changes to Boolean. The following step replaces step 3 of Boolean. If argument is an object and argument has an internal slot, return false. B3.6.2 changes to as loosely equal. The following steps replace step 4 of as loosely equal. 4. Perform the following steps. Note, objects with an internal slot are never created by this specification. However, the document tool object https://html.spec.wg.org/multipage.html#dom-document-all in web browsers is a host-defined exotic object with this slot that exists for web compatibility purposes. There are no other known examples of this type of object, and implementations should not create any with the exception of document tool. AB. Changes to the type-off operator. The following step replaces step 12 of the evaluation semantics for type-off. 2. If a val has an internal slot, return undefined. B. 3.7 Non-default behavior in host make job callback. The host make job callback abstract operation allows host switcher web browsers to specify non-default behavior. B. 3.8 Non-default behavior in host ensure can add private element. The host ensure can add private element abstract operation allows host switcher web browsers to specify non-default behavior. B. 3.6 3. If X is an object, X has an internal slot, and Y is either undefined or null, return true. If X is either undefined or null, Y is an object, and Y has an internal slot, return true. ECMA International 2024 787. Annex C. Informative. The strict mode of ECMAScript. The strict mode restriction and exceptions. Implements. Interface. Let. Package. Private. Protected. Public. Static. And yield are reserved words within strict mode code. 1.2.7.2. A conforming implementation, when processing strict mode code, must disallow instances of the production's numeric literal, legacy octal integer literal, and decimal integer literal, non-octal decimal integer literal. A conforming implementation, when processing strict mode code, must disallow instances of the production's escape sequence, legacy octal escape sequence, and escape sequence, non-octal decimal escape sequence. Assignment to an undeclared identifier or otherwise unresolvable reference does not create a property in the global object. When a simple assignment occurs within strict mode code, its left-hand side expression must not evaluate to an unresolvable reference. If it does, a reference error exception is thrown. 6.2.5.6. The left-hand side expression also may not be a reference to a data property with the attribute value false, to an accessor property with the attribute value internal slot is false. In these cases, a type error exception is thrown. 13.15. An identifier reference with the string value eval or arguments may not appear as the left-hand side expression of an assignment operator. 13.15. Or of an update expression. 13.4. Or as the unary expression operated upon by a prefix increment, 1.3.4.4, or a prefix decrement, 1.3.4.5. Operator. Arguments. Objects for strict functions define a non-configurable accessor property callee which throws a type error exception on access. 1.0.4.4.6. Arguments. Objects for strict functions do not dynamically share their array indexed property values with the corresponding formal parameter bindings of their functions. 1.0.4.4. For strict functions, if an arguments object is created, the binding of the local identifier arguments to the arguments object is immutable and hence may not be the target of an assignment expression. The 10th of February 2011. It is a syntax error if the string value of a binding identifier is either eval or arguments within strict mode code. 1.3.1.1. Strict mode eval code cannot instantiate variables or functions in the variable environment of the caller to eval. Instead, a new variable environment is created and that environment is used for declaration binding instantiation for the eval code. 1.9.2.1. If this is evaluated within strict mode code, then this value is not coerced to an object. This value of either undefined or null is not converted to the global object and primitive values are not converted to wrapper objects. This value passed via a function call, including calls made using function prototype apply and function prototype call, do not coerce the pass this value to an object. 1.0.2.1.2.2.0.2.3.1. 2023. When a delete operator occurs within strict mode code, a syntax error is thrown if its unary expression is a direct reference to a variable, function argument, or function name. 13511. When a delete operator occurs within strict mode code, a type error is thrown if the property to be deleted has the attribute false, or otherwise cannot be deleted. 13512. Strict mode code may not include a with statement. The occurrence of a with statement in such a context is a syntax error. 14111. It is a syntax error if a catch parameter occurs within strict mode code and bound names of catch parameter contains either eval or arguments. 14151. It is a syntax error if the same binding identifier appears more than once in the formal parameters of a strict function. An attempt to create such a function using a function generator or a sync function constructor is a syntax error. 15212021111. An implementation may not extend beyond that defined in this specification. The meanings within strict functions of properties named caller or arguments of function instances. ECMA International 2024 789. See 4.2 for the definition of host. D. 1. Host hooks. Host call job callback. Capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R. Host enqueue generic job. Host enqueue promise job. Host enqueue timeout job. Host ensure can compile strings. Host finalize import meter. Host get import meter properties. Host grow shared array buffer. Host has source text available. Host load imported module. Host make job callback. Host promise rejection tracker. Host resize array buffer. Initialize host defined realm. D. 2 host defined fields. Host defined on realm records. See table 24. Host defined on script records. See table 40. Host defined on module records. See table 41. Host defined on job callback records. See table 28 on candidate executions. See table 96. CB 3.6. D. 3 host defined objects. The global object. See clause 19. Annex D. Informative. Host layering points. ECMA International 2024 791. D. For running jobs. Preparation steps before and cleanup steps after. Invocation of job abstract closures. C 9.5. D. 5 internal methods of exotic objects. Any of the essential internal methods in table 4 for any exotic object not specified within this specification. D. 6b. Built-in objects and methods. Any built-in objects and methods not defined within this specification, except as restricted in 17.192. Copyright sign. ECMA International 2024. Annex E. Informative. Corrections and clarifications in ECMAScript 2015 with possible compatibility impact. 1, 1, 4, 1, 5 to 9, 1, 1, 4, 1, 8 edition 5 and 5.1 used a property existence test to determine whether a global object property corresponding to a new global declaration already existed. ECMAScript 2015 uses a known property existence test.
And now it's super fun. x86 64. No, x32 64. Assembly language, benchmark, fun time. I don't know. That doesn't really have a ring to it, just a lot of words. I don't know. I'm gonna run it now.
Previous editions permitted the time clip abstract option to return either +0 or -0 as the representation of a zero time value. ECM
I'm gonna build it again for extra luck.
always return.
Because that's how things work. Not really.
Is never observably -0 and methods that return time values never.
And then run the exe.
3.2. If a UTC offset rep.
Oh man.
Edition 5.1 incorrectly stated that a missing time.
Choking on water. I'm drowning. No, I'm not. I'm drowning. Oh, I'm so pissed off. Why is it zeros?
1, 4, 4, 4, 1. Previous editions did not specify the value.
Now I'm angry. I'm coughing. This is gonna keep getting worse. What the heck? Did no time pass
2,
between the calls?
2, 2, 2, 6, 1. Any line terminate. Source property of a regexp instance must be expressed.
Instead, I'm not gonna subtract. I'll just print whatever's in one of them.
Of Dart 2, 2, 6, 8, 2, 2, 2, 6, 1, 1. In previous editions, the specifications for string prototype match and string prototype replace was incorrect for cases where the pattern argue
And then run it again.
whose global flag is set.
You gotta be kidding me. What the fuck? Chatbot. Chatbot sucks. Chatbot GPT. Chatbot GPT sucks. A bundle of dicks. A whole bundle of dicks. That's what ChatGPT sucks. Is a bundle of dicks.
Such as value is treated as if +0 was returned from the compare.
Because if I set it to like a real value,
Also specifies that to number is applied to the result returned by a compareFn. In previous editions, the effect of a compareFn result that is not a number value was implementation defined. In practice, implementations call to number ECMA International 2024 793 and XF informative additions and
so it should print 1, 2, 3, 4.
with prior editions, 2.5. In ECMAScript 2015, function calls are not allowed to return a reference record.
Oh, come on. It was too good to be true. Of course it's not going to work. Because that's how things tend to work. So instead, I'm going to call the other macro that gets real time.
In ECMAScript 2018, template
Because I just want something to print.
location instead of across all occurrences of that template literal or tag template in a realm in previous editions. 2.
And that's too much to ask for without a whole bunch of complication.
0, 0 or higher is mandated, as opposed to ECMAScript 2015 which mandated Unicode 5.1. In particular, this caused U plus 180 Mongolian vowel separator, which was in the space separator, Z's category and thus treated as whitespace in ECMAScript 2015, to be moved to the format CF categories of Unicode 6, 3, 0. This causes whitespace sensitive methods to behave differently. For example, U180e.trim.length was 0 in previous editions, but 1 in EC.
That's great. Moved all the code they used to get file time out of the file.
2017 mandated always using the latest
Oh, here's an example.
2.7.
I think I'm done choking on water. I think it passed. I'm probably dead. The water I was choking on, it probably filled my lungs. And I'm dead. Except this is hell anyways, so nothing changed. That's what probably happened. Only hell would have Windows as an operating system. It's ridiculous. What am I doing? Okay, that's what I'm doing. I want to get this time or whatever.
Property names in object initializers 1, 3. ECMAScript 2015. Strict mode code containing an assignment to an immutable binding such as the function name of a function expression does not produce an early error. Instead it produces a runtime error. 4.2. In ECMAScript 2015, a statement list beginning with the token let followed by the input elements line terminator then identifier as the start of a lexical declaration. In previous editions, automatic semicolon insertion would always insert a semicolon before the identifier input element. 4.5. In ECMAScript 2015, a statement list item beginning with the token let followed by the token is the start of a lexical declaration. In previous editions, such a sequence would be the start of an expression statement. 4. 6. 2. In ECMAScript 2015, the normal result of an if statement is never the value empty. If no statement part is evaluated or if the evaluated statement part produces a normal completion containing empty, the result of the if statement is undefined. 4.7. In ECMAScript 2015, if token of the for statement is similar followed the token sequence let, then the let is treated as the start of a lexical declaration. In previous editions, such a token sequence would be the start of an expression. 4.7. In ECMAScript 2015, if the token of a foreign statement is immediately followed by the token sequence let, then the let is treated as the start of a declaration. In previous edition, Suhat or Kern Solana would be the start of an left-hand side expression. 4.7. Prior to ECMAScript 2015, an initialization expression could appear as part of the variable declaration that precedes the in keyword. In ECMAScript 2015, the for binding in that same position does not allow the occurrence of such an initializer. In ECMAScript 2017, such an initializer is permitted only in non-strict code. 4.7. In ECMAScript 2015, the result of evaluating an iteration.
Oh no, I figured it out. It's because I'm calling to get the clock cycles after where I'm printing it. So it might work.
The normal
I just have to move it above.
4.1.1.2. In ECMAScript,
So make a copy of it
evaluating a with statement is no.
so don't mess it up. The original.
If evaluation of the statement part of a with statement produces a normal completion whose is empty, the result of evaluating the with statement is a normal completion whose is undefined. 4.1.2. 4. In ECMAScript 2015, the result of evaluating a switch statement is never a normal completion whose is empty. If evaluation of the case block part of a switch statement produces a normal completion whose is empty, the result of evaluating the switch statement is a normal completion whose is undefined. 4.15. In ECMAScript 2015, identifier that appears as the catch clause parameter. In previous editions, such a variable declaration would be instantiated in the enclosing variable environment, but the declaration's initializer value would be.
So I'll just call this up at the top
3. In
before anything else happens in the program.
15, a runtime syntax error is thrown if the catch clause evaluates an on. Strict direct eval whose eval code includes a var or function declaration that binds the same identifier that appears as the catch clause parameter. 4.1.5. 3. In ECMAScript 2015, the result of a try statement is never the value empty. If the block
I'll put the subtract back.
containing empty, the result of the try statement is undefined. If the block part of a try statement evaluates to a throw completion and it has a catch.
And now I can run it again. Please work.
If there is no finally clause or if it's finally clause.
No.
Completion. 5.4.5 in ECMAScript 2015. The function objects that are created as the values of the attribute of access are properties in an object literal and not constructor functions, and they do not have a prototype own property. In the previous edition, they were constructors and had a prototype property. 0, 1, 2, 6. In ECMAScript 2015, if the argument.
Wait. It's fine.
Extensible ordinary object with no own properties. In the previous edition, a non-object argument always causes a type error to be thrown. 0, 1.
Will it compute the difference between is tween a word? Does betwixt, because it sounds fancy. One thing betwixt another. Doesn't even make any sense. I'll just click it.
1, 0. In ECMAScript 2.
Oh, it's different. Oh my god, it's amazing. Something happened. It has an output. There's a chance that might work.
The result is used in place of the original argument value. In the previous edition, a non-object argument
6DAO.
1, 2, 1, 2 in ECMAScript 2015. If the argument to object get prototype of is not an object, an attempt is made to coerce the argument
Convert that to decimal, whatever.
used in place of the original argument value.
Using a handy dandy calculator.
0, 1, 2, 1, 6 in ECMAScript 2015. If the argument to object is extensible is not an object, it is treated as if it was a non-extensible ordinary object with no own properties. In the previous edition, a non-object argument always causes a type error to be thrown. 0, 1, 2, 1, 7 in ECMAScript 2015. If the argument to object is frozen is not an object, it is treated as if it.
Really? That many clock cycles?
In the previous edition, a non
What the hell is the CPU doing?
be thrown. 0, 1, 2, 1, 8 in ECMA
How the heck
field is not an object
do that many clock cycles happen between?
own properties. In the previous edition, a non-object argument always called
It's a huge number.
96. Copyright sign, ECMA International 2024, 201-219 in ECMAScript 2015. If the argument to object keys If the coercion is successful, the result is used in place of the original argument value. In the previous edition, a non-object
Oh, there is a loop that does nothing.
1, 2,
So I'll turn this loop off.
script 2015. If the argument to object prevent extensions is not an object, it is treated as if it was a non-extensible ordinary object with no own properties. In the previous edition, a non-object argument always causes a type error to be thrown. 0, 1, 2, 2, 2 in ECMAScript 2015. If the argument to object seal is not an object, it is treated as if it was a non-extensible ordinary object with no own properties. In the previous edition, a non-object argument always causes a type error to be thrown. 0, 2, 3, 2 in ECMAScript 2015. The internal slot of a bound function is set to the value of its target function. In the previous edition, was always set to %function prototype %.
Oh no. Is this mic working? Testing, testing, testing. This software sucks. Okay, so now I guess it's gonna get the cycle time of everything between, which is these. I don't know, because I got the mill turned off now. So now it's not gonna run. It's in the middle. So assemble, link, executable. Is that higher than last time? Was it 6 something? This is a bigger number. 60 AO and D07C. How's it bigger? I removed the loop. Why is the number bigger? Something tells me that not only is the cycle count not real time, but it's counting all the instructions on the CPU, not just this process. Which makes it even more useless. This is stupid. Why can't I just get the fucking time? God damn. I hate everything. I had to like Google stuff, figure this out. This is great. I'll see how much bigger this is than the other number. 60 AO. AO. It's like twice as big. It's more than twice as big. So moving the loop gave me a cycle count twice as big as last time. So I'm gonna run it one more time. I'm beginning to think that this is not. This is why. Okay. Jetpack gave me this in C code. And I was like, why the hell does it say 3 seconds? Why divide by the frequency? This is not anywhere close enough. It doesn't matter. I am so fucking disappointed in everything. This is bullshit. So, Run it again. See what happens. Okay, so it's possibly stable. This time it's 6 again. Run it again. Oh, we got 5. Back to 6. I guess the odds are 50-50. That would be double. So that's slow. Now it's 69. 69. Alright, I'm done. I gotta stop. Alright. 69 is a funny number. So, while I'm behind, because I can't ever seem to get ahead, I could connect that to the last joke, but I won't. I'm gonna be mature. Because I already hit. Never mind. Now I'm going to dang it didn't copy. Okay, I'm gonna get to begin and end time using the file time, I guess, because that's like the only time Windows will let you access. Unless you're the operating system, then you can do whatever you want. I won't get into it. It's ridiculous to call get system time versus file time and pass in an address. Like, what the hell? Just pass back the result in RAX like a normal function. It's stupid. It's so dumb. Now it's going to call get system time precise is fall time between where it's getting the cycle clock count. I'll see if the delay is larger than the cycle count, which is like assuming the cycle count isn't actually a time and is clock cycles. I don't know. It's not really comparable. Right. Now it's going to print whatever clock precise is fill time. Here we go. Please be like useful. Let me get something positive out of this. Then run exe. Oh man, bunch of zeros. It's not a good sign. I don't think bell time is very accurate. Well, maybe it is accurate. It's smaller than cycle time. I don't know what time unit that is. Is that 2 seconds? If there's 1,000 milliseconds in a second, I have no idea what the time is. Let's see if I run it again. It will be accurate or not. That same number. Okay, at least the file time looks more like a steady time. Now it's 1B. Now it's 1C26. 1C51. I can just keep clicking this. So 1B, FA, 1C, 1B, 1B, 1C. This looks more steady than the cycle count. A lot more steady. I think it was 1,000,000 iterations, not 1,000. Oh look, it's a teeny bit of time that elapsed. I don't like how it's 8. Again, makes me think that this clock is rigged. Oh, this clock is fake. It's fake as fuck. Ah, it's not even real. How the fuck do I get the real fucking time? Motherfuckers. This is not the real time. It's not possible. Look. 8. 8. 8. 8. This is not. This is not statistically possible. I'm gonna go cry in a corner. I just want the fucking time. So, I'm gonna figure out how to speed test this shit and get the real time. I'm gonna go cry in a corner for a little bit. I'm gonna go question my life and stuff. This is not accurate. I'll BRB. Okay, so this timer, the time now not time now. The get system time precise is file time. It's not very accurate. I think it's tied to the time scheduler. It's way too predictable. I'm gonna set this to 2,000 loops. And the lag. So 2,000 loops. I'm gonna see if I get 16 or not 16. That'd be 1-0 because it's hexadecimal. So times 2 is 1-0. I think this is 27. Oh no, that's literally 8. 8 what? So times 2. It's gonna give me 16. So it is 16. Well, it's 1-0 in hexadecimal. 16 in decimal. I am so disappointed. Really disappointed. I don't know why the OS doesn't give an accurate time. Is it to prevent hacking or timed attacks? Why would they intentionally not give real time? It's suspect. So, I don't know. I set the counter to twice as high. I'll like undo. I'll shift it. I'll just multiply by 2. So now it's like clearly twice the count of iterations. Assemble, link, run executable, and then a couple more times. Okay, it's taking longer to run this time. Okay. Oh my god. This can't be real. Are you fucking kidding me? It can't be that predictable. I'm so annoyed. This is so fake. So fucking. This is not how time works. Windows can suck a dick. I just want an accurate time. That's not too much to ask for. Just give me the fucking time. Not this pseudo time shit. This is so annoying. So getting the time in Windows is gonna be really annoying, I guess. I need to like figure out some way, if possible, to get the actual time, not the time schedule time, because that's gonna be like not whatever. So I don't know. I'm gonna turn on Siri, have it read the documentation, whatever. I'm gonna try to figure this out in a couple hours. If I can't, I'll just make the best of it. Until a new operating system comes out. It's best it can be for now, I guess. One day over the rainbow. This is so boring. I have to like get the stupid time to speed test some stuff, benchmark stuff. It's taking way too long. So I don't know. I'm trying to like figure this out in a couple hours or come to some solution at that point. I don't know. Like Google stuff. This is so boring though. I just want the time. All I want is the time. It's like really frustrating. It's so close. But just not quite the time. So it's gonna take my time. I'm gonna try not to spend too much time. I'm trying to get the time. If that makes any sense.
A binding concrete method of a declarative environment record envrec takes argument n, a string, and returns a normal completion containing a boolean. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called. Assert. envrec has a binding for n. If the binding for n in envrec cannot be deleted, return false. Remove the binding for n from envrec. Return true, 1, 1, 1. 8 has this binding. That has this binding concrete method of a declarative environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 1. 9 has super binding. That has super binding concrete method of a declarative environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 1. 1, 0 with base object. The with base object concrete method of a declarative environment record envrec takes no arguments and returns undefined. It performs the following steps when called. Return undefined, 1, 1. 2 object environment records. Each object environment record is associated with an object called its binding object. An object environment record binds the set of string identifier names that directly correspond to the property names of its binding object. Property keys that are not strings in the form of an identifier name are not included in the set of bound identifiers. Both own and inherited properties are included in the set regardless of the setting of their attribute. Note a regular declarative environment record. That is, one that is neither a function environment record nor a module environment record. Does not provide this binding. Note a regular declarative environment record. That is, one that is neither a function environment record nor a module environment record. Does not provide a super binding. 38. Copyright sign. ECMA International 2024. Because properties can be dynamically added and deleted from objects, The set of identifiers bound by an object environment record may potentially change as a side effect of any operation that adds or deletes properties. Any bindings that are created as a result of such a side effect are considered to be a mutable binding, even if the writable attribute of the corresponding property is false. Immutable bindings do not exist for object environment records. Object environment records created for with statements 14.11 can provide their binding object as an implicit this value for use in function calls. The capability is controlled by a Boolean field. Object environment records have the additional state fields listed in Table 17. Table 17, additional fields of object environment records. The behavior of the concrete specification methods for object environment records is defined by the following algorithms, 1, 2, 1 has binding, n, the has binding concrete method of an object environment record envrec takes argument n, string, and returns either a normal completion containing a Boolean or a throw completion. It determines if its associated binding object has a property whose name is n. It performs the following steps when called. Let binding object be envrec. Let found binding be. Has property, binding object, n. If found binding is false, return false. If envrec is false, return true. Let unscopables be. Get binding object. Add at unscopables. If unscopables is an object, then a let block be to Boolean. Get unscopables, n. Be if blocked is true, return false. Return true, 1, 2. To create mutable binding, n. D. The create mutable binding concrete method of an object environment record envrec takes arguments n, a string, and e, a Boolean, and returns either a normal completion containing unused or a throw completion. It creates in an environment records associated binding object a property whose name is n and initializes it to the value undefined. If D is true, the new property's attribute is set to true, otherwise it is set to false. It performs the following steps when called. Let binding object be envrec. Perform. Define property or throw, binding object, n, property descriptor, undefined. True, true. D. Return unused. Field name, value, meaning, binding object. An object. The binding object of this environment record is with environment. A Boolean indicates whether this environment record is created for a with statement. Note normally envrec will not have a binding for n, but if it does, the semantics of defined property or throw may result in an existing binding being replaced or shadowed or cause an abrupt completion to be returned. ECMA International 2024 139 9 1 1 2 3 Create a mutable binding n s. The create a mutable binding concrete method of an object environment record is never used within this specification, 1 1 2 4 Initialize binding n v. The initialize binding concrete method of an object environment record envrec takes arguments n, a string, and v, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. It performs the following steps when called. Perform envrec set mutable binding n, v, false. Return unused, 1 2 5 Set mutable binding n, v, s. The set mutable binding concrete method of an object environment record envrec takes arguments n, a string, v, an ECMAScript language value, and s, a Boolean, and returns either a normal completion containing unused or a throw completion. It attempts to set the value of the environment records associated binding object's property whose name is n to the value v. A property named n normally already exists to t if it does not or is not currently writable. Error handling is determined by s. It performs the following steps when called. Let binding object be envrec. Let still exist as b. Has property, binding object, n. If still exists as false and s is true, throw a reference error exception. Perform. Set binding object n, v, s. Return unused, 1 2 6 Get binding value n, s. The get binding value concrete method of an object environment record envrec takes arguments n, a string, and s, a Boolean, and returns either a normal completion containing an ECMAScript language value or a throw completion. It returns the value of its associated binding object's property whose name is n. The property should already exist, but if it does not, the result depends upon s. It performs the following steps when called. Let binding object be envrec. Let value be has property binding object n. If a value is false, then if s is false, return undefined. Otherwise throw a reference error exception for return get binding object n, 1, 1, 2, 7. Delete binding n. The delete binding concrete method of an object environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that correspond to properties of the environment object whose attribute have the value true. It performs the following steps when called. Note in this specification, all uses of create mutable binding for object environment records are immediately followed by a call to initialize binding for the same name. Hence, this specification does not explicitly track the initialization state of bindings in object environment records. 2. Let binding object be envrec. Return binding object n. 40. ECMA International 2024 9. 1. 1. 2. 8 has this binding. The has this binding concrete method of an object environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 2. 9 has super binding. The has super binding concrete method of an object environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 2. 1, 0 with base object. The with base object concrete method of an object environment record envrec takes no arguments and returns an object or undefined. It performs the following steps when called. If envrec is true, return envrec. Otherwise, return undefined. 1, 1, 3. Function environment records. A function environment record is a declarative environment record that is used to represent the top-level scope of a function and, if the function is not an arrow function, provides this binding. If a function is not an arrow function and references super, its function environment record also contains the state that is used to perform super method invocations from within the function. Function environment records have the additional state fields listed in Table 18. Table 18. Additional fields of function environment records. Note: object environment records do not provide this binding. Note: object environment records do not provide a super binding. Field name, value, meaning this value, an ECMAScript language value. This is the this value used for this invocation of the function. This binding status, lexical, initialized, or uninitialized. If the value is lexical, this is an arrow function and does not have a local this value. Function object, an ECMAScript function object. The function object whose invocation caused this environment record to be created. New target, an object or undefined. If this environment record was created by the internal method, is the value of the new target parameter. Otherwise, its value is undefined. Copyright sign, ECMA International 2024, 41. Function environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for has this binding and has super binding. In addition, function environment records support the methods listed in Table 19. Table 19. Additional methods of function environment records. Method. Purpose. Bind this value. V. Set the end record that it has been initialized. Get this binding. Return the value of this environment records this binding. Throws a reference error if this binding has not been initialized. Get super base. Return the object that is the base for super property accesses bound in this environment record. The value undefined indicates that such accesses will produce runtime errors. The behavior of the additional concrete specification methods for function environment records is defined by the following algorithms. 1, 1, 3, 1. Bind this value, v. The bind this value concrete method of a function environment record envrec takes argument v, an ECMAScript language value, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Assert. envrec is not lexical if envrec is initialized. Throw a reference error exception. Set envrec to v. Set envrec to initialized. Return v, 1, 1, 3, 2 has this binding. The has this binding concrete method of a function environment record envrec takes no arguments and returns a boolean. It performs the following steps when called. If envrec is lexical, return false. Otherwise, return true. 9, 1, 1, 3. 3 has superbinding. The has superbinding concrete method of a function environment record envrec takes no arguments and returns a boolean. It performs the following steps when called. If envrec is lexical, return false. If envrec is undefined, return false. Otherwise, return true, 1, 1, 3. Forget this binding. The get this binding concrete method of a function environment record envrec takes no arguments and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Assert. envrec is not lexical if envrec is uninitialized. Throw a reference error exception. Return envrec. 42. ECMA International 2024. 9, 1, 1, 3. 5. Get superbase. The get superbase concrete method of a function environment record envrec takes no arguments and returns either a normal completion containing either an object, null, or undefined, or a throw completion. It performs the following steps when called. Let home be envrec. If home is undefined, return undefined. Assert. Home is an object. Return home, 1, 1. 4. Global environment records. A global environment record is used to represent the outermost scope that is shared by all of the ECMAScript script elements that are processed in a common realm. A global environment record provides the bindings for built-in globals, clause 19, properties of the global object, and for all top-level declarations, 8, 2, 9, the 8th of February 2011, that occur within a script. A global environment record is logically a single record, but it is specified as a composite encapsulating an object environment record and a declarative environment record. The object environment record has as its base object the global object of the associated realm record. This global object is the value returned by the global environment records get this binding concrete method. The object environment record component of a global environment record contains the bindings for all built-in globals, clause 19, and all bindings introduced by a function declaration, generator declaration, async function declaration, async generator declaration, or variable statement contained in global code. The bindings for all other ECMAScript declarations in global code are contained in the declarative environment record component of the global environment record. Properties may be created directly on a global object. Hence, the object environment record component of a global environment record may contain both bindings created explicitly by function declaration, generator declaration, async function declaration, async generator declaration, or variable declaration declarations and bindings created implicitly as properties of the global object. In order to identify which bindings were explicitly created using declarations, a global environment record maintains a list of the names bound using its create global var binding and create global function binding concrete methods. Global environment records have the additional fields listed in Table 20 and the additional methods listed in Table 21. Table 20. Additional fields of global environment records. Field name, value, meaning, object record, an object environment record. Binding object is the global object. It contains global built-in bindings as well as function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration bindings in global code for the associated realm. Global this value, an object, the value returned by this in global scope. Hosts may provide any ECMAScript object value. Declarative record. A declarative environment record contains bindings for all declarations in global code for the associated realm code except for function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration bindings. Var names, a list of strings, the string names bound by function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration declarations in global code for the associated realm. Copyright sign, ECMA International 2024, 43, Table 21. Additional methods of global environment records. Method. Purpose. Get this binding. Return the value of this environment records. This binding has var declaration. N. Determines if the argument identifier has a binding in this environment record that was created using a variable declaration. Function declaration. Generator declaration. Async function declaration. Or async generator declaration has lexical declaration. N. Determines if the argument identifier has a binding in this environment record that was created using a lexical declaration such as a lexical declaration or a class declaration, has restricted global property. N. Determines if the argument is the name of a global object property that may not be shadowed by a global lexical binding, can declare global var. N. Determines if a corresponding create global var binding call would succeed if called for the same argument. N. Can declare global function. N. Determines if a corresponding create global function binding call would succeed if called for the same argument. N. Create global var binding. N. D. Used to create and initialize to undefined a global var binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a var. The string value n is the bound name. If D is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows var declarations to receive special treatment. Create global function binding. N. V. D. Create and initialize a global function binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a function. The string value n is the bound name. V is the initialization value. If the Boolean argument D is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows function declarations to receive special treatment. The behavior of the concrete specification methods for global environment records is defined by the following algorithms. 1, 1, 4, 1 has binding. N. The has binding concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a Boolean or a throw completion. It determines if the argument identifier is one of the identifiers bound by the record. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n, is true, return true. Let OBJREC be envrec. Return. OBJREC has binding, n, 1, 1, 4, 2 create mutable binding, n, d. The create mutable binding concrete method of a global environment record envrec takes arguments n, a string, and e, a Boolean, and returns either a normal completion containing unused or a throw completion. It creates a new mutable binding for the name n that is uninitialized. The binding is created in the associated 44. Copyright sign, ECMA International 2024, declarative record. A binding for n must not already exist in the declarative record. If D is true, the new binding is marked as being subject to deletion. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n, is true, throw a type error exception. Return. DCLREC create mutable binding, n, D, 1, 1, 4, 3 create a mutable binding, n, s. The create a mutable binding concrete method of a global environment record envrec takes arguments n, a string, and s, a Boolean, and returns either a normal completion containing unused or a throw completion. It creates a new immutable binding for the name n that is uninitialized. A binding must not already exist in this environment record for n if s is true. The new binding is marked as a strict binding. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n, is true, throw a type error exception. Return. DCLREC create a mutable binding, n, s, 1, 1, 4, 4 initialize binding, n, v, The initialize binding concrete method of a global environment record envrec takes arguments n, a string, and v, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. An uninitialized binding for n must already exist. It performs the following steps when called. Let DCLREC be envrec if DCLREC has binding n is true, then a return. DCLREC initialize binding n v assert if the binding exists. T must be in the object environment record. Let objrec be envrec return. Objrec initialize binding n v, 1 1 4 5 set mutable binding n v s. The set mutable binding concrete method of a global environment record envrec takes arguments n, a string, v, an ECMAScript language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is n to the value v if the binding is an immutable binding and s is true. A type error is thrown. A property named n normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called. Let DCLREC be envrec if DCLREC has binding n is true, then a return. DCLREC set mutable binding n v s. Let objrec be envrec return. Objrec set mutable binding n v s, 1 1 4 6 get binding value n s. The get binding value concrete method of a global environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMAScript language value or a throw completion. It returns the value of its bound identifier whose name is n if the binding is an uninitialized binding. Throw a reference error exception. A property named n normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called. Let DCLREC be envrec if DCLREC has binding n is true, then a return. DCLREC get binding value n s. ECMA International 2024 145 3. Let objrec be envrec return. Objrec get binding value n s, 1 1 4 7 delete binding n. The delete binding concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called. Let DCLREC be envrec if DCLREC has binding n is true, then a return. DCLREC delete binding n. Let objrec be envrec. Let global object be objrec. Let existing prop be has own property, global object n. If existing prop is true, then a let status be objrec delete binding n b. If status is true and envrec contains n, then I remove n from envrec. C return status return true, 1 1 4 8 has this binding. That has this binding concrete method of a global environment record envrec takes no arguments and returns true. It performs the following steps when called. Return true, 1 1 4 9 has super binding. That has super binding concrete method of a global environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1 1 4 1 0 with base object. The with base object concrete method of a global environment record envrec takes no arguments and returns undefined. It performs the following steps when called. Return undefined 9 1 1 4 1 1 get this binding. The get this binding concrete method of a global environment record envrec takes no arguments and returns a normal completion containing an object. It performs the following steps when called. Return envrec 146. ECMA International 2024. Note: global environment records always provide this binding. Note: global environment records do not provide a super binding. 9.1.1.4.1.2 has var declaration. N. The has var declaration concrete method of a global environment record envrec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a variable statement or a function declaration. It performs the following steps when called. Let var declared names be envrec. If var declared names contains n, return true, return false, 1, 1, 4, 1, 3 has lexical declaration. N. The has lexical declaration concrete method of a global environment record envrec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a lexical declaration such as a lexical declaration or a class declaration. It performs the following steps when called. Let DCLREC be envrec. Return. DCLREC has binding. N, 1, 1, 4, 1, 4 has restricted global property. N. The has restricted global property concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is the name of a property of the global object that must not be shadowed by a global lexical binding. It performs the following steps when called. Let objrec be envrec. Let global object be objrec. Let existing prop be global object. N. If existing prop is undefined, return false. If existing prop is true, return false. Return true, 1, 1, 4, 1, 5 can declare global var. N. The can declare global var concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global var binding call would succeed if called for the same argument n redundant var declarations and var declarations for pre-existing global object properties are allowed. It performs the following steps when called. Let objrec be envrec. Let global object be objrec. Let has property be has own property. Global object. N. If his property is true, return true. Return is extensible. Global object. Note: properties may exist upon a global object that were directly created rather than being declared using a var or function declaration. A global lexical binding may not be created that has the same name as a non-configurable property of the global object. The global property undefined is an example of such a property. ECMA International 2024 147 9 1 1 4 1 6 can declare global function n. The can declare global function concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global function binding call would succeed if called for the same argument, and it performs the following steps when called. Let objrec be envrec. Let global object be objrec. Let existing prop be global object. N. If existing prop is undefined, return is extensible. Global object. If existing prop is true, return true. If is data descriptor, existing prop is true and existing prop has attribute values. True, enumerable. True, return true. Return false, 1, 1, 4, 1, 7 create global var binding. N, D. The create global var binding concrete method of a global environment record envrec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is reused and assumed to be initialized. It performs the following steps when called. Let objrec be envrec. Let global object be objrec. Let has property be has own property. Global object. N. Let extensible be is extensible. Global object. If his property is false and extensible is true, then a perform. Objrec create mutable binding. N. D. B perform. objrec initialize binding, n, undefined. If envrec does not contain n, then append n to envrec7. Return unused, 1, 1, 4, 1, 8. Create global function binding, n, v, d. The create global function binding concrete method of a global environment record envrec takes arguments n, a string, v, an ECMAScript language value, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is 2, 3, 4, 7, 8, replaced. It performs the following steps when called. Let objrec be envrec. Let global object be objrec. Let existing prop be global object, n. If existing prop is undefined or existing prop is true, then a let desc be the property descriptor, v, true, true, d. Else a let desc be the property descriptor, v, perform. Define property or throw, global object, n, desc. Perform. Set, global object, n, v, false. If envrec does not contain n, then append n to envrec. Return unused. 48. ECMA International 2024. Note global function declarations are always represented as own properties of the global object. If possible, an existing own property is reconfigured to have a standard set of attribute values. Step 7 is equivalent to what calling the initialize binding concrete method would do, and if global object is a proxy will produce the same sequence of proxy trap calls, 1, 1. 5 module environment records. A module environment record is a declarative environment record that is used to represent the outer scope of an ECMAScript module. In addition to normal mutable and immutable bindings, module environment records also provide immutable import bindings, which are bindings that provide indirect access to a target binding that exists in another environment record. Module environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for get binding value, delete binding, has this binding, and get this binding. In addition, module environment records support the methods listed in Table 22. Table 22, additional methods of module environment records. The behavior of the additional concrete specification methods for module environment records are defined by the following algorithms, 1, 1, 5, 1 get binding value, n, s. The get binding value concrete method of a module environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMAScript language value or a throw completion. It returns the value of its bound identifier whose name is n. However, if the binding is an indirect binding, the value of the target binding is returned. If the binding exists but is uninitialized, a reference error is thrown. It performs the following steps when called. Assert. S is true. Assert. envrec has a binding for n. If the binding for n is an indirect binding, then a let m and n2 be the indirection values provided when this binding for n was created. B let target env be m. C if target env is empty, throw a reference error exception. D return target env get binding value. N2, true. If the binding for n in envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n in envrec. Note S will always be true because a module is always strict mode code 9. 1, 1, 5. To delete binding, n. The delete binding concrete method of a module environment record is never used within this specification. Method. Purpose. Create import binding, n, m, n2. Create an immutable indirect binding in a module environment record. The string value n is the text of the bound name. M is a module record, and n2 is a binding that exists in m's module environment record. Get this binding. Return the value of this environment records this binding. Copyright sign, ECMA International 2024 149. Note module environment records are only used within strict code, and an early error rule prevents the delete operator in strict code from being applied to a reference record that would resolve to a module environment record binding. C13, 5, 1, 1, 1, 1, 5, 3 has this binding. The has this binding concrete method of a module environment record env-rec takes no arguments and returns true. It performs the following steps when called. Return true, 1, 1, 5, 4 get this binding. The get this binding concrete method of a module environment record env-rec takes no arguments and returns a normal completion containing undefined. It performs the following steps when called. Return undefined, 1, 1, 5, 5 create import binding, n, m, n2. The create import binding concrete method of a module environment record env-rec takes arguments n, a string, m, a module record, and n2, a string, and returns unused. It creates a new initialized immutable indirect binding for the name n. A binding must not already exist in this environment record for n. N2 is the name of a binding that exists in m's module environment record. Accesses to the value of the new binding will indirectly access the bound value of the target binding. It performs the following steps when called. Assert. env-rec does not already have a binding for n. Assert. When m is instantiated, it will have a direct binding for n2. Create an immutable indirect binding in env-rec for n that references m and n2 as its target binding and record that the binding is initialized. Return unused, 1.2 environment record operations. The following abstract operations are used in this specification to operate upon environment records. 9, 1, 2, 1 get identifier reference, env, name, strict. The abstract operation get identifier reference takes arguments env, an environment record or null, name, a string, and strict, a boolean, and returns either a normal completion containing a reference record or a throw completion. It performs the following steps when called. If env is null, then a return the reference record, unresolvable, name, strict. This value, empty. Let exists be env has binding. Name if exists is true, then a return the reference record, env, name, strict, empty. Else, 150. ECMA International 2024. Note, module environment records always provide this binding. AB, let outer be env, return. Get identifier reference, outer, name, strict. 9, 1, 2, to new declarative environment. E. The abstract operation new declarative environment takes argument E, an environment record or null, and returns a declarative environment record. It performs the following steps when called. Let env be a new declarative environment record containing no bindings. Set env to E. Return env, 1, 2, 3 new object environment. O, W, E. The abstract operation new object environment takes arguments O, an object, W, a boolean, and E, an environment record or null, and returns an object environment record. It performs the following steps when called. Let env be a new object environment record. Set env to O, set env to W, set env to E. Return env, 1, 2, 4 new function environment, F. New target. The abstract operation new function environment takes arguments f, an ECMAScript function object, and new target, an object or undefined, and returns a function environment record. It performs the following steps when called. Let env be a new function environment record containing no bindings. Set env to f. If f is lexical, set env to lexical. Else, set env to uninitialized. Set env to new target. Set env to f. Return env, 1, 2, 5 new global environment, G. This value. The abstract operation new global environment takes arguments G, an object, and this value, an object, and returns a global environment record. It performs the following steps when called. Let obj-rec be new object environment, G, false, null. Let DCL-rec be new declarative environment, null. Let env be a new global environment record. Set env to obj-rec. Set env to this value. Set env to DCL-rec. Set env to a new empty list. Set env to null. Return env, 1, 2, 6 new module environment, E. The abstract operation new module environment takes argument E, an environment record. and returns a module environment record. It performs the following steps when called. Let env be a new module environment record containing no bindings. Set env to E. Return env. ECMA International 2024 151. 9.2 Private environment records. A private environment record is a specification mechanism used to track private names based upon the lexical nesting structure of class declarations and class expressions in ECMAScript code. They are similar to, but distinct from, environment records. Each private environment record is associated with a class declaration or class expression. Each time such a class is evaluated, a new private environment record is created to record the private names declared by that class. Each private environment record has the fields defined in Table 23. Table 23. Private environment record phi LDS field name value type meaning outer private environment A private environment record or null the private environment record of the nearest containing class null if the class with which this private environment record is associated is not contained in any other class. Names a list of private names the private names declared by this class. 9. 2. 1 Private environment record operations. The following abstract operations are used in this specification to operate upon private environment records. 9. 2. 1. 1 New private environment. Outer-privy env. The abstract operation new private environment takes argument outer-privy env, a private environment record or null, and returns a private environment record. It performs the following steps when called. Let names be a new empty list. Return the private environment record. Outer-privy env, names, 2, 1. To resolve private identifier, privy env, identifier. The abstract operation resolve private identifier takes arguments privy env, a private environment record, and identifier, a string, and returns a private name. It performs the following steps when called. Let names be privy env. For each private name Pn of names, do if Pn is identifier. Then I return Pn. Let outer privy env be privy env. Assert. Outer privy env is not null. Return resolve private identifier. Outer privy env. Identifier. 3 realms. Before it is evaluated, all ECMAScript code must be associated with the realm. Conceptually, a realm consists of a set of intrinsic objects, an ECMAScript global environment, all of the ECMAScript code that is loaded within the scope of that global environment, and other associated state and resources. A realm is represented in this specification as a realm record with the fields specified in Table 24. 52. Copyright sign, ECMA International 2024. Table 24. Realm record fields. Field name. Agent signifier. Intrinsics. Global object. Global env. Template map. An object or undefined value. An agent signifier. A record whose field names are intrinsic keys and whose values are objects. A global environment record. A list of records with fields. A template literal parse node. And v. An array. F. The agent that owns this realm, the global object for this realm, the global environment for this realm, meaning the intrinsic values used by code associated with this realm, a list of records with fields are a string and a module record. Note 1 once a parse node becomes unreachable, the corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything default value is undefined. Note 2 as mentioned in host load imported module 16.2.1.8. Note 1 in realm records is only used when running an import expression in a context where there is no active script or module, field reserved for use by hosts that need to associate additional information with a realm record. Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template literal. The associated ALU is the corresponding template object that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record. The list does not contain two different records with the same 9, 3, 1 create realm. The abstract operation create realm takes no arguments and returns a realm record. It performs the following steps when called. Let realm rec be a new realm record. Perform create intrinsics. realm rec, set realm rec to agent signifier, set realm rec to undefined, set realm rec to undefined, set realm rec to a new empty list, return realm rec, ECMA International 2024 153, 9, 3, 2 create intrinsics, realm rec. The abstract operation create intrinsics takes argument realm rec, a realm record, and returns unused. It performs the following steps when called. Set realm rec to a new record. Set fields of realm rec with the values listed in table 6. The field names are the names listed in column 1 of the table. The value of each field is a new object value fully and recursively populated with property values as defined by the specification of each object in clauses 19 through 28. All object property values are newly created object values. All values that are built-in function objects are created by performing create built-in function, steps, length, name, slots, realm rec, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name property, length is the initial value of the function's length property, slots is a list of the names, if any, of the function's specified internal slots, and prototype is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform capital A, D, D, capital R, E, S, T, R, I, C, T, E, D, capital F, U, N, C, T, I, O, N, capital P, R, O, P, E, R, T, I, E, realm rec, return unused, 3.3 set realm global object, realm rec, global OBJ, this value. The abstract operation set realm global object takes arguments realm rec, a realm record, global OBJ, an object or undefined, and this value, an object or undefined, and returns unused. It performs the following steps when called. If global OBJ is undefined, then a let intrinsics be realm rec, b set global OBJ to ordinary object create, intrinsics assert, global OBJ is an object. If this value is undefined, set this value to global OBJ, set realm rec to global OBJ, let new global env be new global environment, global OBJ, this value, set realm rec to new global env, return unused, 3.4 set default global bindings, realm rec. The abstract operation set default global bindings takes argument realm rec, a realm record, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let global be realm rec for each property of the global object specified in clause 19. Do a let name be the string value of the property name. B let desk be the fully populated data property descriptor for the property, containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4 the value of the attribute is the corresponding intrinsic object from realm rec. See perform. Define property or throw, global, name, desk, return global. Point 4 execution contexts. An execution context is a specification device that is used to track the runtime evaluation of code by an ECMAScript implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running execution context is always the top element of this stack. A new execution context is created whenever control is transferred from the executable code associated with the currently running execution context to an executable code that is not associated with that. 54. Copyright sign, ECMA International 2024. Execution context. The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25. State components for all execution contexts. Component. Purpose. Code evaluation state. Any state needed to perform, suspend, and resume evaluation of the code associated with this execution context. Function. If this execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm. The realm record from which associated code accesses ECMAScript resources. Script or module. The module record or script record from which associated code originates. If there is no originating script or module, as is the case for the original execution context created in initialize host-defined realm, the value is null. Evaluation of code by the running execution context may be suspended at various points, defined within this specification. Once the running execution context has been suspended, a different execution context may become the running execution context and commence evaluating its code. At some later time, a suspended execution context may again become the running execution context and continue evaluating its code at the point where it had previously been suspended. Transition of the running execution context status among execution contexts usually occurs in stack-like last-in first-out manner. However, some ECMAScript features require non-LFO transitions of the running execution context. The value of the realm component of the running execution context is also called the current realm record. The value of the function component of the running execution context is also called the active function object. ECMAScript code execution contexts have the additional state components listed in Table 26. Table 26. Additional state components for ECMAScript code execution contexts. Component. Purpose. Lexical environment. Identifies the environment record used to resolve identifier references made by code within this execution context. Variable environment. Identifies the environment record that holds bindings created by variable statements within this execution context. Private environment. Identifies the private environment record that holds private names created by class elements and the nearest containing class null if there is no containing class. The lexical environment and variable environment components of an execution context are always environment records. Execution contexts representing the evaluation of generators have the additional state components listed in Table 27. ECMA International 2024 155. Table 27. Additional state components for generator execution contexts. In most situations, only the running execution context, the top of the execution context stack, is directly manipulated by algorithms within this specification. Hence, when the terms lexical environment and variable environment are used without qualification, they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMAScript implementation. It is impossible for ECMAScript code to directly access or observe an execution context. 4.1 Get active script or module. The abstract operation get active script or module takes no arguments and returns a script record, a module record, or null. It is used to determine the running script or module, based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let X be the topmost execution context on the execution context stack whose script or module component is not null. If no such execution context exists, return null. Otherwise, return X script or module. 4.2 Resolve binding. Name, env. The abstract operation resolve binding takes argument name, a string, and optional argument env, an environment record or undefined, and returns either a normal completion containing a reference record or a throw completion. It is used to determine the binding of name. env can be used to explicitly provide the environment record that is to be searched for the binding. It performs the following steps when called. If env is not present or env is undefined, then A set env to the running execution context's lexical environment. Assert env is an environment record. If the source text match by the syntactic production that is being evaluated is contained in strict mode code, let strict be true, else let strict be false. Return. Get identifier reference, env, name, strict, 4.3 get this environment. The abstract operation get this environment takes no arguments and returns an environment record. It finds the environment record that currently supplies the binding of the keyword this. It performs the following steps when called. Let env be the running execution context's lexical environment 2. Repeat component purpose. Generator the generator that this execution context is evaluating. 156. ECMA International 2024. Note the result of resolve binding is always a reference record whose field is name ABCDE. Let exists be env has this binding. If exists is true, return env. Let outer be env. Assert. Outer is not null. Set env to outer. Note the loop in step 2 will always terminate because the list of environments always ends with the global environment which has a this binding. 4.4 resolve this binding. The abstract operation resolve this binding takes no arguments and returns either a normal completion containing an ECMAScript language value or a throw completion. It determines the binding of the keyword this using the lexical environment of the running execution context. It performs the following steps when called. Let env-rec be get this environment. Return env-rec get this binding. 4.5 get new target. The abstract operation get new target takes no arguments and returns an object or undefined. It determines the new target value using the lexical environment of the running execution context. It performs the following steps when called. Let env-rec be get this environment. Assert. env-rec has a field. Return env-rec, 4.6 get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called. 2.5 let current realm be the current realm record. Return current realm, jobs and host operations to enqueue jobs. A job is an abstract closure with no parameters that initiates an ECMAScript computation when no other ECMAScript computation is currently in progress. Jobs are scheduled for execution by ECMAScript host environments in a particular agent. This specification describes the host hook's host enqueue generic job. Capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R, host enqueue promise job, and host enqueue timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract closure and a realm record or null, as parameters. If a realm record is provided, these operations schedule the job to be performed at some future time in the provided realm, in the agent that owns the realm. If null is provided instead for the realm, then the job does not evaluate ECMAScript code. Their implementations must conform to the following requirements. At some future point in time, when there is no running context in the agent for which the job is scheduled and that agent's execution context stack is empty, the implementation must perform any host-defined preparation steps, invoke the job abstract closure, perform any host-defined cleanup steps, after which the execution context stack must be empty. Only one job may be actively undergoing evaluation at any point in time in an agent. Once evaluation of a job starts, it must run to completion before evaluation of any other job starts in an agent. The abstract closure must return a normal completion, implementing its own handling of errors. ECMA International 2024 157. Note 1 host environments are not required to treat jobs uniformly with respect to scheduling. For example, web browsers and Node.js treat promise handling jobs as a higher priority than other work. Future features may add jobs that are not treated at such a high priority. At any particular time, script or module, a script record, a module record, or null, is the active script or module if all of the following conditions are true. Get active script or module. Is script or module. If script or module is a script record or module record, let EC be the topmost execution context on the execution context stack whose script or module component is script or module. The realm component of EC is script or module. At any particular time, an execution is prepared to evaluate ECMAScript code if all of the following conditions are true. The execution context stack is not empty. The realm component of the topmost execution context on the execution context stack is a realm record. Particular kinds of jobs have additional conformance requirements. 5.1 Job callback records. A job callback record is a record value used to store a function object and a host-defined value. Function objects that are invoked via a job enqueued by the host may have additional host-defined context. To propagate the state, job abstract closures should not capture and call function objects directly. Instead, use host mac, a job callback and host call job callback. Job callback records have the fields listed in Table 28. Table 28. Job callback record fields, 5.2 host make job callback. Callback, the host-defined abstract operation host make job callback takes argument callback, a function object, and returns a job callback record. An implementation of host make job callback must conform to the following requirements. It must return a job callback record whose field is callback. Note: 2 host environments may prepare an execution to evaluate code by pushing execution contexts onto the execution context stack. The specific steps are implementation defined. The specific choice of realm is up to the host environment. This initial execution context and realm is only in use before any callback function is invoked. When a callback function related to a job, like a promise handler, is invoked, the invocation pushes its own execution context and realm. Note the WHATWG.html specification, https://html.spec.whatwg.org/ for example, uses the host-defined value to propagate the incumbent settings object for promise callbacks. Field name value meaning callback, a function object, the function to invoke when the job is invoked. Host-defined, anything default value is empty. Field reserved for use by hosts. 158. ECMA International 2024. The default implementation of host make job callback performs the following steps when called. 1. Return the job callback record. Callback empty. ECMAScript hosts that are not web browsers must use the default implementation of host make job callback, 5.3 hosts call job callback. Job callback v arguments list. The host-defined abstract operation host call job callback takes arguments job callback, a job callback record, v, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. An implementation of host call job callback must conform to the following requirements. It must perform and return the result of call. Job callback v arguments list. The default implementation of host call job callback performs the following steps when called. Assert is callable. Job callback is true. Return call job callback v arguments list. ECMAScript hosts that are not web browsers must use the default implementation of host call job callback, 5.4 host enqueue generic job realm. The host-defined abstract operation host enqueue generic job takes arguments job, a job abstract closure, and realm, a realm record, and returns unused. It schedules job in the realm in the agent signified by realm to be performed at some future time. The abstract closures used with this algorithm are intended to be scheduled without additional constraints, such as priority and ordering. An implementation of host enqueue generic job must conform to the requirements in 9.5 host enqueue promise job realm. The host-defined abstract operation host enqueue promise job takes arguments job, a job abstract closure, and realm, a realm record or null, and returns unused. It schedules job to be performed at some future time. The abstract closures used with this algorithm are intended to be related to the handling of promises, or otherwise, to be scheduled with equal priority to promise handling operations. An implementation of host enq with promise job must conform to the requirements in 9.5 as well as the following. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that execution is prepared to evaluate ECMAScript code at the time of job's invocation. Let script or module be get active script or module at the time host enq with promise job is invoked. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that script or module is the active script or module at the time of job's invocation. Jobs must run in the same order as the host enq with promise job invocations that scheduled them. Note this is called at the time that the callback is passed to the function that is responsible for its being eventually scheduled and run. For example, promise then action, calls make job callback on then action at the time of invoking promise prototype then, not at the time of scheduling the reaction job. Note this requirement means that hosts cannot change the behavior of function objects defined in this specification. ECMA International 2024 159. Note the realm for jobs returned by new promise resolve thenable job is usually the result of calling get function realm on the then function object. The realm for jobs returned by new promise reaction job is usually the result of calling get function realm on the handler if the handler is not undefined. If the handler is undefined, realm is null. For both kinds of jobs, when get function realm completes abnormally, that is called on a revoked proxy, realm is the current realm record at the time of the get function realm call. When the realm is null, no user ECMAScript code will be evaluated and no new ECMAScript objects, for example, error objects, will be created. The WHATWG-HTML specification, https://html.spec.whatwg.org/ for example, uses realm to check for the ability to run script and for the entry, https://html.spec.whatwg.org/ /entry concept, 5.6 host enq timeout job, realm, milliseconds. The host-defined abstract operation host enq timeout job takes arguments timeout job, a job abstract closure, realm, a realm record, and milliseconds, a non-negative finite number, and returns unused. It schedules timeout job in the realm in the agent signified by realm to be performed after at least milliseconds. An implementation of host enq timeout job must conform to the requirements in 9.5. 9.6 Initialize host-defined realm. The abstract operation initialize host-defined realm takes no arguments and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let realm be create realm. Let new context be a new execution context. Set the function of new context to null. Set the realm of new context to realm. Set the script or module of new context to null. Push new context onto the execution context stack. New context is now the running execution context. If the host requires use of an exotic object to serve as realm's global object, let global be such an object created in a host-defined manner. Otherwise, let global be undefined, indicating that an ordinary object should be created as the global object. If the host requires that this binding in realm's global scope return an object other than the global object, let this value be such an object created in a host-defined manner. Otherwise, let this value be undefined, indicating that realm's global this binding should be the global object. Perform set realm global object, realm, global. This value 0. Let global obj be. Set default global bindings, realm 1. Create any host-defined global object properties on global obj 2. Return unused. 7 Agents. An agent comprises a set of ECMAScript execution contexts, an execution context stack, a running execution context, an agent record, and an executing thread. Except for the executing thread, the constituents of an agent belong exclusively to that the agent. An agent's executing thread executes algorithmic steps on the agent's execution contexts independently of other agents, except that an executing thread may be used as the executing thread by multiple agents. provided none of the agents sharing the thread have an agent record whose field is true. Note 1. Some web browsers share a single executing thread across multiple unrelated tabs of a browser window. For example, 60, copyright sign, ECMA International 2024. While an agent's executing thread is executing algorithmic steps, the agent is the surrounding agent for those steps. The steps use the surrounding agent to access the specification-level execution objects held within the agent, the running execution context, the execution context stack, and the agent records fields. An agent signifier is a globally unique opaque value used to identify an agent. Table 29. Agent record fields. Field name, value, meaning, little endian, a boolean. The default value computed for the is little endian parameter when it is needed by the algorithm's get value from buffer and set value in buffer. The choice is implementation defined and should be the alternative that is most efficient for the implementation. Once the value has been observed, it cannot change. Can block. A boolean determines whether the agent can block or not. Signifier. An agent signifier uniquely identifies the agent we, in its agent cluster, is lock-free 1. A boolean, true if atomic operations on 1 byte values are lock-free. False otherwise is lock-free 2. A boolean, true if atomic operations on 2 byte values are lock-free. False otherwise is lock-free 8. A boolean, true if atomic operations on 8-byte values are lock-free. False otherwise. Candidate execution. A candidate execution record. See the memory model. Kept alive. A list of either objects or symbols, initially in empty list, representing the list of objects and or symbols to be kept alive until the end of the current job. Once the values of and have been observed by any agent in the agent cluster, they cannot change. Note 2. The values of and are not necessarily determined by the hardware, but may also reflect implementation choices that can vary over time and between ECMAScript implementations. There is no field. 4-byte atomic operations are always log-free. In practice, if an atomic operation is implemented with any type of lock, the operation is not lock-free. Lock-free does not imply wait-free. There is no upper bound on how many machine steps may be required to complete a lock-free atomic operation. That an atomic access of size n is lock-free does not imply anything about the perceived atomicity of non-atomic accesses of size n. Specifically, non-atomic accesses may still be performed as a sequence of several separate memory accesses. See read shared memory and write shared memory for details. ECMA International 2024 161. Note 3. An agent is a specification mechanism and need not correspond to any particular artifact of an ECMAScript implementation. 7.1 Agent signifier. The abstract operation agent signifier takes no arguments and returns an agent signifier. It performs the following steps when called. Let AR be the agent record of the surrounding agent. Return AR, 7.2 Agent can suspend. The abstract operation agent can suspend takes no arguments and returns a boolean. It performs the following steps when called. 2.8 Let AR be the agent record of the surrounding agent. Return AR, agent clusters. Note in some environments it may not be reasonable for a given agent to suspend. For example, in a web browser environment, it may be reasonable to disallow suspending a document's main event handling thread, while still allowing workers' event handling threads to suspend. An agent cluster is a maximal set of agents that can communicate by operating on shared memory. Every agent belongs to exactly one agent cluster. All agents within a cluster must have the same value for the field in their respective agent records. All agents within a cluster must have the same values for the field in their respective agent records. Similarly for the field, all agents within a cluster must have different values for the field in their respective agent records. An embedding may deactivate, stop forward progress, or activate, resume forward progress, an agent without the agent's knowledge or cooperation. If the embedding does so, it must not leave some agents in the cluster active while other agents in the cluster are deactivated indefinitely. Note 1. Programs within different agents may share memory by unspecified means. At a minimum, the backing memory for shared array buffers can be shared among the agents in the cluster. There may be agents that can communicate by message passing that cannot share memory. They are never in the same agent cluster. Note 2. The agents in a cluster need not all be alive at some particular point in time. If agent A creates another agent B, after which A terminates and B creates agent C, the three agents are in the same cluster if A could share some memory with B and B could share some memory with C. Note 3. If different agents within an agent cluster have different values of it becomes hard to use shared memory for multi-byte data. 62. Copyright sign. ECMA International 2024. Note 4. The purpose of the preceding restriction is to avoid a situation where an agent deadlocks or starves because another agent has been deactivated. For example, if an HTML shared worker that has a lifetime independent of documents in any windows were allowed to share memory with the dedicated worker of such an independent document, and the document and its dedicated worker were to be deactivated while the dedicated worker holds a lock, say, the document is pushed into its Windows history, and the shared worker then tries to acquire the lock, then the shared worker will be blocked until the dedicated worker is activated again, if ever. Meanwhile, other workers trying to access the shared worker from other windows will starve. The implication of the restriction is that it will not be possible to share memory between agents that don't belong to the same suspend-wake collective within the embedding. An embedding may terminate an agent without any of the agent's cluster's other agents' prior knowledge or cooperation. If an agent is terminated not by programmatic action of its own or of another agent in the cluster but by forces external to the cluster, then the embedding must choose one of two strategies: either terminate all the agents in the cluster, or provide reliable APIs that allow the agents in the cluster to coordinate so that at least one remaining member of the cluster will be able to detect the termination, with the termination data containing enough information to identify the agent that was terminated. Each of the following specification values, and values transitively reachable from them, belong to exactly one agent cluster. Candidate execution record, shared data block, waitlist record. Prior to any evaluation of any ECMAScript code by any agent I in a cluster, the field of the agent record for all agents in the cluster is set to the initial candidate execution. The initial candidate execution is an empty candidate execution whose field is a list containing, for each agent, an agent events record whose field is that agent's agent signifier, and whose fields are empty lists. Note 5 examples of that type of termination are operating systems or users terminating agents that are running in separate processes, the embedding itself terminating an agent that is running in process with the other agent's WinPer. Agent resource accounting indicates that the agent is runaway. Note 6. All agents in an agent cluster share the same candidate execution in its agent records field. The candidate execution is a specification mechanism used by the memory model. Note 7. An agent cluster is a specification mechanism and need not correspond to any particular artifact of an ECMAScript implementation. Point 9. Forward progress. For an agent to make forward progresses for it to perform an evaluation step according to this specification, an agent becomes blocked when its running execution context waits synchronously and indefinitely for an external event. Only agents whose agent records field is true can become blocked in this sense. An unblocked agent is one that is not blocked. Implementations must ensure that every unblocked agent with a dedicated executing thread eventually makes forward progress. In a set of agents that share an executing thread, one agent eventually makes forward progress. ECMA International 2024 163. An agent does not cause another agent to become blocked except via explicit APIs that provide blocking. Point 10. Processing model of weak ref and finalization registry targets 9.10. 1. Objectives. This specification does not make any guarantees that any object or symbol will be garbage collected. Objects or symbols which are not live may be released after long periods of time, or never at all. For this reason, this specification uses the term may when describing behavior triggered by garbage collection. The semantics of weak refs and finalization registries is based on two operations which happen at particular points in time. When weak ref prototype derf is called, the referent, if undefined is not returned, is kept alive so that subsequent synchronous accesses also return the same value. This list is reset when synchronous work is done using the clear-kept objects abstract operation. When an object or symbol which is registered with the finalization registry becomes unreachable, a call of the finalization registry's cleanup callback may eventually be made, after synchronous ECMAScript execution completes. The finalization registry cleanup is performed with the cleanup finalization registry abstract operation. Neither of these actions, clearcap, objects, or cleanup finalization registry, may interrupt synchronous ECMAScript execution. Because hosts may assemble longer, synchronous ECMAScript execution runs, the specification defers the scheduling of clear-kept objects and cleanup finalization registry to the host environment. Some ECMAScript implementations include garbage collector implementations which run in the background, including when ECMAScript is idle. Letting the host environment schedule cleanup finalization registry allows it to resume ECMAScript execution in order to run finalizer work, which may free up held values, reducing overall memory usage. 10.2 Liveness. For some set of objects and or symbols S, a hypothetical weak ref oblivious execution with respect to S is an execution whereby the abstract operation weak ref deriv of a weak ref whose referent is an element of S always returns undefined. This, along with the liveness guarantee in the memory model, ensures that all sec.cst writes note eventually become observable to all agents. Note 1 weak ref obliviousness, together with liveness, capture two notions. 1. That a weak ref itself does not keep its referent alive. 2. That cycles in liveness does not imply that a value is live. To be concrete, if determining V's liveness depends on determining the liveness of a weak ref referent, R's liveness cannot assume V's liveness, which would be circular reasoning. Note 2 weak ref obliviousness is defined on sets of objects or symbols instead of individual values to account for cycles. If it were defined on individual values, then a weak ref referent in a cycle will be considered live even though its identity is only observed via other weak ref referents in the cycle. Note 3 colloquially, we say that an individual object or symbol is live if every set containing it is live. At any point during evaluation, a set of objects and or symbols S is considered live if either of the following conditions is met. Any element in S is included in any agents list 164. ECMA International 2024. There exists a valid future hypothetical weak ref oblivious execution with respect to S that observes the identity of any value in S. Note 4 the second condition above intends to capture the intuition that a value is live if its identity is observable via non-weak ref means. A value's identity may be observed by observing a strict equality comparison or observing the value being used as key in a map. Note 5. Presence of an object or a symbol in a field, an internal slot, or a property does not imply that the value is live. For example, if the value in question is never passed back to the program, then it cannot be observed. This is the case for keys in a weak map, members of a weak set, as well as the infields of a finalization registry cell record. The above definition implies that, if a key in a weak map is not live, then its corresponding value is not necessarily live either. Note 6 liveness is the lower bound for guaranteeing which weak refs engines must not empty. Liveness is defined here as undecidable. In practice, engines use conservative approximations such as reachability. There is expected to be significant implementation leeway. 10.3 Execution. At any time, if a set of objects and or symbols S is not live, an ECMAScript implementation may perform the following steps atomically. For each element value of S, do a for each weak ref such that ref is value. Do I set ref to empty. B for each finalization registry FG such that FG contains a record cell such that cell is value. Do I set cell to empty. 2. Optionally, perform capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R F G. C for each weak map such that map contains a record R such that R value. Do I set R to set R to empty. D for each weak set such that set contains value. Do I replace the element of set whose value is value with an element whose value is empty. ECMA International 2024 165. Note 1. Together with the definition of liveness, this clause prescribes optimizations that an implementation may apply regarding weak refs. It is possible to access an object without observing its identity. Optimizations such as dead variable elimination and scalar replacement on properties of non-escaping objects whose identity is not observed are allowed. These optimizations are thus allowed to observably empty weak refs that point to such objects. On the other hand, if an object's identity is observable, and that object is in the internal slot of a weak ref, optimizations such as rematerialization that observably empty the weak ref are prohibited, because calling capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R, is optional. Registered objects in a finalization registry do not necessarily hold that finalization registry live. Implementations may omit finalization registry callbacks for any reason. For example, if the finalization registry itself becomes dead, or if the application is shutting down. Note 2. Implementations are not obligated to empty weak refs for maximal sets of non-live objects or symbols. If an implementation chooses a non-live set S in which to empty weak refs, this definition requires that it empties weak refs for all values in S simultaneously. In other words, it is not conformant for an implementation to empty a weak ref pointing to a value v without emptying out other weak refs that, if not emptied, could result in an execution that observes the value of v, 10.4 host hooks, 1041, capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R, finalization registry, the host-defined abstract operation, capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R, takes argument finalization registry, a finalization registry, and returns unused. Let cleanup job be a new job abstract CL Azure with no parameters that captures finalization registry and performs the following steps when called. Let cleanup result be completion, cleanup finalization registry, finalization registry. If cleanup result is an abrupt completion, perform any host-defined steps for reporting the error. Return unused. An implementation of capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R, schedules cleanup job to be performed at some future time, if possible. It must also conform to the requirements in 9.5.11 clear-kept objects. The abstract operation clear-kept objects takes no arguments and returns unused. ECMAScript implementations are expected to call clear-kept objects when a synchronous sequence of ECMAScript executions completes. It performs the following steps when called. Let agent record be the surrounding agent's agent record. Set agent record to a new empty list. Return unused. 66. ECMA International 2024. 9.12. Add to kept objects. Value. The abstract operation add to kept objects takes argument value, an object or a symbol, and returns unused. It performs the following steps when called. Let agent record be the surrounding agent's agent record. Append value to agent record. Return unused. 0.13. Cleanup finalization registry. Finalization registry. The abstract operation cleanup finalization registry takes argument finalization registry, a finalization registry, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Assert. Finalization registry hasn't internal slots. Let callback be finalization registry. While finalization registry contains a record cell such that cell is empty, an implementation may perform the following steps. A choose any such cell. B remove cell from finalization registry. C perform. Host call job callback. Callback. Undefined. Cell. Return unused. 0.14 can be held weekly. V. The abstract operation can be held weekly takes argument V, an ECMAScript language value, and returns a boolean. It returns true if and only if V is suitable for use as a weak reference. Only values that are suitable for use as a weak reference may be a key of a weak map, an element of a weak set, the target of a weak ref, or one of the targets of a finalization registry. It performs the following steps when called. If V is an object, return true. If V is a symbol and key for symbol, V is undefined, return true. Return false. Note when the abstract operation add to kept objects is called with a target, object, or symbol, it adds the target to a list that will point strongly at the target until clear kept objects is called. Note a language value without language identity can be manifested without prior reference and is unsuitable for use as a weak reference. A symbol value produced by symbol 4, unlike other symbol values, does not have language identity and is unsuitable for use as a weak reference. Well-known symbols are likely to never be collected, but are nonetheless treated as suitable for use as a weak reference because they are limited in number and therefore manageable by a variety of implementation approaches. However, any value associated to a well-known symbol in a live weak map is unlikely to be collected and could leak memory resources in implementations. 0. Ordinary and exotic objects behaviors. 0.1 Ordinary object internal methods and internal slots. All ordinary objects have an internal slot called. The value of this internal slot is either null or an object and is used for implementing inheritance. Assume a property named P is missing from an ordinary object O but exists on its object. If P refers to a data property on the object, O inherits it for get access, making it behave as if P was a property of O if P refers to a writable data property on the ECMA International 2024-167 object. Set access of P on O creates a new data property named P on O if P refers to a non-writable data property on the object. Set access of P on O fails. If P refers to an accessor property on the object, the accessor is inherited by O for both get access and set access. Every ordinary object has a Boolean valued internal slot which is used to fulfill the extensibility related internal method invariants specified in 6.1.7.3. Namely, once the value of an object's internal slot has been set to false, it is no longer possible to add properties to the object, to modify the value of the object's internal slot, or to subsequently change the value of to true. In the following algorithm descriptions, assume O is an ordinary object, P is a property key value, V is any ECMAScript language value, and ESC is a property descriptor record. Each ordinary object internal method delegates to a similarly named abstract operation. If such an abstract operation depends on another internal method, then the internal method is invoked on O rather than calling the similarly named abstract operation directly. These semantics ensure that exotic objects have their overridden internal methods invoked when ordinary object internal methods are applied to them. 0, 1, 1. The internal method of an ordinary object O takes no arguments and returns a normal completion containing either an object or null. It performs the following steps when called. Return ordinary get prototype of O10. 1, 1. One ordinary get prototype of O. The abstract operation ordinary get prototype of takes argument O, an object, and returns an object or null. It performs the following steps when called. Return O10, 1, 2. V. The internal method of an ordinary object O takes argument V, an object or null, and returns a normal completion containing a Boolean. It performs the following steps when called. Return ordinary set prototype of O, V10, 1, 2, 1 ordinary set prototype of O, V. The abstract operation ordinary set prototype of takes arguments O, an object, and V, an object or null, and returns a boolean. It performs the following steps when called. Let current be O if same value, v, current, is true, return true. Let extensible be O if extensible is false, return false. Let bev, let done be false, repeat. While done is false.
That's interesting. Okay, so as chatbot, and I don't want to make a loop. I think it's an average. And I don't want to like merge the timers. So the the get system precise as file time. It's not very accurate. And then getting the CPU cycle count that's not even related to time. So I have to get both. I have to get the time that's not very accurate. And there's no way I can get it without like hijacking the OS. And it's gonna like trip a bunch of stuff. So chatbot said to put like, so right now I have the get system as file time whatever, because that way you'll enter, this is gonna be tied, I don't know, I feel like it's gonna be bogged down, so it'll bog it down. This CPU ID is probably a faster instruction, so when it runs inside between this get system time or precise file time and get this precise file time, it seems like the better option because this is going to have less overhead between the two. But then I got to call to get the cycle count again at some point. But if I put it after this get precise file time, then I feel like this is gonna like lock it up. It's probably a heavy duty call. And it's gonna like click this timer in after it when I call to get the cycles after like some certain amount of work has been done. So chatbot said to wrap. It kind of makes sense, I guess. I didn't want to have like a whole bunch of counters. But this sounds like the better option. So I'll like get the CPU cycle count before and after the get system precise as file time. And then I can subtract the end from the start before and after. I'll just like paste it in place. So like this is called get the CPU cycles. This is called after to the CPU cycles. I'll call it in between. the CPU cycles before the get system time precise file time. And so call it to get the CPU clock cycles after the get system time precise file time. So we'll do this here. This whole thing, whatever, right here. I'll also do it before. And then I can take the cycle count here and here, subtract them. So end minus start. The variable's too long. So I'll get the end minus start here, where I called it before and after outside of get precise file time. And then I'll have separate counters down here before and after. So like these are like a secondary count or whatever to track the time before and after this one. And I'll subtract these two from each other, divided by 2. And that's actually about as accurate to an average as we'll get. Because the get system persists as file time. It's like if the ticks are like uneven, the OS whatever tries to like smooth it out. So since the OS is trying to smooth it out, if I get the cycle times like before, like if this is before, like right here, I don't know, it doesn't matter, just at some point. So like if this is like precise file time, whatever, the granularity is bigger because it's not as accurate. It's like it's like 10 to 15 millisecond accuracy or something. It's not accurate. So it's like a very large granularity. So there's less ticks, whatever. The cycle count has more ticks, as you can see here, but they're not related to time itself, which is annoying as hell. So they're really not the same fucking thing. And you can make up a number and merge them together to make a fake time that's still not time. So I'm gonna do this for now. So I don't know. I'm gonna do this like as a solution for now. I'll keep the 2 times separate, and I'll think about some way to like creatively merge them together to make like a uniform time or something. So like if this is like cycle count, So if this is where cycle count start is at, this is CPU cycle count end. Then it's going to get a higher granularity. I need to drink some water. See how there's like 1, 2, 3, 4, 5, like 7, 8 ticks compared to the precise time, which only has like 4 ticks. So the precise time would happen maybe like right here. I'll get this like once. So like just magically lined up. So if this is a cycle time start, the code would be run in the middle here. Benchmark, whatever. Okay, so this is start end, and that's what's going to be subtracted up here at the beginning, these 2 points. Get precise, file time, whatever, it's called between. So I'm adding up these two, dividing by 2 to get somewhere between here, which is somewhere where file time start was called. And then this way I have file time start. I guess technically it's an accurate quote time, even though it's not high precision, it's supposed to be accurate. I don't believe either, but it's close enough. So the precise time, file time, whatever, if there's 1, 2, 3, maybe like 7 ticks between where cycle start, cycle end is called, and cycle start, cycle end. I don't know. This seems like a actually good solution. And I could like lazily divide the cycle count by the precise file time, but I had to figure out some kind of base unit to base it off of. Because this is real time, this is not real time, if that makes sense. So now I'll be able to get like the real time. It's not going to be the most precise because it's the granularity sucks, but I can also get this fake time of CPU cycles that has nothing to do with real time. I'll probably merge them later to make like a pseudo time or artificial time, whatever you would call it. I don't know. I think that's my plan. So I'm like, throw this together, run some code, and I don't know. This is better than running several test loops and trying to like find the average. Because I could run several test loops for precise file time, whatever, and it's gonna be extremely granular and not accurate. So like running multiple loops to like try to find the static isn't even gonna be possible because the timer is so granular that you can't detect that kind of like fine tuning. And if you fine tune that, it's not even fine tuned because it's only fine tuned to the granularity of the precision or whatever, which is very low. So, this is my plan. So I'm gonna try to get started on that, whatever. And then, I don't think it'll take too long. Then I'll be able to test some stupid assembly and get some kind of like guesstimation of what's faster or slower. I'll probably have to make an artificial time from the precise file time that's like freaking shit time and the cycle count or whatever, the CPU cycles timestamp. So I don't know, I'm gonna just work on this, I guess. Possibly be able to test something. I think I need to just add a couple counters and then make sure they're being printed. That's about it. At least I don't have to use. I don't know. I'm gonna get started. Stop stalling. I thought through a whole bunch of ways. This is the best it's gonna get. And it's not even close to what I want. But I'm gonna just settle. Because getting an average tends to be like the worst way. But if it's like before and after the point, that's about as good as it can get. It's 50-50. Just divide that by 2. I don't know. This might actually work really good. If not, I'll have to come up with like a better way, whatever. Something more complicated. I want to try to keep it simple because everything always ends up complicated because nothing, like even getting the time, you can't even get the time at a simple level. So everything gets so fucking complicated. So I'm gonna try to focus, whatever. And then benchmark some shit. If I can get done, then I'll run speed tests or whatever. On something. Which would be better than nothing. And I'll play Siri. I don't know why. What's up with the sound? But things just keep crashing lately. It can't be the CPU. Something on the motherboard might be dying though. So until it dies, it's working for now. Which is however long it is until it stops working.
Be a new abstract closure with no parameters that captures name and env and performs the following steps when called. A return env get binding value. Name. False. Let getter be create built-in function. Getter closure. 0. Note. Getter is never directly accessible to ECMAScript code. Return getter. 0. 4. 4. 7. To make arg setter. Name. env. The abstract operation make arg setter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed sets the value bound for name and env. It performs the following steps when called. Let set a closure be a new abstract closure with parameters, value, that captures name and env and performs the following steps when called. A return env set mutable binding. Name. Value. False. Let setter be create built-in function. Setter closure. 1. Note. Setter is never directly accessible to ECMAScript code. Return setter. 0. 4. 5. Typed array exotic objects. A typed array is an exotic object that performs special handling of integer index property keys. Typed arrays have the same internal slots as ordinary objects and additionally length and internal slots. An object is a typed array if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by typed array create 0, 4, 5, 1. P. The internal method of a typed array O takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Then I let value be typed array get element. Oh, numeric index 2. If value is undefined, return undefined. 3. Return the property descriptor value true, true, true. Return ordinary get own property. O. P. ECMA International 2024 195 10 4 5 2. P. The internal method of a typed array O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Return as valid integer index. O. Numeric index. Return. Ordinary has property O. P 0, 4, 5, 3. P. Desk. The internal method of a typed array O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Then if is valid integer index. O. Numeric index is false. Return false. 2. If desk has a field and desk is false, return false. 3. If desk has an field and desk is false, return false. 5. If is access a descriptor, desk, is true, return false. V. If desk has a field and desk is false, return false. V. If desk has a field, perform. Typed array set element. Oh. Numeric index. Desk. 7. Return true. Return. Ordinary define own property. O. P. Desk. 0, 4, 5, 4. The. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Then I return typed array get element. Oh. Numeric index 2. Return. Ordinary get. O. P, receiver 0, 4, 5, 5. If P is a string, then a let numeric index be canonical numeric index string, P, B. If numeric index is not undefined, then I have same value, O, receiver, is true, then perform. Typed array set element, O, numeric int x, V, return true 2. If is valid integer index, O, numeric int x, is false, return true, return. Ordinary set, O, P, V, receiver, 96, ECMA International 2024, 10456, P, the internal method of a typed array, O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string, P, B. If numeric index is not undefined, then if is valid integer index, O, numeric int x, is false, return true, else return false 2. Return. Ordinary delete, O, P, 0, 4, 5, 7. The internal method of a typed array, O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let tar record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, A, Y, capital W, I, T, H, capital B, U, F, E, R, capital W, I, T, N, E, S, O, sexy ST. Let keys be a new empty list. If it's typed array out of bounds, tar record is false. Then a let length be typed array length. Tar record be for each integer I such that 0 length. In ascending order, do I append to string I to keys for each O, W n property key P of O such that P is a string and P is not an integer index. In ascending chronological order of property creation, do I append P to keys for each own property key P of O such that P is a symbol. In ascending chronological order of property creation, do I append P to keys 6. Return keys 0, 4, 5, 8. Typed array with buffer witness records. And typed array with buffer witness record is a record value used to encapsulate a typed array along with a cached byte length of the viewed buffer. It is used to help ensure there is a single shared memory read event of the byte length data block when the viewed buffer is a growable shared array buffer. Typed array with buffer witness records have the fields listed in Table 32. Table 32. Typed array with buffer witness record fields 0, 4, 5, 9. Capital M, A, K, E, capital T, Y, P, E, D, capital A, R, A, Y, capital W, I, T, H, capital B, U, F, E, R, capital W, I, T, N, E, S, obj. Order. The abstract operation, capital M, A, K, E, capital T, Y, P, E, D, capital A, R, A, Y, capital W, I, T, H, capital B, U, F, E, R, capital W, I, T, N, E, S, takes arguments obj, a typed array, and order, sexy st or unordered, and returns a typed array with buffer witness record. It performs the following steps when called. Let buffer be obj. If is detached buffer is true, then a let byte length be detached. Field name, value, meaning, object, a typed array, the typed array whose buffer's byte length is loaded. Cached buffer byte length, a non-negative integer or detached. The byte length of the objects when the record was created. Copyright sign, ECMA International 2024 197. 3. Else, a let byte length be array buffer byte length. Buffer, order. Return the typed array with buffer witness record. OBJ, byte length 0, 4, 5, 1, 0 typed array create. Prototype. The abstract operation typed array create takes argument prototype, an object, and returns a typed array. It is used to specify the creation of new typed arrays. It performs the following steps when called. Let internal slots list be. Let A be make basic object. Internal slots list. Set A is specified in 1, 0, 4, 5, 1. Set A is specified in 1, 0, 4, 5, 2. Set A is specified in 1, 0, 4, 5, 3. Set A is specified in 1, 0, 4, 5, 6. Set A is specified in 1, 0, 4, 5, 7, 0. Set A to prototype 1. Return A 0, 4, 5, 1, 1 typed array byte length. Tar record. The abstract operation typed array byte length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. If this typed array out of bounds, tar record, is true, return 0. Let length be typed array length, tar record. If length equals 0, return 0. Let O be tar record. If O GTH is not auto, return no. Let element size be typed array element size. O. Return length element size 0, 4, 5, 1, 2 typed array length. Tar record. The abstract operation typed array length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. Assert. Is typed array out of bounds. Tar record. Is false. Let O be tar record. If O is not auto, return no. Assert. Is fixed length array buffer. O is false. Let byte offset be O. Let element size be typed array element size. O. Let byte length be tar record. Assert. Byte length is not detached. Return floor. Byte length. Byte offset. Element size 0, 4, 5, 1, 3 is typed array out of bounds. Tar record. The abstract operation is typed array out of bounds takes argument tar record, a typed array with buffer witness record, and returns a boolean. It checks if any of the object's numeric properties reference a value at an index not contained within the underlying buffer's bounds. It performs the following steps when called. 2. Let O be tar record. Let buffer byte length be tar record. 98. ECMA International 2024. 3. Assert. Is detached buffer. O. Is true if and only if buffer byte length is detached. If buffer byte length is detached, return true. Let byte offset start be O. If O is auto, then a let byte offset end be buffer byte length. Else, a let element size be typed array element size. O. Be let byte offset end be byte offset start plus O element size. If byte offset start, buffer byte length or byte offset end, buffer byte length, return true. Note: 0 length typed arrays are not considered out of bounds. 0. Return false. 0, 4, 5, 1, 4 is valid integer index. O. Index. The abstract operation is valid integer index takes arguments O, a typed array, and an x, a number, and returns a boolean. It performs the following steps when called. If is detached buffer, O, is true, return false. If is integral number, int x, is false, return false. If index is -0, return false. Let tar record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, unordered. Note: bounds checking is not a synchronizing operation when O's backing buffer is a growable shared array buffer. If this typed array out of bounds, tar record, is true, return false. Let length be typed array length, tar record. If R, int x, 0 or R, int x, length, return false. Return true. 0, 4, 5, 15 typed array get element. O. Index. The abstract operation typed array get element takes arguments O, a typed array, and index, a number, and returns a number, a big int, or undefined. It performs the following steps when called. If as valid integer index, O, int x, is false, return undefined. Let offset be O, set. Let element size be typed array element size, O. Let byte index in buffer be R, int x, element size plus offset. Let element type be typed array element type, O. Return get value from buffer, O. Byte index in buffer, element type, true, unordered, 0, 4, 5, 1, 6 typed array set element, O. Int x, value. The abstract operation typed array set element takes arguments O, a typed array, int x, a number, and value, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If O is bigint, let num value be to big int, value. Otherwise, let num value be to number, value. If as valid integer index, O, int x, is true, then a let offset be O, b let element size be typed array element size, O. C let byte index in buffer be R, int x, element size plus offset. D let element type be typed array element type, O. E perform set value in buffer, O. Byte index in buffer, element type, num value, true, unordered, return unused. ECMA International 2024 199 10 4 5 17 is array buffer view out of bounds. O. The abstract operation is array buffer view out of bounds takes argument O, a typed array or a data view, and returns a boolean. It checks if either any of a typed array's numeric properties or a data view object's methods can reference a value at an index not contained within the underlying data block's bounds. This abstract operation exists as a convenience for upstream specifications. It performs the following steps when called. If O has an internal slot, then a let view record be capital M A K E capital D A T A capital V I E W capital W I T H capital B U F F E R capital W I T N E S S capital R O sexy S T B return as view out of bounds, view record. Let tar record be capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O sexy ST return is typed array out of bounds. Tar record 0 4 6 module namespace exotic objects. A module namespace exotic object is an exotic object that exposes the bindings exported from an ECMAScript module. C16 2 3. There is a one-to-one correspondence between the string keydown properties of a module namespace exotic object and the binding names exported by the module. The exported bindings include any bindings that are indirectly exported using export items. Each string valued own property key is the string value of the corresponding exported binding name. These are the only string keyed properties of a module namespace exotic object. Each such property has the attributes true, true, false. Module namespace exotic objects are not extensible. An object is a module namespace exotic object if its and internal methods use the definitions in this section, and its other essential internal methods use THE definitions found in 10.1. These methods are installed by module namespace create. Module namespace exotic objects have the internal slots defined in Table 33. Table 33 Internal slots of module namespace exotic objects. Internal slot. Type. Description. Module. A. Module record. The module record whose exports this namespace exposes. Exports. A list of strings. A list whose elements are the string values of the exported names exposed as own properties of this object. The list is ordered as if an array of those string values had been sorted using %array prototype sort % using undefined as compare fn 1 0 4 6 1. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing null. It performs the following steps when called. Return null. 00 ECMA International 2024. Note this operation always appears to succeed, but it has no effect when attempting to write past the end of a typed array or to a typed array which is backed by a detached array buffer. 1 0 4 6 2. V. The internal method of a module namespace exotic object O takes argument V, an object or null, and returns a normal completion containing a boolean. It performs the following steps when called. 1. Return. Set immutable prototype O. V 0 4 6 3. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing false. It performs the following steps when called. Return false. 0 4 6 4. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing true. It performs the following steps when called. Return true. 0 4 6 5. P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. If P is a symbol, return ordinary get own property O. P. Let exports be O. If exports does not contain P, return undefined. Let value be O. Return property descriptor value true, true, false. 0 4 6 6. P. Desk. The internal method of a module namespace exotic object O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a symbol, return ordinary define own property O. P. Desk. Let current be O. P. If current is undefined, return false. If desk has a field and desk E is true, return false. If desk has an field and desk is false, return false. If is accessor descriptor desk is true, return false. If desk has a field and desk is false, return false. If desk has a field, return same value, desk. Current. Return true. 0 4 6 7. P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a symbol, return ordinary has property O. P. Let exports be O. If exports contains P, return true. Return false. ECMA International 2024 201 1 0 4 6 8. The. If P is a symbol, then a return ordinary get O. P. Receiver. Let exports be O. If exports does not contain P, return undefined. Let M be O. Let binding be M. Resolve export P. Assert. Binding is a resolved binding record. Let target module be binding. Assert. Target module is not undefined. If binding is namespace, then a return get module namespace. Target module 0. Let target env be target module 1. If target env is empty, throw a reference error exception. 2. Return target env get binding value. Binding true 0 4 6 9. The return false 1 0 4 6 1 0. P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a symbol, then a return ordinary delete O. P. Let exports be O. If exports contains P, return false. Return true. 0, 4, 6, 1, 1. The internal method of a module namespace exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let exports be O. Let symbol keys be ordinary own property keys. O. Return the list concatenation of exports and symbol keys. Note resolve export is side effect free. Each time this operation is called with a specific export name, resolve set pairs arguments, it must return the same result. An implementation might choose to pre-compute or cache the resolve export results for the of each module namespace exotic object. 02 ECMA International 2024 104612 module namespace create module exports. The abstract operation module namespace create takes arguments module, a module record, and exports a list of strings and returns a module namespace exotic object. It is used to specify the creation of new module namespace exotic objects. It performs the following steps when called. Assert module is empty. Let internal slots list be the internal slots listed in table 33. Let m be make basic object internal slots list. Set m's essential internal methods to the definitions specified in 1046. Set m to module. Let sorted exports be a list whose elements are the elements of exports ordered as if an array of the same values had been sorted using %array prototype sort % using undefined as compare n. Set m to sorted exports. Create own properties of n corresponding to the definitions in 28.3. Set module to m 0. Return m 0, 4, 7 immutable prototype exotic objects. An immutable prototype exotic object is an exotic object that has an internal slot that will not change once it is initialized. An object is an immutable prototype exotic object if its internal method uses the following implementation. Its other essential internal methods may use any implementation, depending on the specific immutable prototype exotic object in question. 0, 4, 7, 1. V. The internal method of an immutable prototype exotic object O takes argument v, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return set immutable prototype O v10 4 7 to set immutable prototype O v. The abstract operation set immutable prototype takes arguments O, an object, and v, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let current be O if same value, v, current, is true, return false. 0.5 Proxy object internal methods and internal slots. A proxy object is an exotic object whose essential internal methods are partially implemented using ECMAScript code. Every proxy object has an internal slot called the value of as an object, called the proxy's handler object, or null. Methods, see table 34, of a handler object may be used to augment the implementation for one or more of the proxy object's internal methods. Every proxy object also has an internal. Note, unlike other exotic objects, there is not a dedicated creation abstract operation provided for immutable prototype exotic objects. This is because they are only used by %object, prototype % and by host environments. And in host environments, the relevant objects are potentially exotic in other ways and thus need their own dedicated creation operation. ECMA International 2024 203. Slot called whose value is either an object or the null value. This object is called the proxy's target object. An object is a proxy exotic object if its essential internal methods, including and, if applicable, use the definitions in this section. These internal methods are installed in proxy create, table 34. proxy handler methods. Internal method, handler method, get prototype of, set prototype of, is extensible, prevent extensions, get own property descriptor, define own property, has, get, set, delete property, own property keys, call, apply, construct. When a handler method is called to provide the implementation of a proxy object internal method, the handler method is passed the proxy's target object as a parameter. A proxy's handler object does not necessarily have a method corresponding to every essential internal method. Invoking an internal method on the proxy results in the invocation of the corresponding internal method on the proxy's target object if the handler object does not have a method corresponding to the internal trap. The and internal slots of a proxy object are always initialized when the object is created and typically may not be modified. Some proxy objects are created in a manner that permits them to be subsequently revoked. When a proxy is revoked, its and internal slots are set to null, causing subsequent invocations of internal methods on that proxy object to throw a type error exception. Because proxy objects permit the implementation of internal methods to be provided by arbitrary ECMAScript code, it is possible to define a proxy object whose handler methods violates the invariants defined in 6.1.7.3. Some of the internal method invariants defined in 6.1.7.3 are essential integrity invariants. These invariants are explicitly enforced by the proxy object internal methods specified in this section. An ECMAScript implementation must be robust in the presence of all possible invariant violations. In the following algorithm descriptions, assume O is an ECMAScript proxy object. P is a property key value. V is any ECMAScript language value and desc is a property descriptor record. O for copyright sign. ECMA International 2024 1051. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing either an object or null, or a throw completion. It performs the following steps when called. Perform. Validate non-rev. Opt proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get prototype of. If trap is undefined, then a return target. Let handler proto be. Call. Trap. Handler. Target. If handler proto is not an object and handler proto is not null, throw a type error exception. Let extensible target be. Is extensible. Target 0. If extensible target is true, return handler proto 1. Let target proto be target 2. If same value, handler proto, target proto, is false, throw a type error exception 3. Return handler proto 0, 5, 2. V. The internal method of a proxy exotic object O takes argument V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoked proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set prototype of. If trap is undefined, then a return target. V. Let boolean trap result be to boolean. Call. Trap. Handler. Target. V. If boolean trap result is false, return false. Let extensible target be. Is extensible. Target 0. If extensible target is true, return true 1. Let target proto be target 2. If same value, V, target proto, is false, throw a type error exception 3. Return true. Note for proxy objects enforces the following invariants. The result of must be either an object or null. If the target object is not extensible, applied to the proxy object must return the same value as applied to the proxy object's target object. Note for proxy objects enforces the following invariants. The result of is a boolean value. If the target object is not extensible, the argument value must be the same as the result of get prototype of applied to target object. ECMA International 2024 205 1053. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler is extensible. If trap is undefined, then a return is extensible. Target. Let boolean trap result be to boolean. Call. Trap. Handler. Target. Let target result be is extensible. Target. If boolean trap result is not target result, throw a type error exception 0. Return boolean trap result 0, 5, 4. End extensions. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Prevent extensions. If trap is undefined, then a return target. Let boolean trap result be to boolean. Call. Trap. Handler. Target. If boolean trap result is true, then a let extensible target be is extensible. Target B. If extensible target is true, throw a type error exception. Return boolean trap result 0, 5, 5, p. The internal method of a proxy exotic object O takes argument p, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. Note for proxy objects enforces the following invariants. The result of is a boolean value. Applied to the proxy object must return the same value as. Applied to the proxy object's target object with the same argument. Note for proxy objects enforces the following invariants. The result of is a boolean value. Applied to the proxy object only returns true if applied to the proxy object's target object is false. 2. Perform. Validate non-revoke proxy O. Let target be O. 06. ECMA International 2024. 3. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get own property descriptor. If trap is undefined, then a return target. P. Let trap result obj be. Call. Trap. Handler. Target. P. If trap result obj is not an object and trap result obj is not undefined, throw a type error exception. Let target desk be target. P. 0. If trap result obj is undefined, then A. If target desk is undefined, return undefined. B. If target desk is false, throw a type error exception. C. Let extensible target be is extensible. Target D. If extensible target is false, throw a type error exception. E. Return undefined. 1. Let extensible target be is extensible. Target 2. Let result desk be to property descriptor. Trap result obj 3. Perform complete property descriptor. Result desk 4. Let valid be as compatible property descriptor. Extensible target. Result desk. Target desk 5. If valid is false, throw a type error exception. 6. If result desk is false, then if target desk is undefined or target desk is true, then I throw a type error exception. B. If result desk has a field and result desk is false, then I assert target desk has a field. 2. If target desk is true, throw a type error exception. 7. Return result desk. Note for proxy objects enforces the following invariants. The result of must be either an object or undefined. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of a non-extensible target object. A property cannot be reported as existent if it does not exist as an own property of the target object and the target object is not extensible. A property cannot be reported as non-configurable unless it exists as a non-configurable own property of the target object. A property cannot be reported as both non-configurable and non-writable unless it exists as a non-configurable, non-writable own property of the target object. 0, 5, 6, p. Desk The internal method of a proxy exotic object O takes arguments P, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Define property. If trap is undefined, then a return target. P. Desc. Let desc obj be from property descriptor. Desc. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. Desc obj. If boolean trap result is false, return false. 0. Let target desc be target. P. ECMA International 2024 207. 11. Let extensible target be. Is extensible. Target. 2. If desc has a field and desc is false, then a let setting config false be true. 13. Else a let setting config false be false. 4. If target desc is undefined, then A. If extensible target is false, throw a type error exception. B. If setting config false is true, throw a type error exception. 5. Else A. If is compatible property descriptor, extensible target, desc, target desc, is false, throw a type error exception. B. If setting config false is true and target desc is true, throw a type error exception. C. If is data descriptor, target desc, is true, target desc is false, and target desc is true, then I. If desc has a field and desc is false, throw a type error exception. 6. Return true. Note for proxy objects enforces the following invariants. The result of is a boolean value. A property cannot be added if the target object is not extensible. A property car not be non-configurable unless there exists a corresponding non-configurable own property of the target object. A non-configurable property cannot be non-writable unless there exists a corresponding non-configurable non-writable own property of the target object. If a property has a corresponding target object property, then applying the property descriptor of the property to the target object using will not throw an exception. 0, 5, 7. P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler has. If trap is undefined, then a return.
So, I have like a plan, whatever, to get some kind of like timing. And
is false. Throw a type error exception. 2. Let extensible target be.
I split up the timers, whatever, so it's like A, the B's in the middle, then CC, then B's in the middle. So both A timers relate to before, both the B relate to after, and then the C timer, or the C timer is after, and then B is taken once before and once after, and that's the wall clock.
Target object, and the target object is not extended.
And then the wall clock seems to like
Validate non-revoke proxy O. Let target be O. Let
it's so inaccurate that it says 2 right here. Sometimes it says 1, then it says 2, this is 3, but it's usually 2. It says 1
P. Receiver. Let target
if there's only one call to get the timestamp. When I put 2 of them in here, the count went up to 2. And it hovers at 2. So this this wall clock, this gets it system time, precision, precise, that's valid time. What kind of name even is that? Get system time, precise, as file time. Is it this broken English? But even at least I don't care about spelling. But at least I can like normally. I don't care really. It doesn't matter. Who cares? It doesn't matter because it's still a Windows call and it still sucks dick. Because that's what Windows does. That's why Windows updates never fix anything. Because they just send new wallpapers and they're busy sucking dick. Windows. Anyways.
Point and target desk is false. Then
I have to make a macro to expand and make all of the variables for the counters. I have to make another macro for the start and end timestamp. So this has to be wrapped in a macro, and I have to give it a tag. So I have to tag it as like option John's code, option MSVC for Visual Studio,
target object property is an
option GNU or Clang, option chatbot. I don't know. I have to like tag it like that so all the counters will be labeled and stuff, and I can like easily just print the data. Then I also need to support an instance count. So I need to have like 1, 2, however many I need. So luckily I can print lists now. And I can make like a new list like really easy. Super simple. So I can like easily just throw everything into place and get it running. Because if I have something like in Visual Studio and there's like 2, 3 code outputs I want to compare, they'll need 2, 3 instances of this.
desk is false. Throw a type error exception. Let extensible target be. Is extensible target 3? If extensible target is false.
And I can't type this up every time. Take forever.
True. Note for proxy objects enforces the following.
So if I want to like compare Visual Studio output 1 versus Visual Studio output 2,
Not be reported as deleted if it exists as a known property of the target object and the target object is non-extensible. 0, 5, 1, 1.
like the assembly, whatever.
The proxy exotic object O takes no arguments and returns either in.
So if Visual Studio makes different outputs, I need to compare them. I need to have multiple lists printed or whatever. It's the window.
Trap B. Get method. Handler. Own keys. 10. ECMA International 2000.
And all this stuff takes fucking time.
Let trap result.
Long enough to just type up 1 and 2. So I need a macro
Trap result.
that will define and auto name it and then make it loop to make how many I need. And then have it also
Get 1. Let target keys be.
make like a loop that holds the loops to print like Visual Studio test 1, test 2, test 3, and like a sub list or whatever. And then I can like open the exe, it'll run. All the benchmarks will be right there. Super simple. I can just test whatever I need to test.
Target non-configurable keys.
And I can change one number.
If extensible target is true and target non-configurable keys is empty.
To like pick how many I need, and the macro will expand to define however many, and I can like, if I need to test another compiler, I just change the name. I don't know. This is so much better than C language. C language sucks.
0.
Sucks just as much as Windows.
Return trap result. 1. For each element key,
I don't have to get into like what it sucks, because we all know it's a dick.
error exception, be removed key from unchecked result keys. 2. If
That's why it's called Microsoft. Bunch of micro softies.
for proxy objects enforces the following invariance. The result of is a list. The returned list can
Yeah, okay, I'm done.
the result list must contain the keys of all non-config.
So, all that's gonna require time. And this stream is gonna run out eventually. And Windows can't even give you the accurate fucking time. I think it's on purpose. Because if they gave accurate time, things would like... It doesn't matter, whatever. Windows sucks though.
Script language value or a throw completion. It performs the following steps. Cool.
So this runs right now still. So I'm gonna like save it while I'm ahead. Break something. Before I break something.
Get method. Handler. Apply. If trap is undefined, then a return. Call.
Dang it, I broke something. Oh no, I didn't. It's because it's open.
Arguments list. Return. Call.
I'll just delete them and run it again.
Target. This argument. Array. Note a proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. ECMA International 2024 211. The 10th of May 2013. Arguments list. New target. The internal method of a proxy exotic object O takes arguments list. A list of ECMAScript language values. A new target. A constructor. And returns either a normal.
I don't know. Everything looks okay. I'm gonna save everything. Continue on tomorrow. It's gonna take an hour or so to make these stupid timer macros.
True. Let handler be O. Assert. Handler is an object.
But then I can finally benchmark shit.
Trap is undefined. Then a return. Construct.
So
Create array from list. Arguments list. Let new obj be. Call. Trap. Handler. Target. Array. New target. 0. If new obj is not an object, throw a type error exception. 1. Return new obj.
I'm done for now. And then I don't know. If I keep going, I'll mess something up. So peace. I'm gonna let the stream run on for 10 more minutes. Because it doesn't always send. Yada yada. Add something else. It can wait till tomorrow.
It throws a type error exception if proxy has been revoked. It performs the following steps when called. If proxy is null, throw a type error exception. Assert. Proxy is not null. Return unused. 0, 5, 1, 5 proxy create. Target. Handler. The abstract operation proxy create takes arguments target, an ECMAScript language value, and handler, an ECMAScript language value, and returns either a normal completion containing a proxy exotic object or a throw completion. It is used to specify the creation of new proxy objects. It performs the following steps when called. If target is not an object, throw a type error exception. If handler is not an object, throw a type error exception. Let P be make basic object. Set P's essential internal methods, except friend, to the definitions specified in 10.5. If is callable, target, is true, then A set P is specified in the 10th of May 2012. B if is constructor, target, is true, then I set P is specified in the 10th of May 2013. Set P to target. Set P to handler. Return P. 12. ECMA International 2024. Note 1. A proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. 11. ECMAScript language. Source text. 1.1 Source text syntax. Source character. Any Unicode code point. ECMAScript source text is a sequence of Unicode code points. All Unicode code point values from U plus 0000 to U plus 10FF, including surrogate code points, may occur in ECMAScript source text where permitted by the ECMAScript grammars. The actual encodings used to store and interchange ECMAScript source text is not relevant to this specification. Regardless of the external source text encoding, a conforming ECMAScript implementation processes the source text as if it was an equivalent sequence of source character values, each source character being a Unicode code point. Conforming ECMAScript implementations are not required to perform any normalization of source text, or behave as though they were performing normalization of source text. The components of a combining character sequence are treated as individual Unicode code points even though a user might think of the whole sequence as a single character. Note in string literals, regular expression literals, template literals and identifiers, any Unicode code point may also be expressed using Unicode escape sequences that explicitly express a code point's numeric value. Within a comment, such an escape sequence is effectively ignored as part of the comment. ECMAScript differs from the Java programming language in the behavior of Unicode escape sequences. In a Java program, if the Unicode escape sequence U000, for example, occurs within a single line comment, it is interpreted as a line terminator. Unicode code point U plus 000A is line feed, LF, and therefore the next code point is not part of the comment. Similarly, if the Unicode escape sequence U000A occurs within a string literal in a Java program, it is likewise interpreted as a line terminator, which is not allowed within a string literal. One must write N instead of U000A to cause a line feed, LF, to be part of the string value of a string literal. In an ECMAScript program, a Unicode escape sequence occurring within a comment is never interpreted and therefore cannot contribute to termination of the comment. Similarly, a Unicode escape sequence occurring within a string literal in an ECMAScript program always contributes to the literal and is never interpreted as a line terminator or as a code point that might terminate the string literal. 1 static semantics, UTF-16 encode code point, CP. The abstract operation UTF-16 encode code point takes argument CP, a Unicode code point, and returns a string. It performs the following steps when called. Assert 0 CP0 times 10FF. If CP0 XFF, return the string value consisting of the code unit whose numeric value is CP. Let CP1 be the code unit whose numeric value is floor. CP0 times 10,000. 0 times 400 plus 0 XD800. Let CP2 be the code unit whose numeric value is CP0 times 10,000. Modulo 0 times 400 plus 0 XDC00. Return the string concatenation of CP1 and CP2. ECMA International 2024 213. 1 2 static semantics. Code points to string text. The abstract operation code points to string takes argument text, a sequence of Unicode code points, and returns a string. It converts text into a string value, as described in 6.1.4. It performs the following steps when called. Let result be the empty string. For each code point CP of text, do a set result to the string concatenation of result and UTF-16 encode code point, CP3. Return result. 1 3 static semantics, UTF-16 surrogate pair to code point, led, trail. The abstract operation UTF-16 surrogate pair to code point takes arguments led a code unit, and trail, a code unit, and returns a code point. Two code units that form a UTF-16 surrogate pair are converted to a code point. It performs the following steps when called. Assert. Led is a leading surrogate and trail is a trailing surrogate. Let CP be led 0 XD800. 0 times 400 plus trail 0 XDC00 plus 0 times 10,000. Return the code point CP. 1 4 static semantics. Code point at string position. The abstract operation code pointer takes argument string, a string, and position, a non-negative integer, and returns a record with fields, a code point, a positive integer, and A Boolean. It interprets string as a sequence of UTF-16 encoded code points, as described in 6, 1, 4, and reads from it a single code point starting with the code unit at index position. It performs the following steps when called. Let size be the length of string. Assert. Position 0 and position size. Let first be the code unit at index position within string. Let CP be the code point whose numeric value is the numeric value of first. If a first is neither a leading surrogate nor a trailing surrogate, then return the record CP 1 full 6. If a first is a trailing surrogate or position plus 1 equals size, then return the record CP 1 true. Let second be the code unit at index position plus 1 within string. If second is not a trailing surrogate, then return the record CP 1 true. Set CP to UTF-16 surrogate pair to code point first, second 0. Return the record CP 2 false 1 1. 5 static semantics. String to code points. String. The abstract operation string to code points takes argument string, a string, and returns a list of code points. It returns the sequence of Unicode code points that results from interpreting string as UTF-16 encoded Unicode text as described in 6, 1, 4. It performs the following steps when called. Let code points be a new empty list. Let size be the length of string. Let position be 0. Repeat. While position size. Let CP be code point at string position. B append CP to code points. C set position to position plus CP. Return code points. 14. ECMA International 2024. 111. 6 static semantics. Parse text. Source text. Goal symbol. The abstract operation parse text takes argument source text, a sequence of Unicode code points.